Hi, I'm Two Hit Matt from Two Hit Studio, and I'm one of the developers and artists from that little two-man studio. I work with my brother, and I've put out one game so far, Fatal Theory, out on Steam. So I'll just run this for a second. Little beat 'em up. That game was made in C++, and that was using SDL 1.2, so the older SDL. We're also working on Starslinger Kings right now. It's a little Java-based game. Alright, little action shooter robot-y game. So that's in the works. Hopefully that releases next year. Good old Blitz Smash, a little small game I made for my brother. Also in C++ with SDL2 this time. And One Heart, a little one-hit kill fighting game. Also made with Java. So that's sort of I mix and match as coder and artist across all of these. And what are we going to do? We are going to make lots of code, all of this, heaps of files, to make a little game called Cyborg to You Diborg. I'll just play a little bit. Let's do this. Alright, let's go. And this will be made with C++ and SDL2, and what you'll get out of it is a lot of like basic game developer stuff. So animation, collision detection. You'll up your C++ skills. You'll play with a lot of pointers, dynamic memory. You'll get to use I guess a bunch of polymorphism, and you'll get used to using lists for storing lots of things as well. So a bunch of game logic, a bunch of C++ intermediate skills. I recommend this for anyone who's at least learnt classes, pointers, and dynamic memory in C++. You should be able to handle this stuff okay. And either way, I'll be giving zip files as we go along of the project at each point. So even if you miss something, you'll have the whole project at each point. So you can just keep rolling on. You'll have the code, basically. And I hope you join me for this. This is my first online teaching course thingy. Usually I teach in a classroom of 24-ish people, maybe under, depends, obviously. And I teach at a college C++, databases, Java, and Android. But teaching on video is very different to teaching in classrooms, so we'll see how that goes. Anyway, I hope you join me for this. It could be a lot of fun. We'll make a cool little game, and you can definitely reuse it, a lot of this code, to build your own little game. Alright, so let's get this project started. So as I mentioned before, we're using SDL2. Now, to set up SDL2, it's an extra library that you need to include into your project. Depending what you use, you might want to use LazyFoo's setup guide for that. So he's got a Hello World section where he talks about setting up for Windows, Linux, and Mac, and various different IDEs, so code blocks, Visual Studio, etc. Or you can check out Will Usher's SDL2 tutorial index for another setup and a few basic tutorials that just talk about some very starting concepts. This is the one that I started on for SDL2. But because I want to get you into coding as quickly as possible, we're going to jump into those folders I got you to download. So there's I'll get you to download it now. So the zip files, assets.zip, SDL2.zip, and startingcode.zip. Just expand those, unzip those into folders. And we're going to go into SDL2. I'm going to copy that folder and we're going to put it somewhere that we're just always going to reference. Easy. That way we can move project from computer to computer. So I'm just going to copy that folder. Now this thing includes all the SDL, includes code that some other people have written, and the libraries to include for both 32-bit and 64-bit. So I want to copy this folder into just C drive. I just chuck it in here just to make my life easier. So I'm just in C drive, just paste SDL2 here with inside that folder is just the include lib and SDL2.dll, which we don't really need to be there. Cool, alright, that's the first part done. We've got somewhere that we can reference these files from. Now, I use Visual Studio 2013 Community. I don't think it's too different from the new one. I think they've only added new things to it. Anyway, if you have issues, just contact me. So, we're going to make a new project. Make sure it's a Visual C++ project. Click Empty Project and give it whatever name you like. Let's call this Cyborg Battle. I'll do. Keep note of where it's gonna go, because we're gonna have to add stuff into that folder. Okay, build that. That builds you an empty project. Now, this is the annoying part. We've got to link all this stuff up. So we got to tell this project how to link to the include and lib stuff in that folder that we pasted into C drive. So how do we do that? You see over here, not the outside whole project, but the little inside solution inside here with the ++ or probably a different symbol depending on what version you got. Right click that, go down to properties, and we're going to set up a few things. Now make sure your configuration is set for all configurations. And I want you to go down to C++, General. Our first step is to add additional include directories. So click down this little down arrow, edit. Click this thing here, new line, ... lets us browse. So I'm just going to go find. Now this is the additional include directories. So we go computer, local disk, so C drive, SDL2. This is your include part. So select that, do select folder. Cool, that's that part done. Now that helps us reference all the code, all the header files I've got there. Now the linking part, so go into linker, general. Where is it? Yes, there it is. Additional library directories. It's about halfway down. I suppose half? Yeah, about half. Additional library directories. Click that, do the same thing, edit. Do the new line button up there. Yep, browse. Now, find that SDL2 folder again, go into lib. Now you have the choice of picking between, do you want to make it a 32-bit game or a 64-bit game? I tend to stick to 32-bit because I sort of, well, 32-bit things run on 64-bit things, so I just want to cover all my bases usually. So I'll pick x86, which lets us do 32-bit systems. Okay. Good. Now this part, in your linker section, go down to input, and this is where we tell it what type of, what libraries we need to include. So you see additional dependencies here. Click that down arrow and edit again. And this one we type out. I'm just gonna get a reference, hold on. Hold on. Alright, so we need SDL2.lib, SDL2 main.lib, SDL2 image.lib, SDL2 mixer.lib, SDL2 ttf.lib. So to do basic SDL2 stuff, that's to do with like rendering to a screen, taking input. You need this one. This one does the SDL2 main.lib. That's to do with the Windows stuff, I believe. Including image lets us do, well, we can load PNGs and stuff. By default, it's just BMP. So this lets us do better image related stuff. Mixer is all sound and music, and TTF is text to font, so we can load up text to font files, or font files basically, and render them to textures, which I'll talk about much later. Okay, cool. Got that now. Next thing, system. This subsystem part. Now I want you to hit apply. So far so good. And I want you to change it to debug. Now the difference between debug and release is obviously debug, you can debug your code, you can stop it, look at variables, test things. And if you're lazy like me, you'd like to see a little console window output stuff as we go along, especially little errors. So if we want the game window and a console window to pop up, then we're going to choose this. So choose console for debug. You'll see when we get this thing going that basically when we run the game in debug mode, we get the game window and a little black window which has all the, console output. Hit apply, go to release, and instead choose Windows. Hit apply. So when we do the release version, it doesn't pop up with that little console window, which is probably what you want for when you actually release this game. Cool, okay. So we have, it's all linked up now. So we just need code and I guess a few assets to run this thing. So let's move on to that. Now there's a bunch of code that I want to start you off. I will explain what's included after we get this thing running, but I don't want you to write everything from scratch for this course. There's a bunch of files I've included: cleanup, drawing functions, random number, and respath, which just helps speed everything up. I've written these once and then I just use them all the time now. So I need to find, oh, this is in my starting code folder, by the way. Starting code, copy all this. Okay, we got to find this stuff now. Now, remember when I told you to take note of where hang on, Visual Studio, the hell is it? Okay, take again. Alright, do you remember when I told you guys to remember where your project is? Well, that's what we're going to do now. We're going to find that fault. There it is, Cyborg Battle. Cool. Yep. And go into it again. This is where all your code gets dumped. Yep. So we dump all your code inside of wherever your project is, basically. But there's a folder with the exact same name as the project inside itself. So Cyborg Battle. Dump all your code here. And I'm just going to drag it into my project here so it knows about it. So just under source files for now, and see all these header files? I prefer to put them under the header file filter. It's not a real folder, it's just a filter. So it's just in the project thing, it knows that, hey, these things under these filter are sort of, I don't know, we've grouped them under the header file section. And I prefer to split it that way. You can just have them all in the source files filter, it doesn't matter. But this at least makes it nicer. Anyway, we've got a few things included now. Good. Again, if you're having troubles, let me know. Alright, I'm going to explain those extra files later. What I'm going to do is make a new item under source files, C++ file, make sure it's a .cpp, and I'm just going to call it main. I think I'll just go at 100%. Okay, cool. Okay, let's start typing some code. I finally got there. Include. I just want to include all these header files that I've pretty much dumped into the project. ResPath comes in handy. Include drawing functions. A lot of these drawing functions are sourced from that Will Usher tutorial that I mentioned, but I've also added a bunch of extra ones myself to make life easier for certain situations. And I'm just going to check SDL Mixer here as well. Drawing functions includes SDL, the SDL header and the SDL image header, so that's why I haven't had to explicitly write that here, but Mixer hasn't been included in anything yet, so I'm just going to include it now. So I can set up that side of things. I'll explain that as we get there. Now, if you're on Windows, you have to, well, I think this is the same for Mac and Linux too. SDL has this thing where it tries to match this main function exactly to replace it with SDL main. So make sure you at least match these arguments at the top here. Otherwise, you'll get SDL main missing something. I don't know. I can't remember the error exactly, but it'll complain about SDL main being missing in some way. So make sure that this is what it needs to look for to replace this with SDL main. It's weird. I don't know. Anyway. Okay, so we've got to initialize SDL. Now, if SDL init SDL, I'm just going to give it one of their existing static flag references that they've made. So everything, SDL init everything, just do it all. Now, if that's not 0, so it returns 0 if it's successful. So if it's not successful, error initializing SDL. Return 1, so quit basically. So this is set up SDL. Okay, out of the way, mouse. Alright. Next part, the window. So the thing that pops up so we can draw stuff in it. Set up window. That's next. SDL window. Window. Is equal to SDL create window. We're going to come back and change this stuff later, but the title that you want on there, so I'm going to just put Cyborg Battle. The X and Y of where it pops up. Now, I'm going to use another one of these pre-built static flags. Window pause centered. So I'll do that again for the Y, X and Y of my screen. It's going to be that. Which basically means whatever size window that I'm going to make, center it on my actual screen when it pops up. Now, how big is this thing going to be? 640 pixels by 352 pixels. That's how big the screen's going to be. And SDL window shown. I'm just going to make this over 2 lines so I can type this next bit. Now, if you wanted to make this thing start in full screen mode, you would replace that with this little, I can't remember the name of this thing, but basically lets us sort of add a few bits together. SDL window full screen. So say, okay, the window is shown and start in full screen. Just replace that with this, including this vertical line. That's if you hold shift and press that slash button over enter, that's how you build that thing. I don't want mine in full screen though, so it's okay. So if window is equal to null pointer, that means it did not work for whatever reason. So we're gonna quit SDL, let it shut down properly, that part, whatever it's initialized. Output window error. So just for our own debugging benefit. Turn 1. Cool. So if it didn't crash at this point, we keep going on to the next thing, which is going to be the renderer. Set up renderer. So this thing helps us draw stuff to the screen. It's very helpful. Render is equal to SDL create renderer. You tell it which window you want to reference. Index, the index of the rendering driver to initialize, -1 to initialize the first one supporting the requested flag. So we're making our first renderer, so we put -1 in here as it says to do, and then some flags. So what things we want. I haven't played around with these really, but this seems to be the standard to get you good results. So oops. Accelerated and prevent VSync. Vertical sync, if you know about that stuff, that's good. It's usually, I don't know, we're preventing it. Usually it's annoying. But you can look into that yourself. But anyway, these give good results. I just stick that in all the time. It seems to be alright. If you want to get into more details, look up renderer flags and you'll find all the other options that you can chuck in there too. So if our renderer is also a null pointer, it means it didn't work. So quit. Actually, we should probably kill the window properly first, so clean up. Window, that's from my cleanup header file, just to make things easier. CR, renderer error. Return 1. Getting there. So what I'm making is a little pixely game. So you can do this thing where you set logical size, which means regardless of how big the screen size is, it's going to try logically fit a particular screen size to that size. So if you want everything to be like always 2 times pixels, then you can set the screen size to double whatever this next thing is. I'll show you what I mean. Render set logical size. Renderer 640 by 352. I'm just putting in the same numbers as above. Yeah, which basically means this is the size to draw things at before we scale it to the screen size dimensions mentioned in create window. So if you want it to be all 2 times pixel, everything scaled by 2 times pixels, just put in half the numbers here, half of whatever's up here. So half of whatever's up there, put it in here, and it will do that for you. You don't have to think about doing weird zoom stuff. You can just set that. It's really nice and easy. Alright, we got to initialize the other things. So, we got to initialize SDL image as well. So if, which lets us use PNGs basically, which is what I want, because bitmaps, as you know, pretty old school. PNGs are also usually a lot smaller in size, so it'll drastically cut your size of your whole project down a fair bit when you're giving it out to people. Not equal to. So if it didn't work, quit again. Okay. Don't know why they've done it in that particular way, but that's fine. I'm just following standards here that other people have set up. And we want to set up that text to font. That's for later. It's a lot easier, so I guess I'll type in these comments here. Hold on. Initialize text to font. Basically lets us output strings using fonts onto the screen. SDL, TTF, did not initialize. Ah, what's with the capital E? Go away. Alright. Term 1. Okay, the mixer next. The mixer lets us play with sound and music, which is always good. Mix, open audio. Now you gotta choose the frequency at which this thing comes out. I'm not a sound guy, so I just more or less again copy this from someone else. So we enter in the frequency, the format, how many channels it has, and the chunk size. The chunk size is sort of what do you call it? In this, well, Mixer calls chunks basically whatever sound you load in. So I guess it tries to stream in chunks of sound, and this decides how much it can take in at any one time. Anyway, again, I just follow this because I'm not a soundy guy. If you're very into the sound stuff, then you can definitely check out these settings. Two channels. If you want more channels, basically how many different sounds can play at once. Two's fine for me. You might want more. If it's equal to -1, this one outputs a -1. Well, returns a -1 if there's an error. So it's just different. It's different to the above ones. See out. Did not initialize. Good. All right, we've made everything start up. That's always a good start. Cool. Let's actually do something with all this. So this is, we've pasted the folder with all the stuff we need to link to. We've told our project how to link to it. In our code now, we've told it to start all of those things, and now we're actually going to start using it. So we're going to load up a texture to draw. String res path. Res is basically just going to be a folder where we just source all our assets from, and get resource path. This this res path.h, this is from the Will Usher tutorial. It just makes dealing with finding your assets a lot easier when you're playing with Visual Studio. So I didn't write this thing, but it helps us find our folder. It'll just give back our folder directory where all our assets are, and then we can just find them. So we're going to make our first SDL texture, which is basically just an image that we want to display. Load texture, res path, path plus, and I'm just going to load this one, map.png, and you give it the renderer so it knows how to build it. So using the renderer and an image file, this function goes off and builds this texture for you. Okay, I'm just going to set up a little loop. run game for 5,000 ticks, which is, I think, basically, I think it's equivalent to milliseconds, or pretty close to anyway. Wow. So get ticks counts the ticks from the start of when you run your game. So it starts 0 and ticks up. This will help us deal with time. So while this thing is less than 5,000, so how many ticks has it done since we started our game? If it's less than 5,000, then I want to SDL render clear, and we give it the renderer. Now that we're just going to go over a very basic drawing procedure, which is clear the screen, draw what we want to the screen next. You can do heaps of these. So render texture, the texture that I want to render, the renderer, and I'm not using this one. I'm using this one, X and Y. I'm just going to leave the clip as default. So where do I want to draw it on the screen? 0, 0, oh, 0, 0. So that's its X and Y, 0, 0. Now X and Y is 0, 0 is top left. So I'm drawing from the top left of the screen, however big this texture is. Now drawing to the screen, well, this draws to the renderer, it doesn't draw directly to the screen. So this renderer sort of stores up this big image, and then when we want to show it, show image we've been rendering. Then we do SDL render present. Cool. Alright. So this thing runs for 5,000 ticks. Every time it runs through, clears the screen, draws our texture to the renderer, and then gets the renderer to dump out whatever it's storing in this image to the screen. Now, just to sign everything off, we're going to do clean up window. I probably have to clean up that renderer as well. I'm pretty sure. Oh, help if I could spell. Renderer. And I want to, oh, I better clean up that texture too. Clean up. And SDL quit. And return 0. So we made it. Okay, so cleanup. What's that doing? I mentioned that you would need to know about pointers and dynamic memory before you get onto this stuff. But basically, see with SDL texture up here, this is a pointer. So it's load texture dynamically builds a texture. And all cleanup is doing is going and deleting that dynamically allocated memory for us, which is good. That way we don't take up unnecessary space in our heap or RAM or whatever you want to call it. Cool. Alright, let's try building this thing. Build solution. Help if I could see the output here. Good. Build 1 succeeded. Now I didn't want to run it because it's going to be looking for some things and it will just crash. I'll show you. It'll just crash. Yeah, there we go. SDL2.dll is missing, so it just crashes. Now, you've got your project folder. Go back to the base of it. So in your projects, wherever you cyborg battle, you built it once and it builds this thing called a debug folder. If you're building release, it'll build a release folder. In here, This is where I'm going to chuck my asset so it can find it. So I'll go back to, hold on, let me just find all this stuff again. Where did I put it? Great, I'm going to lose everything. Hold on. Didn't I just chuck it here somewhere? Yeah. Alright, that assets.zip, that's what we want. All of this stuff. I don't want you to copy the assets folder, just what's inside it. So inside res, we got a bunch of images that I've provided, a blank white one, cyborg running around, various art things that we need, plus sounds and files and whatever else, font. Cool. But also in here is a bunch of DLLs. Now we need this so our exe will run. See, there's that SDL2.dll that it was complaining that it couldn't find. Copy all of that. Go to your project folder. In that first debug folder, now it will build two debug folders. I'll build this one in here where it's got all these object files and stuff. Not that one. Go back to the root of your project and use the outside debug one. Chuck it in here. It's where your exe gets built. So chuck it in there. Yep. And let's run it again. Run. Yeah, that's it. Look, it loaded that image. That's pretty cool. Alright, and it ran for 5,000 ticks or milliseconds, which is basically just 5 seconds. Let's do it again. Oh yeah. Cool. Well done. We got something running. That's good. Alright, now we've gotten this far. I am going to make sure that you get a copy of this project so far. So every time we do get through a chunk of code and we can run it, then I'll basically make sure that that section of code and project, all of it, is available. If it's not, then hunt me down. Alright, cool. Okay, so I mentioned that I would talk about those files that we just chucked in. So, first one, clean up. I think you pretty much get the idea. This helps dynamically delete any of these things that we've built. So SDL window, renderer, texture, or surface. So it's basically just a cleanup set of functions. Just dynamically cleans things. Gets rid of that new memory that we've built. Now, drawing functions. This is a whole bunch of useful ones that I got the start of these off that Will Usher tutorial, and then I've added onto them quite a bit. Now we've got load texture, which is what we've used. Takes a file and a renderer and dynamically builds a texture for us. So the file we used was that map last time, map.png, which is here, that one there. And we just loaded that straight up as a texture. Now we also have load surface, which is one that I built myself. I'm pretty sure. What's this? Yeah, pretty sure I made this one. SDL surface is a bit different. Now, SDL surfaces were used extensively in SDL1, but since we've gone to SDL2, the emphasis is to go into textures. Now the difference is it's the same sort of concept, but a surface is stored in your RAM and it's blitted to the screen, so it's software rendering, so it's more intensive on your GPU. Now textures are stored in your VRAM or video RAM, basically stored on your graphics card's RAM temporarily while you're running stuff. And Obviously this is good because we're using hardware accelerated rendering. It's much faster and more efficient, and we're not taking up RAM. We're using just video RAM, which is sort of what it's built for. So this is the better way of doing things. Now I still have load surface here, even though I'm working with SDL2 for one reason really. Textures that are stored in VRAM we don't have direct access to, whereas SDL surfaces we have direct access to their pixel data. Which you're probably wondering, why the hell would we want that? A lot of people don't need it, but for someone like me who likes to do palette swapping, so when you get like an 8-bit pixely image and you swap out its colors for another set of colors, that's what I like to do. So you see that in the old fighting games like Street Fighter 2, you'd see them, you pick a character and the second player picks the same character, they get an alternative color palette. They don't have two sets of the image, they just load up a different set of color palette for that one image. That's why I keep surfaces around. Now, like I said, texture's the way to go though in SDL2. So what I do is, if I do need to do color swapping, I load up a surface, I swap the palette using this one here, surface palette swap, so it helps like swap a set of colors in and out on a surface. And then I use this one here, convert surface to texture. So good thing is you can do all your pixel data manipulation on a surface first and then convert it to a texture after you're done to speed things up again. So we can always do that. This is another reason why I picked SDL2 over other C++ rendering things. I do like having direct access to pixel data. Anyway, we got render texture here. It takes a texture, takes the renderer, and this one we can use SDL rectangle. That's basically just a rectangle using a X, Y, width, and height. I'm going to show you. X, Y, width, height. It's just a struct. That's just part of the SDL package. As the destination, and basically, say your texture is like 32 by 32 and your destination is somewhere on the screen using X and Y, and you set the width and height to 64 by 64, it'll stretch that 32 by 32 pixel image to 64 by 64. That's why this little renderer has been built this way, which is very handy. And clip, if this is not null, so the default is it's null. If this is not null, which rectangular clip or which region inside our texture do we want to draw from? So you don't have to draw the entire texture, you can just draw a small chunk of it. This will help us later when it comes to animation, where we've got one image that holds a whole bunch of frames and we just want to draw one frame at a time. We use this clip section, so it's just a region from which we draw from. This is the one we used earlier. So render texture takes a texture, a renderer, this time an X and a Y, and then a clip. So it doesn't have a destination rectangle, it uses an X and Y instead. So this one's good if you just want to just draw stuff that's at that exact size, like the same size to the screen. So if it's 32 by 32, you'll draw it at 32 by 32 just at this X and Y. So if you want to do quick stretching and stuff, use this one. If you want to have stuff grow and shrink. If you want to just stick it on the screen, then use this one. Again, it does that clip stuff. Render text, we'll use that later. Basically, string, your message, your font file, color, font size, renderer. And what it does is it takes your text and, well, your string, I guess, and using that font and color and size and the renderer, it builds a texture out of it. So you don't want to do this too much. So you want to sort of build a bit of like a text image in a way, a text texture, and then output to the screen, and when it changes, then free it up and rebuild it again. Don't do this every loop cycle if you can help it. We'll go on about that later. And another one, render text here as well. So message, your font again, color. It's basically the same stuff. I just took out a few options to make it simpler. And this one, save screenshot BMP. So we won't use that, but if you want to call this thing, you tell it where to output this file, tell it which window, which renderer, and it'll basically take a screenshot for you and output it as a BMP. If you want it as PNGs and stuff, you'll have to look up how to do that yourself. Just BMP is easiest, and it's just a quick way for me to get screenshots out of a game. If I want to programmatically do screenshots, otherwise you just do screenshots the normal way, I suppose, just using the screenshot key. Okay, random number. Get random number modifier. So this is one I built myself. Random stuff, we'll talk about random numbers later, but basically it gives you a number between 0 and whatever your modifier is. So if you put in 100 here, then you'll get a random number between 0 and 99. Res path, that one that I mentioned that Will Usher did. So get resource path, and then we typed in res here, and it got us the res, or the path to that res folder. Very helpful. Okay, otherwise it's just the code for all these things that you can look through yourself. Or if you have questions about particular drawing functions especially, then contact me about it. I'm hopefully they're not too odd. They should be okay. Alright, cool. That's another one down. So at some point in your Cody life, some guy probably told you using global variables is bad. They're not wrong, but there's nicer ways of doing it. And in terms of making a game fast, globals do come in handy. So we're going to make some global variables using a class, so it's a bit nicer at least. But also, you probably find with these tutorials, I skip a few basic standards just to speed things up. And as an indie, that's what it comes down to for me. You can be as clean as you want on your big professional project, but if you want to get it out quick, then just make sure it works. Alright, so we're going to make our first class that we're going to build together. So in your header files, add new item. You could do new class, but I prefer to do it one by one. Header file, globals. Cool. Now, if not defined, if you did it the other way, it would use that pragma thing. I prefer to use these just because that's how I was taught at uni, so I just can't help it. Globals, then define globals and if, which I don't know if you know what this is for or what that pragma thing's for, but basically when the compiler's compiling, I guess that's what it does, it compiles, and what it does is whenever it sees it include a header file of any type, it basically goes and copies and pastes that code and just chucks it in. So what this is doing is making sure that if that include shows up a number of different times, that it doesn't paste that code multiple times, because the compiler ends up building like this giant big thing of code that's just like one big file of code, and then tries to turn it into an exe in a way. Sort of, not, well, kind of. So this stops it from pasting this code over and over. If you don't have this stuff here or that pragma thing here, then you get the error of multiple definitions of this class is what you'll see. So I just wrap this around all my classes. Include. Now we need strings in here, I'm pretty sure. We need, what else do we need? IOStream. Probably not, but you never know. SDL. Probably very handy to have that. And for some reason I've included random number. I don't think I need that, but whatever. Cool. Alright, class. Globals. Public. Now, I'm going to use statics. So, first one I'll use is static const float pi. If you don't remember what static is, basically it means that this pi variable that belongs to this class is now, well, I've declared it as static, which means it doesn't belong to an individual object of type globals. So if I went globals, global dot pi, do something with it, say, if it wasn't constant, for instance, I would be changing pi for all global classes. It's shared. So static means that this data member is shared amongst all other globals, which is very handy for what we're doing. Static variables of classes and just in general are initialized at the start of the program. They exist outside of scope pretty much. When your program runs, these all get set up, and then when your program ends, these all get destroyed. So you don't need a global object for these things to exist, which is very handy. You'll see, we'll start using them in a second. We'll just build a few first. So this is my math helpers. Whenever I just sort of try to batch these a bit. Useful for me as a dev, so I just make a few things like this. So static bool debugging, whether I'm debugging or not, so I can do weird extra drawing stuff on the screen if I'm in debugging mode, which I'm going to use for hitboxes and collision boxes. You'll see later. We're also going to store the static int screen width, screen height, and screen scale. And I'm actually going to store the renderer in here. It's just much easier to just find this thing wherever I need it. I don't want to have, I want to make this thing global so I don't have to pass it from one class to the next. I hate doing that after a while. It can be handy, but sometimes if it's just the one thing that I want, I just want to be able to get to it. So I just make this thing global. Alright, so this is all that SDL related stuff. And what else do we have here? I think that might be it. That's all. It's pretty easy, just a few. Now, like I said, static stuff gets initialized at the start of the program. So we're going to make a source file to reflect this. So add new item C++ file.cpp globals. And what I do is, because I'm lazy, right, I copy all of them over to here. Well, I got to include globals.h. I paste all this junk here, and what you do is you stick in the class name in front of it, globals, get rid of the statics everywhere. Put these on everything. It's going to complain for a little bit. It's alright, that's what we're expecting. And there, get rid of those statics. Alright, then we start just putting in numbers. So I am 14159. You can go further if you want, or you can derive this some other way. I don't really care for full-on accuracy. This is not real life, so I'm okay with that. So this is how I initialize it. This is how this particular variable gets set up at the start of the program. Debugging, I'll set this to true for now. I'll be changing that a fair bit. Our screen size was 640 by 352. It's a strange number. Basically, I just picked it because it's divisible by 32, which is sort of my tile size for this whole thing. And screen scale, I'll choose 1 for now. I'll show you what this is going to do later. I'll surprise you. And my renderer, I think I'll just leave that as null for now, because we're going to set that up later. Cool, so we got them. Pi, debugging, screen width, screen height, screen scale, and renderer initialized, all belonging to this class. Cool, jump into main. And we're going to include globals. And here, where it's got 640 for the size of the screen, I'm going to change that to globals. Oops. Screen width. I might make this go onto the next line again, just so you can see it. Screen width times globals screen scale. So if I want to do 2 times scale, I just change that screen scale to 2. Pretty easy. Do the same for that 352, so that's globals screen height times globals screen scale. And look at that. So I'm playing with these variables that belong to globals, but haven't built a globals object. That's because it belongs to the whole class as a whole. I don't have to initialize. I don't have to instantiate any objects to access these variables. So this is how I do this stuff. Play with globals. It's sort of nicer. Down here where we had this renderer from before, I'm going to just change this out for globals. And wherever it bitches, just chuck that in front of it. And down further. A few more. Good. Oh, I knew. Yeah. And that one. Good. Cool. If your code still runs, then you've done good. Like, nothing's changed so far. Look, there it is. We've just added a new class that helps manage a few things. Now, I told you that scale thing's pretty cool. Oh, here as well. We should change out. This will help with our scale thing. So SDL render set logical size. I want to put in just globals screen width and globals screen height. And what I'm going to do is I'm going to go into my globals file and I'm going to change the scale to not 12, 2. And run that. There we go. It's at 2 times size. It's just scaled everything up. So it drew the exact same thing, but at 2 times scale. And that's all we had to do. Pretty easy, hey? Cool. Alright. guess that's it for globals. We'll revisit it if we need to, but I don't think we need to for a while. Cool. Again, you'll get access to all this code as a whole project again if you need it. Alright, done. Okay, so we're up to some theory now. We're going to talk about animations, sprites, sprite sheets, frames. You get the idea. Because we're eventually going to want to animate this stuff, get some little characters running around on screen. Now, let's go over here first. Whereas you see that there's this file. Here's our cyborg. This thing here we call a sprite sheet. So I'm just going to drag it in to Photoshop. I like to work with Photoshop when I'm drawing stuff. Cool, whatever, that'll do. Place. Cool. Alright, so this thing here we call a sprite sheet. And it's basically describes a set of animations. And each one of these images we call a frame. Now you can see running's only 4 frames. It's not terribly convincing. Well, it's pretty good. Sword attack's only 3, so 1, 2, 3. The reason why I can get away with a few frames and it's it's pretty passable is because of this thing called persistence of memory. So if you have some guy about to throw a punch and then next frame he throws it and that's it, that's all you got. If it happened in quick enough succession, your brain makes the steps in the middle that it needs to. So it sort of pretends that middle frame happened, which is good. That's what you want, right? So that saves you in animating and time, which is good. So we've got this thing here, our sprite sheet with all our frames on it and all of our animations. So we've got run, up, down, left, right, all our attacks, getting hit, dying. This is for dash. Now, we got all that just in one big file, and I mentioned last time in that drawing functions header file, there's code to clip parts out of it. So we're going to load up all this information into an animation set, which contains a bunch of animations, so like running down, running right, running up, running left, and those animations hold a list of frames, and those frames hold this thing here, clip region. So that's a clip region there, clip region. Now I'm using this tool that I've built myself to generate these other files. So if we go over to here, you'll see, where is it? I can't seem to see it. Udemy cyborg.fd set. Yeah. I'm loading these files up alongside the images. Now, these files are called frame data sets. It says what image to load, how many animations there are, and then it starts to describe each animation and a bunch of data related to that animation. So things like the clip region, so the X, Y, width and height, offset, duration, and index. Collision box I'm not using anymore, but later on, hitbox, wherever that is. Can't find it from there. No? Oh, whatever. It's in there somewhere. So hitboxes are in there somewhere. Should be anyway. Yeah, hitbox. There it is. Right there. Yeah. And damage. So for the frames that have do damage, they have hitboxes and amounts of damage that they do. So what I do is I load up one of these FD set files in code, and it describes to me how to read in the information of this particular sprite sheet. So it describes all the frames and various other data. The tool that I'm using for that to generate these files is called frame data, and it's by my studio. I actually made this myself. There's it'll explain why. If you go and check out this tool, it'll explain why I built this tool in the first place. I basically wasn't happy with those Atlas creators out there. Anyway, if we load an animation set up, that's set to Udemy. Okay, so load animation set. Find a Udemy cyborg. This is all the animations that this cyborg has. Up, down, left, right, up. There he is running. Yep, cool. Edit one of those frames. I'll just zoom in a bit so you can see. Here's this guy. Alright. Let's go to a more interesting animation actually. Let's do slash down. And we go in here. Alright. So this tool lets me just quickly build all the data for frames and whatnot. So duration is how long does this particular frame stay on screen, where 1 is a second, so 0.1 of a second, whatever that adds up to be. Offset is if frames are of different sizes, how do we line them up? So how I line them up, I tend to decide on a common offset point or origin to go, okay, this dot needs to line up with this dot and this dot and this dot. So when I stick them all together, if I overlay these points here, the animation will line up properly. So that's what offset is. So go back in here. Offset, so you can see it's this white square here. Collision boxes, so I don't use these, but there's a collision box there. Hitbox though, see this area here? This is where the damage zone is. And then damage, I've typed in 10. So I use this tool to build all this information relating to this stuff. So if I could add another frame if I wanted to, which is not a good idea, but it's like frame region. Let's chuck this on the end for no reason at all. Save. There, it's added this guy on here. Offset. If I stick it there, he'll line up properly at least. Save. Doesn't make sense, but yeah, I'll get rid of him. But I use this tool to build this thing. To build that FD set file, which is down here. That. So this file describes all the animations in this sprite sheet, all the frames and all the data relating to that. You can use this tool of mine to build whatever data you want. If you've got a fighting game with all different types of frame data, you can use this tool to build that. Anyway, not important right now. Jump back over here. Okay, so we've got a sprite sheet. A sprite sheet holds a bunch of animations. Animations are broken up with frames. Frames hold data like offset, so to help line them up. And clip region, so where on the sprite sheet they are, so we can load the whole file up as one big image and then just draw a little tiny piece at a time whenever we need it. And things like duration and hitboxes and damage and whatever else you need. That's just about it on that. I guess we'll start coding it very soon. So this time we're going to talk about time, especially in games. This is important for doing our animation stuff because without some idea of how much time's passed since the last thing that's happened, then it'll be very hard to work out how long a frame should show up on the screen for. Now we're going to make a class that deals with this. So we'll just go over and build a new header file. And we're going to call this thing time controller. Alright. So if not define time controller, then define time controller. And if this thing needs to know about, not too much at least, include iostream, yep, that, and include SDL. Class time controller. Good. Alright, the public stuff. Now I make these what's the word for it? These static constants reference keys, I guess, reference values. They're just constant values, just so I can keep track of. Well, I don't want to keep passing values around like 0 and 1 and working it out. This is for readability's sake. So these things just have a static value, and I just use them as reference. You'll see. So they're just reference values. And time state, so that's one of the above. I don't think we end up pausing time, but if we need to, we've got that there. The last update. Now, uint32 is unsigned integer 32, so it's quite a large integer value, so it can get like quite large, right? We're going to store the current amount of ticks at that point in time. So the ticks, SDL counts these things called ticks from when you start the game all the way until you quit the game. They just tick up. And they're pretty equivalent, like 1 tick is equal to 1 millisecond. So we can use this as, this is the last time we checked time. So this is like the most current amount of ticks in our game. Or, sorry, the last time we checked time. So this is the last time we checked how many ticks we were up to. And float dt, which is our delta time. Now, delta time basically gives us, oh, that's right, this is in seconds, so 1 is equal to 1 second. 0.5 is half a second. You get the idea. It goes into milliseconds through the decimal place, right? So, delta time is the amount of time since the last frame was rendered onto screen. Now, if you're playing games and you can see like the frames per second, or FPS, pop up anyway, you can turn that on. You'll see that that fluctuates. So games try to aim for a minimum of about 30 frames per second, but if you got a good computer and the game's not terribly hard to run, then it could be running in the hundreds of frames per second. Now, that value fluctuates depending on your computer or what the game's trying to process at that time. So how many frames per second is dependent on a few things. It's not something that we can totally control. We can't force an exact 30 frames per second. I believe we can, but it's not something you want to do. You sort of want the game to run as fast as it can and keep rendering to the screen as often as it can, and we keep track of time outside of that. So delta time is how much time since the last time we did a frame render, so since the last frame that we rendered to the screen. And usually it's tiny, it's in the milliseconds, very small. Using that, we can work out all sorts of timing. So how much time has passed since the last iteration of through our loop of code in our logic, or we can count down timers, count up timers, make various events happen. Very useful for animating sprites. So we're going to use this to help work out a lot of our animation. Alright, so our time controller has a constructor which will set itself up. Update time, which will update last update and DT. Void pause, void resume, void reset. Now, the game you can pause the timer and keep running the game's code, but DT will be 0, so that way things that rely on time will pause, but the game will keep rendering to the screen whatever is not relying on time. So if you have other things that move outside of time or read various, well, like user input, for instance, you don't want that based on whether time's paused or not. So if a user wants to quit the game, press escape, you don't want that based on time. You want that just to be something you're allowed to do even if the game's paused. So this just pauses the timer, and we can resume it and reset it as well. Okay, so this is just our header file. And one other thing, we're going to set up this global value of time controller. So I mentioned in the globals video a while back, statics means that this data member here belongs to the class as a whole, so it doesn't belong to any single object of time controller. So what I've done is I've made this class group have a static single copy of a time controller that they all share. So I'm basically just going to use this one. It's just going to, and as I mentioned last time, statics initialize when the program starts. So as soon as our program starts, this thing gets initialized, calls our constructor, and then we've just got this one time controller that we can reference from anywhere. Alright, let's build the code for this thing. So, under our source files, add new item, CPP, time controller. Include time controller. Again, I'm lazy, so I'll definitely copy all of these across. So all of the member functions, methods, functions, whatever you want to call them, and this static member as well. And I'm just going to paste that over here. And to make it so that I'm defining these functions for this class, I've got to put this thing in front of all of them to say that, hey, update time function belongs to this class. That's what I'm defining this for. And here as well. Now knock off that static. That's all we have to do there. So this thing is builds a global time controller object for use anywhere. As long as we reference this in front of it, whenever we need it, we can use it. Okay, our constructor, we'll get onto that in a second. I'm just going to basically get rid of all these semicolons and turn them into open brackets, and then I'll chuck code in there in a second. Alright, let's do it. So, start chucking code in. Alright, I forgot I also did those constant values. So let's go back out here. These guys at the top. I don't need the static part. Copy that. Paste it up the top. Copy this bit again. And it doesn't really matter what you set these values to as long as they are different. Now these are just reference values for readability's sake. So I just put that in the header file. Reference values. Yeah. Okay, so DT in our constructor, we're going to set that to 0. Last update is equal to, I guess we should probably get how many ticks it's been. Oh, let's set it to 0 actually. Doesn't matter at this point. Update time. So if time state, which we should also set up here, sorry, time state is equal to play state. See that there? So I'm keeping track of whether we're playing or not using an integer, and I'm referencing the value up here. So instead of just going, oh yeah, time state is 0, what does that mean for someone reading through your code? Not much. So it's just for that, just for readability's sake. So if time state is equal to pause state, so if they pause the timer, then the DT is 0. So just means that it's just informing you to say no time has passed since the last update. Otherwise, uint32 time diff is equal to SDL get ticks, so it gets the current ticks that we're running at, minus the last update. So say we're at 5,000 ticks and the last time we ran this function, the last update was set to 2,000 ticks. That would mean the time difference is 3,000 ticks. And then dt is equal to time diff divided by 1,000, which move these milliseconds into the decimal area, decimal place area. E.g., let's do 104 is equal to 0.104 seconds. So just have it that. It just seems to be easier to have this in decimal places for the code after that. Because I used to run it as just the how many ticks it had been, and I ended up having to convert it into decimal places a lot of the time anyway, so this just saves time. Last update is equal to SDL get ticks. There's it. So whenever we call this update time, last update always gets updated to whatever the current amount of ticks is. So if ticks is 5,000, then last update's set to that. So then the next time when we run this and the current amount of ticks is 5,050, then when we get to time diff, it's 5,050 minus 5,000 is 50, and then you can move that into your DT. That's sort of the logic here. And that gives us the amount of, I guess, milliseconds or seconds since the last update. Pause and resume are pretty easy. Time state is equal to pause state. Time state is equal to play state. And reset is just dt is equal to 0, and last update is equal to the current ticks as well. That's it. That's all we have to do for our time controller. So just remember that ticks is SDL's way of keeping track of how long the entire program's been running. So it'll start at 0, and it'll basically just count the milliseconds since you've started. So using that, we can work out delta time, which is time since the last time we called this function, update time. And using that, we're going to work out all of our animation code, timing code, and all that. Cool. All right, we'll use this very soon. Okay, so this time we're going to build the class for a single frame. We're going to build up frame class first, which belongs to an animation, and then an animation belongs to an animation set. So we'll start with the smallest one. Now, there's a bunch of code I've already written. I want you to download data groups code.zip, unzip that, and copy all of these files into your project. So paste and drag them into your project. Yeah, I dragged them into the header files filter because there's only one CPP, so easiest to chuck that one after into there. Yep. These files that I just got you to get, data group type, group box, group builder, group number, group position, group string, they're the types of data a frame can have in very general terms. And we're going to load this information up later. We're going to deal with very basic frame stuff now, and I'll talk about this stuff when we get onto loading our information up from those FD set files. So don't worry about this for now. Just we've got it there included because we need it. Good. All right. Now let's move on to that frame class I mentioned. So right click, add new item, header file, frame, add in this same stuff if not defined, unless using the pragma want stuff, which is fair enough. Define. Whoops. I've got a laptop on my lap getting in my way. Okay. So what do we got to include for this one? We need a bunch of things. We need IOStream if we want to do any output. List, very useful for creating dynamic structures for holding things. File stream for when we get up to loading information in. String stream, good for building strings or reading from strings. We'll do that for loading as well. SDL.h. Going to include the drawing functions too. Globals, just in case we need to reference anything in there, which we will add a new function to. And group builder, which we'll use for loading up all the frames extra data. Okay, using namespace std class frame. Now a frame has a few inbuilt attributes that every frame must have, and then a generic list of frame data, which could be anything. It's up to whoever designs those FD sets, which will be you, so you can decide what types of data goes in there. But this is the stuff that every frame is going to have. So frame number or frame index is used to work out the order of which frame this is. Like, so index 0 will be the first frame, index 1 is the second frame. You get the idea. SDL rect for the clip zone. So the clip, like I mentioned in the last video, or maybe 2 videos back, is the on the sprite sheet, the region which describes just one frame. So if we go to our cyborg, say we've got this downward slash, that clip zone is got an X, Y, and a width and a height to describe a box around that one frame there, so that we can just draw that piece out of this whole image. So we can load a whole image at once. It just makes life a lot easier. I'll put these notes in as well. So it's the region on the sprite sheet where this frame is. So SDL rect has an X and a Y and a width and a height. It's, I might as well show you. It's a struct. So X, Y, width, height, just integers. Every frame has a duration. How long should it be on screen for? How long does frame run for? And SDL point. An SDL point just holds an X and a Y. For the offset, which is the pivot point to help align frames in an animation. So I might show how this one is supposed to be used. So you go, just kick open Photoshop. It's probably the quickest way to show you this stuff. Okay. So in code, you'll have your characters X and Y at some point on the screen. So let's say this is at 50, right? And then we've got a image of our dude, whatever he's doing. I'm using the mouse rather than the tablet at the moment. There's the clip zone, so it's clipped out like this. Now, if we didn't use an offset, then he would draw from the top left corner, which is probably not that useful for aligning things. So that offset says, okay, so this frame's offset is down here. So let's say that's 100 down, 100 on the Y, and 20 across. So it goes, okay, using that offset of 100 and 20, so 20 and 100, we can minus that 20 to get it to there, and minus that 100 to push it up to here, which helps align us our offset point on our image with the X and Y of where our character is in terms of code. So as these things move around, we've got something that helps align everything up nicely. So that's what this offset here is for. Alright, and the next thing is a list of frame data, which we'll talk about a bit later, I guess. But basically it holds groups of additional data for the frame. This one is just a list of groups, and groups can be of box groups, number groups, position groups, and string groups. So I wrote this to be a bit generic because that way it doesn't matter what data you've got, you can just load anything up. You'll have these default bits of data, and then any other type of data you want to add to each frame, it'll just load it up in this way. That way, once you get through all of this, you can just dump my frame and animation code into any other project if you're using SDL2 again, and you can just load stuff up very easily with any data. So hopefully that helps you. Anyway, there's only 2 functions we've got to build for this thing, and one of them we're going to do later. So void draw. Draw takes a texture, so an image that we've loaded up of some sort. Spreadsheet. And an X and a Y of where should we draw this thing. The other function that we'll be building later to do is the load frame code. I'm going to do all of the loading code for all of this later though. Okay. So only really have to fill out one function. That's pretty easy. So we're going to build the CPP file for this thing as well. Add new item, CPP file, frame. Make sure you include that header file. Yep. And again, because I'm lazy, I'm going to copy that function, paste it here. And remember, we've got to make it for that class that we're defining this function for. Otherwise, it's just a generic draw function. So we need to make sure it belongs to that frame class. Alright, and now we just got to fill this one in. The reason why we pass in the texture on the draw cycle is because maybe you want to retain all of the same frame data information, but just want to sub out the image. So this is useful for, well, we're going to use it for subbing in and out the damage image, which is just pure white version of everything. But you might use it for if you got like characters with different alternate colors, perhaps. You could use it for after your character gets hurt so much, you have a more hurt version of that sprite sheet that you want to draw instead of the first one you loaded up. It's up to you. Anyway, let's get on to drawing this stuff. So we build SDL rec to describe the destination. So destination of where we want to draw this frame. Now this works out like this. So the destination's x is equal to that x that's been passed in minus the offset x, and the des.y is equal to the y minus offset dot y. And that's going back to this. That's exactly what that bit of code does. It goes, okay, that offset x and y moves our image up to that point to help us align us with the x and y that you've passed in. So use that offset to line it up with that other x and y. That's what that's doing. Our destination's width is equal to the same as our clip's width. And our destination's height is equal to our clip's height as well. Now all we have to do is draw this thing to the screen. Well, to the renderer. So render texture. Yep. We give it a sprite sheet. It's asking for a renderer now, so we're going to go globals, renderer, destination, so we've got DST for that, and our clip region, which we also have. We have to give that the memory address though, because it's asking for a pointer in that slot, so we just give it the memory address of this clip rectangle. Cool, that's all we need to do for this one. So up next is the animation class, which holds a bunch of frames. Let's do that very soon. And back, let's do the animation class now. So last time we did the frame class, and now we're going to make an animation class that holds a bunch of frames. So go up to your header files filter, add new item, header file, animation. Do the same old stuff as last time. If not, define animation. Oh. Then define it. Alright, we need to include a few things here, so let me see. I can skip a lot of that. Pretty much just need to include frame actually. So include frame. Using namespace std, class animation. From memory, did I forget to add public to frame? Yes, I did. So go back to your frame class and make sure it's public. Good. Okay. With animations have names, we're going to use that to help look up which animation to use. Name of the animation. It's pretty obvious, I guess. A list of frames. And that's it. We just start building functions for this thing. This one has a bunch more. We're going to make a constructor for this one, which takes a string name and default value of empty. But we'll probably end up filling it in more than not. And then a bunch of useful functions to get around running an animation. So we got get next frame number. Returns the next frame number in the list. Oh, I forgot the semicolon, my bad. Okay. We're going to use this one to get next frame. Which takes a previous frame as an argument. So whatever frame we're up to, it'll check its frame number and try to get the one after that. Get and frame number returns the last frame's number. Can be useful. And another one, frame get frame int frame number. So you can request a specific frame by frame number. And we're going to do this one later to do load animation. We're going to deal with that later, as I said. So we're going to deal with that later. Cool. Alright, so we got that. That's our header file. Let's add a CPP file now. Cool. And again, lazy, gonna copy these. Although it's probably not going to save me heaps of time because I got to delete a lot more. Get rid of the default value in this one. You only need to define the default value once. Now it's going to freak out. We've got to do a few things. I'm going to say every one of these functions belongs to the animation class. Just make that a bit more obvious. There we go. And then we open and close these brackets just so we're ready to start chucking code in. Cool. Alright, first one's pretty easy. This name is equal to name. If you can't remember how this works, it's basically a special pointer pointing to the current object that we're talking about. So in this case, this is this animation that we're working on. And it's mostly used to disambiguate this situation where there's a class attribute called name and there's an argument that's been passed in called, well, parameter, sorry, called name as well. So you can see that this one's gray, this is gray, so this is the one that's been passed in, this is the one that belongs to the class. There's other reasons you might use this as well, but that's the first one, I guess. Alright, that's all that one has to do. Constructor's pretty easy. Move on to get next frame number. So if frame number plus 1 is less than frames.size, return frame number plus 1, else return 0. Now with a lot of your animations, they're going to loop back around, so that's why get the next frame number going back to 0 is okay, because we're going to start our index at 0. So the first frame is at 0, second frame is at frame number 1. So we're going to use this to either get the next frame number, but if we exceed that size of frames, then we're just going to return 0 to go back to the start again. Get next frame. This one returns, we're going to call another one, so get frame. So this function that we're going to define down the bottom down here, you get next frame number, so the one that we have above, we're going to pass it the current frame's frame number. That's it. So get next frame passes in a frame and goes, okay, let's get the next frame number after that frame, so the one after it, or loop back around to the start and get that frame and return that. So we're using a bunch of other functions that we've got here. It's kind of handy. Get end frame number, return frames.size -1. So if you have 5 frames in the list, the last frame number is 4. That's only because we start at 0. This one's not as tidy, but it's okay. So get frame if frames.size is 0, then return null. So if our animation has no frames in it, then return null. So this frame pointer is going to be pointing to nothing. Otherwise, we're just going to build a iterator to deal with our list. I is equal to frames.begin. I'll just explain what this thing does if you haven't seen it before. So we have a list of frames, right? That's this type of structure. It's called frames though, but this is the signature it takes. Now we're building an iterator to help iterate over lists of frames. So an iterator is something that helps you navigate through a list. So think of it as something that points to just one item in the list, and you can use it to go back and forth one item at a time to cycle through all the items. So in making this iterator point to the first frame in the list, so frames.begin. So point iterator to first frame in the frames list. Just going to make a little counter, count 0. This is probably not the most elegant solution, but it's alright. I try to build fast rather than, well, I try to make stuff efficient where possible, but I don't break myself trying to do that. So for counter equals 0, counter is less than frame number, and counter is less than frames size -1. So it has to meet, hang on, didn't mean to do that. Let's get rid of that, yep. So it keeps looping while this is true, which is the counter has to be less than the frame number that we're after, which if it's 0, then it'll break out, that's fine. So if it's 1, it'll cycle through once. and the counter has to be less than the total number of frames we've got -1. And I could have used get end frame number here, so I could have done n less than get end frame number, but that's okay. And increment our counter as well, so counter plus plus. And all I'm going to do here is increment our iterator, which means make iterator point to the next frame in the list. And I'm just going to do that, I guess, using this counter. I'm just going to just iterate through this list until we're at the right point. And then, might break this into 2 steps. Yeah, I think I will. So, frame is equal to just gonna, when you dereference an iterator, it gives you the actual value of the thing that you're pointing at in the list. So for frames.begin and we dereference it, it gives us that frame. So that will be pointing, we'll have that frame object to play with. Now, because I want to make this a pointer, because that's the type that I want to return, I want to get the memory address of the frame in the slot that we're pointing to. So it's a bit crazy, but basically, make frame point to the frame inside the list our iterator is pointing at. And I'll put a note here. Is equal to gets frame at i's position in the list. Sort of. It's, well, I isn't really like a position based thing, it's more of a memory address type thing, so it's a bit more fancy than that. And then that ampersand is get the memory address of whatever is on the right. So this part takes us down to getting a frame, like a frame object, and this will get the memory address of that frame object. So we're storing that in this pointer here. If this is going over your head a little bit, you should go over pointers again. Pointers and referencing and dereferencing. This is your, whoops. Dereferencing. And this is referencing. Okay, and all we got to do is return this frame now. Cool, I think that's everything for this class as well. So get frame, just to give you an overview of this one. If there's nothing in the list, return null. Otherwise, get our iterator to point to the first position in our list of frames. And based on the frame number you're asking for and the size of the thing, it will try to move the frame counter up to where we're trying to get to, the frame that we want. And then using that iterator, we get the frame out of it. And then, well, we reference the frame that's in that list and return it. Like I said, if this part here is getting you a bit, then go over pointers, referencing, and dereferencing. If this stuff's new to you, it's alright, we're going to use lots of list stuff. They didn't teach us this stuff at uni, and they should have, but we're going to use it a lot, so don't worry, this is sort of not how you'd normally use it anyway. Alright, cool. Next one is animation set, so I'll see you soon. Cool, we're up to animation set. Animation set holds an animation, well, a bunch of animations, and animations hold a bunch of frames. So we're almost there. So, add new header file, animation. Ah, animation set, my bad. So animation set. So if not defined animation. Can't ever seem to type all in caps very effectively. That's okay. I'll just paste that instead this time. Okay, so all we really need to include here is the animation header file, because everything else we need is included along the way. Cool. Using namespace std class animation set public. Good. So far so good. Alright, good. Now, a bunch of things that we need for this is string. We need a image name. So this thing holds the sprite sheet's name. And we also have this thing loads up the sprite sheet itself. So holds the sprite sheet image for all of our animations. So you'll have an animation set for the cyborg, an animation set for the enemies and stuff. You get the idea. So an animation set for each different set of animations, each thing. Now I'm going to use another texture here, and it's up, like normally I would just run with a sprite sheet, that's fine, but because I want the enemies and hero to flash white when they get hit rather than go into like a hurt animation, I'm building a white sprite sheet, which by default is null. Not every animation is going to need that, but I'm going to build this white sprite sheet through code. So I mentioned that SDL surfaces let you access pixel data, which is very handy. So what I'm going to do is load up a sprite sheet, access its pixel data, and make another SDL texture using basically swapping out the colors in the original sprite sheet for white, but leaving the see-through color, whatever color you deem to be the see-through color, which I'll tell you about when we get there as well. So I use this sprite sheet to show damage. So depending on your games after this, you might not use this one. Okay, now an animation set obviously has a list of animations. Animation, there we go. Animations. We're just going, well, I guess we don't really need that. What do we actually have to build here? Not many things, which is good. We need to build, let me just check one thing. Ah, yes, we do need that. Now, we don't need a constructor because it doesn't really need to set anything up. We're just going to build one of these things and start loading information in instead. But what we do need to build is a destructor. So our destructor properly cleans up any dynamic memory, e.g. textures. Cool. There's only two functions we need here, so it's this one which returns an animation pointer, so animation get animation string name. So this function basically just looks through our list of animations, checks the name of each animation till it finds a match, then returns it. And then again, we just got to do load animation set, which, like I said, we'll deal with later. Just deal with, well, I only have to make two functions. That's pretty easy. Alright, so let's add the CPP file. New item, CPP, animation set, cool, include that header file. Go back to your header file, be lazy, copy that, check it there. If you can't remember what a destructor does, basically when an object of a class gets destroyed, this little cleanup function gets called automatically. It takes no arguments and has no return type. Oops. So it's just a cleanup function that belongs to the class. And all we're really going to do is clean up the sprite sheet. And if we've decided to have a white sprite sheet, so if it's not null, then clean it up too. That's it. That's all it has to do. And that'll save us from having memory leaks, which suck and are really hard to trace. Alright, get animation. So basically we're just going to loop through the list until we find it, and then once we do, we'll just return it, otherwise we'll return null. So list animation iterator, so that thing that I mentioned before. So this thing is going to iterate through my list. Rather than calling it I, let's just call it animation. It's probably more confusing, but that's alright. So this thing points to a position in this list that we're going to work with. So we're going to make it point to the start of the list. Did I not give it a name in the end? I guess not. Animation is equal to animation, so begin. So our iterator is called animation, and it is pointing at the beginning of this for loop to the start of our animations list. So it's pointing to the first animation in that list. Now, as long as that thing is not at the animations end, then keep going. So animations.end gives you the pointer, the memory address of the position just after the list. So it will give, so as we iterate through one animation at a time through our list, as soon as we land on this other memory address that's just outside the list, then it will go, oh, I'm out of bounds, so I'll exit. And animation plus plus will move us one item down the list or through the list at a time. It's kind of weird that you get plus plus, use it that way, but it's handy, at least it's shorthand. Now we want to, I guess that's what, yeah, so we're just gonna make an animation pointer anim is equal to, we're just gonna dereference this thing again like we did last time. So get the memory address of the animation at that point in the list. So at this point in the list, give me the animation and then give me the memory address of that, so that we can just have this thing point to that animation. So if name is equal to anim's name, then return anim. So if the animation, cycle through every animation list, if any of them equals the same name as what we're asking for, then return it. If we find a match on name, return that animation from the list. Otherwise, return null. So we do a null check whenever we deal with getting animations, because it might give us back nothing. So if you type in some other weird animation name that doesn't exist, you're going to get nulls back. So rather than trying to animate a null and having a null pointer exception, we should check for nulls as we go along. But that's future us's problem for now. We just done what we need to do for this class. It didn't have that much in it. That's all we had to do. Cool. Next step is to do the loading. Load all this animation stuff up. And we'll do that next time. So finally, we're up to the part where we're going to load all this information in. Now, this information, if you check through your res folder, you'll find this thing called Udemy cyborg.fd set. Now, if you right click that and open it with some sort of text file editor, I use Notepad++. It's basically just a text file, and it describes at the beginning what image to load. So cyborg.png tells you how many animations it has, and then it starts basically just going through each thing. It'll go through the up animation, has 4 frames. First frame. Now you can see that this frame part is replicated just to show the difference between this is a frame, this is a frame, this is a frame. You get the idea. Very helpful. Now every frame has a clip region, so that's where it is on the sprite sheet. The offset, duration in seconds, so 1 is a second, so that's 0.1 of a second. Index 0, so what frame number is this? And then extra information, which is frame data. This is collision box stuff, which I didn't end up using. I decided to go with a Cody collision box, which created less issues, but this is still here. But later on down the track, when we start doing attacks, wherever that is, /up. Yep, /up, frame. Second frame has a hitbox. So you can see some frames have extra frame data. So the attack frames have hitboxes to describe where they're hitting and how much damage they do. So there's a lot of information here, and I'm going to make your life easier. I'm going to give you the code for loading this stuff. I'm not going to subject you to writing it out as I write it out. It'll be painful for both of us. But I'll explain what the code does, and then you can look through it in more detail if you want to tweak it or do whatever you need to do. But as I said, this code that I'm going to give you is going to make your life easy. If you want to use this tool to build animations, outputs those FD set files, then this code will load it up. So it comes with the default stuff, duration, offset, and then whatever extra details you want to add. So maybe you want to add another hitbox here, let's say. Just draw it on. But I don't actually want to do that. Just cancel that. But you decide what types of data you want for your things in this tool. So you can say I want frame advantage data on each frame, then you can decide that that's the type of thing that your stuff can have. But I'll go into this thing in detail another time, or you can just check out the link for this and it will explain it anyway. So anyway, let's get back to it. So we want to read this information in so we can start animating stuff with a bunch of information attached to it. Like I said, I didn't want to subject you guys to it. We just got to write one little function inside globals to fix things up. And that's this thing called clip off data header. Now I'll just get my cheat sheet out just so I can, well, cheat. There's no way I write this entire thing off the top of my head. Alright, so static string clip off data header. What this function does is see here in my FD set file for Cyborg, I've got clip and a bunch of values, so x, y, width, and height. What this thing does, if I jump back in my code, clips off header, e.g. this turns into, but without the clip part at the front. So it just knocks off the word and colon. So it would just give you whatever's on the right hand side of that colon, basically. And I'm just structured globals because it is kind of useful. You might find yourself using this every now and again. It depends what you do. So we jump into our globals source file, paste that there. We're going to define this thing. If you got taught C++ at uni or a college, probably they put you through a lot of string stuff, so hopefully I don't have to explain too much of this for you, but I'll say it as we go. We want to find the position on that string where the colon is, starting at index 0, which is the first letter in the string. So that returns where we find the in the string. Otherwise, return -1. So if pos is not equal to -1, data is equal to data dot substring that position +1, so just after the colon, and go for data dot length minus position +2. It seems to work. Basically just build a substring of whatever's left of the string and just replace the original string with that, and we'll just return it. Yep, cool. We're just going to need that one for our loading stuff. That's all. Okay, so let's go to our frame. Wherever you are, here you are. To do load frame, that's what we're up to there. Might take this jacket off for this one. Okay. Now I've given you the code for this, but we've still got to type out the prototype. So load frame takes a input file stream, so reading from a file basically. We give it a list of data group type called group types. Yeah. So give it the file to work with and a list of groups. Now that list of groups is something we'll use later. Basically, we're going to hard code the extra groups of data that we're going to be looking for each type of thing. So for us, that's going to be hitboxes and damages and collision boxes and things. So we give it this group and it goes, oh, I should look for that inside this big file. So collision box and hitbox and damage. I'll store that inside of your frame data list. So that's what that's about. Okay. Go back into your frame source file. Now, I provided all the load functions here. So load frame, just download this, copy, paste, good. This thing basically explains how it reads it, but I'll do a quick rundown. So that groups types that it's brought along, so what types of groups to expect, build that into empty groups for our frame and chuck it in frame data. So it'll build a collision box group, a hitbox group, and a damage group. And they're basically just a list of different data types that we will be empty unless we read it in the next step. Next, string buffer, just something to store what we're reading into temporarily as we go along. So get line, read from the file, one line. Buffer, now it's going to read this first part, which is frame, which is up. Just chuck this to the side for the moment. That is here, frame. So it's reading that first. It's not terribly useful, so it's just going to skip past that. So it's going to move on to clip next. So clip, read clip. And we build a string stream. String streams are very useful for building strings and reading from strings. Very helpful. So a buffer is equal to clip off the data header, chuck buffer in there. So using that global function that we just built, basically just goes and cuts off this part of it, the clip colon, and just gives the 50, 114, 44, and 49. We stream that into our string stream, and then we stream it out. Oh, sorry, we'll stream it out to our string stream and stream it back in like this. So you saw that it had 4 values, x, y, width, height, which is a clip x, y, width, and height. This is why string stream is very useful. No doubt you've used C in, C out to do basic input-output for a little console window, hopefully, to get this far. You'll probably have noticed that streams are very good at dealing with types. So it goes, all right, we're going to read in part of this stream into this thing, and this thing is an integer, so I'll convert this section into an integer. So it reads that first 50, convert that from a string basically into an integer and store it in this variable, and so forth. So when you're streaming stuff like this, it's very similar to this. So cn clip.x clip.y. You get the idea. So using cn, it's the same process. So it'll read up until a new line character or a white space. So that's why we're able to read in just that, and that all in the one line out into these 4 variables. Very helpful. Okay, read in the pivot point, duration, index, and then load all the group data up in the files that I got you to include earlier. So that group builder builds it for you, and it just deals with loading that information. So it goes, okay, is collision box something we're looking for? Yes, it is. What type of data is it? Is it a string, a box, a point, or a number? Okay, it's a box. I'll create a SDL rect and chuck it into the collision box list inside of our frame data. So that's what that's doing in there. That's doing a lot of the hard work, and that's it's not a bunch of code that I really want to explain unless you really want me to go through it later, but hopefully it sort of explains itself along the way. Mostly I'd rather you just dump this code in if you're going to use frame data sets. Okay, onto animation. It's got to load as well. So frame takes a input file stream. That's because we're going to get the animation set to build the input file stream and pass that input file stream all the way through animation and frame. So we'll go into animation next. We've got to build its prototype for this function as well. So void load animation, and help if I could spell, which again takes an input file stream and that list of data group types, which it doesn't use, it just passes on to any frame that it builds so it can load that frame up properly. Yep, so type that in. Let's go over to that one. This one's relatively short at least. So in the source file for your animation CPP, we go and check that one out. Load animation, copy this, paste. And that's good. Void. Didn't copy it properly. Alright, cool. So, this is at this point in the file. So, it's an animation name, so in this case up, and then read the number of frames next, which is this section of it. Then basically for the number of frames, do a for loop and just keep building new frames and calling their load frame function and pass that file stream along. So it will call that load frame code that we just sort of looked at before. And that's all that one does. Okay, onto animation set. So go to that header file. This is the biggest one because it does a lot of image loading. So void load animation set string file name list data group type, group types again, plus a bunch of extra ones. So bool set color key is equal to true. Oh, actually, I've got it set as false. So what is setting a color key? If we look at our assets and we look at our cyborg, not BMP, but PNG, the background is this sort of weird purpley blue color. Now, in SDL, if you load up an image like this which has no transparency, you can set the color key, which basically says, which color out of this image should I make the transparent color? So we're going to make that an option here. So do we want a color key, yes or no? Sometimes you just want a background that doesn't have color key information. Okay, next one. Int transparent pixel index. Now this means you've got to know a little bit about 8-bit images. This only works for 8-bit images. So if I load up my 8-bit image into some sort of pixel-based program like iDraw3 here, for instance, I can open up the palette and see all the colors for this particular file. Now, indexes start at 0, and you can see this number here says what index we're up to. So index 0 for me is that see-through color at the back here. I'll just show you by changing it to some weird color. See how it changed all of that background color to that gross mustard yellow. Alright, so index 0, I want to make index 0 out of this color palette be see-through in code. So that's what that is for. It's saying which index should I make that. So the only way you'll know about this stuff is if you are working with your own assets, I suppose. If your image is a PNG with transparency in it, basically set this to false, and it doesn't matter what you set this to, it doesn't matter. It already reads in that transparency, but I like to work with non-transparent PNGs. It's just lets me work with pixel programs a lot easier. And finally, bool create white texture is equal to false. So I'll set this true if I want to build a white texture if I want to have the normal texture that shows the character running around, and then the same if I want to have that same image again but replace all the colors with white except for the see-through color, then that's what this one's for. So I'll be using this one later. Cool. Let's go over to animation sets CPP file. Go down to the bottom there. And I've already given you this, load animation set.txt. Now this one's big because it caters for quite a lot. We don't need that. No. I'll actually delete it from here as well. You don't need it. So this will be in the video, but not in this file when you get it. Okay, so just dumped at the bottom of this CPP file. It tries to explain it in quite a lot of detail as it goes. It takes a file name. So which file should I open up? So it creates that input file stream that would pass along. Okay, it tries to open that file. If it worked, so is good, then read the image name. So at the top of this FD set file, you can see it's got what image to load, so cyborg.png. Gets that. Now, if color key set, then load this thing up as a surface first. Set the transparent pixel using set color key, and then convert this sprite, this SDL surface into a texture for our sprite sheet. if we need to create a white texture, then load up this thing called allwhite.png, which is just in res. This first one, it's a really small image that's just completely white, and I'll show you why I've got that one. Open all white. No, I don't want to make changes to that. It's a 1 by 1 pixel image, and I'm not sure why that's pink, but everything here is pretty much white except for this color spot here. And basically it goes, load up that really tiny image and replace the color palette for our surface here, and then create our white texture. Then clean up our SDL surface. That way we're just keeping the SDL textures out of this. So it's just build that surface just to do some stuff. Otherwise, if you don't really care about programmatically making something transparent or building new textures using other things, color palettes, then just do sprite sheet is equal load texture, just the way we did it before at the start of this whole thing. So very simple, it just builds a texture for you. Alright, next thing it reads is number of animations, which is this part here, which for us is 17. Then it runs a for loop, which basically just keeps building new animations for however many it read. So for us it'll run 17 times, build a new animation, call its load animation function, and pass it that file stream, give it that grouped types thing, and add that new animation to the animations list. And when it's done, close it. So animation set has a load function that loads it up, which calls animations load function, and the animation calls frames load function. And then it cycles all the way back out of here, and then animation set closes it off. Alright, that was pretty hefty, but it lets us load in a bunch of useful information. And well, you have it as code now. It's not just some weird library. That means you can tweak this if you need to and do whatever you want. So if you want to have like an all red texture, you can pretty much work out how to do this stuff if you want to. I'll happily explain it if you contact me. But it's not the main part of this course, so let's keep going. So that's it for loading. We will build something with that very, very soon. Cool. So I've just hit another theory-based class. So this time is polymorphism. Probably my favorite thing in C++. So hopefully you're good at building a class of something and then building another class that inherits from that, which does something a bit more specific. So hopefully you're good at inheritance at least. And obviously building a class gets you encapsulation. You can look this stuff up if you want, it's alright. But what we're going to deal with is polymorphism, and I'll tell you why that's awesome. So we're going to build a class called entity. Sits here. And an entity has a few basic attributes, but mostly it's got these two functions called update and draw. So these functions at the moment don't do anything. An entity is an idea. This is an abstract class. So good thing is we can use inheritance to start building things out from this. So typical things an entity would have would be a x, y, I guess animation stuff, so whatever, frames, etc. Useful stuff for things in the world, in the game world. So, but it's just a concept. So we can start building things out from this. So we can go, alright, so we can make a hero. Our hero is a type of entity, and we make a more specific version of update and draw, depending on. So these are overridden, so I guess I'll mark that in pink for now. Plus there has other functions that are useful too. It's like attack. In our game we're gonna have dash, and let's just chuck in die as well. Cool. So hero has a more specific version of update and draw. Okay, cool. Maybe we build some enemies and enemy, which also has its own version of update and draw. Update and draw. So a player update might deal more with user input and stuff, whereas update on an enemy's one might deal with AI. We're going to have walls or obstacles, and then anything else you want to chuck in. So in one of my other games I had traps and items. Now the good thing about this is I can make a big list of entities, and using polymorphism I can call every entity's update and draw function, but it will call the more specific versions of each of these. So while I'm referring to hero as an entity, I can only call functions on it that entity knows about, which includes update and draw, which is good. But the thing is, if I've overridden update on hero, it'll call hero's update, which is good. So I can pretty much just build this big thing where I just go for list. It's going to be a little bit different when we get to the code, but list entity iterator. Oh, I can't spell apparently. Iterator I is equal to entities dot begin. Doesn't matter if this is legible or not. I not equal to entities dot and I plus plus, and then inside the body of it we just go I dereference and call a function or data member at the same time. I update, I draw, if I want to do it like that. And that's pretty handy because what that's doing is well, we'll probably split it into two, but the idea is we just keep chucking in all these types of things because they all inherit from entity, so they're all inside this big, hold on, well, I can't reach it from here, entities list. So everything's in this entities list there. So all these things are of type entity, so inside this entities list is items, walls, enemies, heroes, traps, if you got bullets, bombs, explosions, everything. It's all in this big list, and we just, with a very simple loop, I can update and draw everything in that list if I wanted to. That's thanks to polymorphism. So polymorphism is basically treating in more complex versions as their simpler versions or as their parents, but calling a function that's common to both of them, but it'll go and look up the more advanced one. So whenever we call update on entity and that pointer is actually pointing to a hero, it'll call hero's update function, which is why polymorphism is so awesome. Because for a game developer, you can cut heaps of corners this way. There's lots of stuff we can just like chalk up to inheritance and lose things along the way. So The structure that we're going to build, I'll just make a new thing. We're going to go entity, goes out to we're going to branch it into living entity. I should have the arrows the other way around to show which way the inheritance is happening, but it's a force of habit to branch out. Okay, and then from that we're going to have a hero, and we're going to make two enemies for this project, so grubs and globs. Also, we're going to have walls as well, stuff to bump into. So that's what we're going to build next. Using polymorphism, we'll take as many shortcuts as we can. Cool. Well, I love polymorphism, so I'm looking forward to this next part. So, we'll see how we go on the next one. On to code. So this is going to be a big one. We're going to be building the entity class that everything sprouts out of. So the entity class is going to have basic attributes relating to something existing in the game world. I'll have a few functions that are supposed to be overridden to make things more interesting, and also a bunch of helper functions that help with very basic situations. So we are going to do most of it now, and then a little bit in the next video, because we're going to break collision stuff out of this. But let's just get started. So let's build a new header file. Same deal that we keep doing. So entity. Let's see if I can scooch up close to my chair. Cool. Okay, include. Smooth. Alright, if not defined entity. Do that. So this thing needs to include globals, just in case. The time controller, very helpful to be able to deal with time. And the animation set. Now, this class that we're going to build is going to be an abstract class. Pretty sure we make it abstract. Let me just double check. Yes, definitely. So I kind of like to keep note of that. So I tend to put that up here, abstract class, which means you cannot instantiate an object of type entity. I can still make entity pointers that point to heroes and enemies and things, but I can't go, e.g. cannot do entity e is equal to, well, I can't do that. I can't build an object of type entity, but I can have entity pointers. They're okay. You probably see me do everything as public. I know it's good standards to have public and private things, but most of the time I'm game developing by myself or with my brother, and honestly the quickest path to getting a game done and out there, the better, because usually it's a hobby and it's in our free time. And I don't want to have to build getters and setters for everything that belongs to a class. I just want to be able to manipulate aspects of it whenever. It's your call if you think that's a good idea or not. For me, it definitely works to make everything public though. Okay, we've got a few reference constants to deal with first. Now they're to do with basic 4-directional movements. We're going to reference these in our game because our game deals with 4-directional, mostly well, they can move in 360-degree angles in this game, but the characters' animations only face on 4 different directions, so up, down, left, right. So this is going to be our reference constants for directions. Direction up, down, left, and if it can't work it out, none, but I don't think we'll end up using that. We're going to have something called a state. So a state is a variable that keeps track of the state of this entity. So it'll be different from each thing. So from a generic entity point of view, entities have states, but the types of states a thing can be in is dependent on the other children classes that we're going to make that inherit from entity. So a hero would have states like attacking, walking, idle. You get the idea. So it's like it's a quick label to see what the entity is up to. Alright, so we got a lot of things that we need to have an entity in the world. So they live on 2-dimensional planes, so they have an X and a Y. I have a direction here that's relating to the 4 directions up the top, up, down, left, right, or none, I suppose. Are they solid? So is this thing solid? Can things pass through me? So usually everything's solid by default, unless your game has a lot of non-solid things, then just swap that default value, whatever's going to speed up your code. Collide with solids. So this is also true. I may be solid, but I may ignore other solids. So things may bump into me, but I may not bump into them. So if you want to set that up for any reason, that's why I've got this here. So sometimes we are solid, but I pass through other solids. It's kind of helpful. Another Boolean, active. So entity turn on or off. It's basically what I use it for. I'm supposed to put comments there. There we go. So if an entity is not active, it's considered off. And I use that to delete things or make something go away and then come back again. String type is equal to entity. I tend to use this to help check what type of entity it is. So while I'm using an entity pointer, I can check the type, and if it's a hero, then I know it's a hero, so I can convert it back into a hero if I need to. So what type of entity is it? E.g. hero, enemy, wall, etc. is the entity moving? Yes or no? This helps just deal with movement stuff later. Float angle, so this is for movement. Angle to move entity in, so this is 360-degree angle. We're going to mathematically work out how to move our character around. We got move speed and move speed max. They're pretty self-explanatory, like how fast we are going and how fast we're allowed to go if you want to cap it off. Slide angle. So I consider angle and move speed max something that an entity is voluntarily trying to do. So they're trying to move in that direction, whereas sliders, they've been pushed by something. So the above, it'll use the above first, then it will slide them. So direction pushed in, float, slide, amount. This is the amount of push in the slide angle. So how hard do we push them from that angle? Sliding is very helpful for when enemies hit you and you get bounced away from them. That type of thing. Float. Move lerp is equal to 4. We'll get onto this later, but this here helps, I guess, it smooths out movement, and 4 seems to be a pretty good one that we've found here. We'll use it in some math later, but I figured I'd make it part of the entity so you can change it if you want to. Basically, it's going to be used in the movement algorithm that we'll build later. I don't think I even use these by the end of the tutorial, but every time we move per loop cycle, we're just going to keep track of how much we move on the X and Y axis, just in case we have to retract it. So it keeps track of total XY movement per movement turn, I guess. Just in case we need to retract movement. Alright, so more things. So SDL rect, the collision box. So this is the box describing the size of our entity and how it and this is used to bump into things. So if you have an entity that's, well, basically it's sort of a bounding box. It's not the entire pixel character, it's just part of it. We'll draw these later, you'll see in game running all our collision boxes, but it just describes a region of our character that is allowed to bump into walls and stuff. So because we're doing a 2.5D game, we'll want, say, the heads of our characters to be able to walk, I guess, sort of through stuff so that it looks like the characters overlap each other. So just their feet area sort of bumps into stuff. You'll see, it's sort of hard to explain. Last collision box. So that's to do with movement and collision stuff. So where our collision box was last. And just some, keep track of these as well. Collision box width and collision box height. This is default collision box sizes. So if we change our collision box all sorts of weird shapes and want to return it back to some default values for our character, then that we store those in there. And collision box Y offset. So from my entities Y value, where should I draw this collision box? Where should I sit this collision box? So the collision box will center itself horizontally for our entity, but then I want us to have control of where it sits vertically on that entity, that collision box. So I'll just kick open Photoshop and I'll show you what I mean. So if I have here's our dude here. So here's our guy. Now I want just a certain area of him to be bumping into stuff. So because it's 2.5D game, I only really want his collision box to be hitting, like bumping into stuff here. That way his head can overlap other objects, so other things can be down here underneath him, and it'll look right because of the perspective that was sort of set. Let's get rid of that guy there. Okay, so the center of our guy centers out where we're going to put our box horizontally, but the Y of our character, let's say, is here. I'll use pink. Our XY value for our character is here, so I want to control where this box is on the Y axis. So I don't want it centered out, because if I centered it out, it would draw it more down here, which is not a useful region. So I want it a bit more up. I don't want it centered. So that's why I've put that Y offset in. Yeah, so that's what that's about. Alright, we need these things as well. So we need a animation set, so everything in the world has some sort of animations or something, so you can see them. Animation, we're going to keep track of the current animation. So this is, first one is our set of all animations this entity can have. This is the current animation the entity is using. Frame, the current frame in the above animation the entity is using. So that's the current frame. And a frame timer helps animate frame to frame. Alright, that's a lot of values that an entity can have. and it sort of just sets them up in how they exist in the world, how they move in the world, and how they look in the world. Next, we go on to all of our functions that we need to build. Now, to get that whole polymorphic effect going on, we have to make sure that the functions that we are allowed to override are virtual functions. So for those first two, virtual void update, yep, and virtual void draw. There you go. There's the two that we mentioned. There's also a bunch of other useful ones. Virtual void move takes a float angle. Now, a lot of these later ones, I'll be putting all of the code inside entity, and for the most part, I won't change it through the inheritance change. So I won't override move very often unless I really, really need to. But I want the option to override it if I need to, which is why I've got virtual here. If I don't have virtual here, and I call move while I'm referencing this as an entity, it'll call entities move, which is not what I want. I want to use whatever the sub-entity's value is. So let's keep going. We've got move, which basically just moves an entity in a direction. We got this update movement function, which deals with movement and sliding. Update collision box. So based on movement and stuff, it'll move the collision box around. And more useful ones, virtual void change animation based on int new state bool reset frame to big. Oh, I wrote the wrong word before, but beginning. Sorry, I wrote in my cheat sheet I had reset frame to begging, which doesn't make any sense. Alright, so change animation. You give it a new state, and this is dependent on which thing that you are. So if you're a hero and you say your new state is attack, and you say reset frame to beginning, so if it's a new state and you want it to start from frame 0 of that thing, then set that to true, and then change the animation for that entity. Now, this is dependent on each entity, so I'm making this fully abstract. This is an abstract function now. And this is what makes this class abstract. If you have any abstract function in here, then it makes the entire class abstract. So basically it means if I put equals 0 here, it means I'm not going to define any code for this function in this class. I'm not going to do the full implementation. Let's keep going. Virtual void update collisions. So I'm going to get back to collisions later. So how we bump into stuff in the world. So we'll get back to this guy later. Alright, let's keep going. And a whole bunch of helper functions that I've built. So helper functions, static float distance between two rects, as in rectangles. SDL rect pass by reference rect1, SDL rect 2. 2. Okay. Static float distance between two entities, which basically uses the above code a bit inside the other one I just referenced, which takes an entity pointer E1 and an entity pointer called E2, and it just gives back the distance between those in pixels. Sometimes we want to know the angle between two entities. So a lot of these ones here, distance and angles and stuff, I just looked up basic formulas for that online and just converted that into code. This is not something I worked out on my own, and there's tons of resources on how to work out angles and distances and how to push things around. But we'll be doing it anyway, so it's okay, you just copy off me, right? Okay, check collision, which just checks if does a collision box, does one rectangle overlap another rectangle? Static int, angle to direction. So we had those 4 directions up above, and I said that we move in 360 degrees, but graphically our characters appear to face only in 4 directions. So this converts an angle to one of those directions up there. Very helpful. We're gonna need the angle between 2 points. It's also helpful. Which is just gonna be float. CX1 float, CY1 float, CX2 float, CY2. Using very basic math stuff for that one, and static float angle between 2 rects. So it's good. SDL rect R1 and SDL rect R2. Yeah, lots of these. We're going to be doing all the code for all of this later. I think I'll split this into 2 videos. Okay, so there are all our helper functions. That's good. Just going to make a few more statics. There's going to be a static list of entities. So remember, static belongs to the class as a whole, not individual objects. So by doing this, I'm sort of making a list of entities that's sort of global. It's just one big list that I can keep playing with from wherever. And that is very handy. So this is sort of like a global entities list I can refer to at any time. And to deal with this list, I've got a few helper functions as well. So I've got static bool entity compare. This helps sort entities in that list. Const. I don't think I need this many consts, but this is what the example is that I found online, so whatever, I guess we'll run with it. Don't think I need that many consts. So this thing helps compare two entities in a list to help sorting. Sorts based on Y value. Now, this big old list of entities is in the world, a 2.5D kind of world, so a 2D-ish world. And I sort the entities by their Y value, which means that you can sort of use their Y value as their depth into the world if you're looking at the top down. So using this sorting algorithm will help draw all of our characters in the right place in the world. Well, they'll always be drawn in the right spot. It's more like they'll be drawn and overlap each other properly. That's more what's going to be done. It decides the drawing order of all of our entities. Now, this is just a helpful one. Remove inactive entities from list, and it takes a list of entity pointers. So it just gets a pointer to a list of entities, I guess, and removes inactive entities from the list. So anything that has, remember we set up here, active. Anything that's active is set to false, then remove it from the list. And if delete entities is true, then whilst we're removing it from the list, also delete it. If it's false, it'll just remove it from the list without deleting it, which we'll do with our enemies, I'm pretty sure. And remove all from list with the same argument. So this one doesn't care if they're active or not, it's just going to empty the whole list. And it's up to you if you delete everything or not. Alright, that's a lot. That's a pretty big header file. It's bigger than I would like a header file to be. So I think we'll stop there on this video, and on the next one we'll start implementing all of the functions. So till next time. Okay, so last time we did the entity header file, and looks like I accidentally missed this one. So I did float instead of float angle. So do that. Cool. Alright, we're going to tackle the code now. I'll probably split this up wherever I can. Like I said, I'm going to do collision stuff later. So add new CPP file, entity, include entity. Good. And what do we need to copy across? So go back to your header file, copy these constants. Deal with them first. And just paste that in front of each bit. Is equal to 0. 1, 2, 3, -1. But again, it doesn't matter what their values are as long as they're different from each other. You probably could have used an enum for this, but I don't know, I just prefer to use these in the end. Okay, a bunch of our functions. All of our functions, in fact. All of this. So go from virtual functions all the way down to the end. We're going to copy this across and we're going to fix them up as we go. Alright, so get rid of the virtual and stick entity in front. Update is not going to do anything for the moment. Override me to do something useful. Same for draw. We're making it up to every other entity to deal with this. If they want to, they can actually leave it empty. Oh well, not override it if they don't want to. Just gonna copy that explanation. Yep. Movement. Okay. So let's have a look. Actually, I'm jumping the gun. I actually do have a default set of code for draw. So a lot of my entities draw in the same way. So let's go back to draw. Okay, so instead, override me if you want something else or more specific to happen. So if current frame is not equal to null and they're active, so if this entity has a frame and it's active, then we can try draw it. So all we gotta do is current frame draw, and we reference the animation set sprite sheet X and Y. That's all we gotta do. But for debugging's sake, so this just draws current frame. That's it. But for debugging's sake, I'm gonna draw collision box. So if globals, so our global variables, debugging, so if that's set to true, and it's only useful if our entity is solid. So if our entity is solid and we've got debugging on in our globals section, then we're going to draw the collision box. So whenever you do basic drawing stuff in SDL, so like drawing a box or a circle that doesn't use textures, it uses the current drawing color. So it only has one active color at a time, and you just swap that out and then try to draw with things after that. So it's kind of like, imagine you have one arm and you're drawing on a whiteboard, and so you want to change from red to blue. Well, you've only got one hand, so you have to put down red to pick up blue to draw the circle that you want to draw. So it's like that. You only have one active color in your hand at a time. So you have to remember that to set it whenever you want to draw stuff, because you don't know what the last time your color change was. So you don't know what, from a coding perspective, you don't know if you were holding red or green last. All you know is that you want to try draw in red, so maybe just set it to red again. So you set the draw color, you tell it which renderer to reference, this guy, and RGB alpha. So I've just made it red, and alpha 255 is opaque, or you can do, I can do this if I want, or I can just do SDL alpha opaque as well. So it's up to you. You can type in 255 there, or type in SDL alpha opaque. Basically, it's a constant that they've built, which is just 255 anyway. So if I jump to it, you can see it's just set as that. So that sets the current drawing color. Sets the current drawing color. Doesn't affect textures and whatnot. Just for this stuff, that like basic drawing stuff. So STL render draw rect. So it draws a rectangle. If you do draw rect, it just draws an outline of 1 pixel width. If you do fill rect, it fills in a whole square. So I'm making a red outline of where the hitbox is. Renderer, and you give it the collision box of our entity. So it's going to go, alright, I'm going to draw the collision box using the renderer. That's all you got to do. Pretty easy. Alright, on to movement. Movement's a bit trickier, I guess. No, not really. We deal with all the tricky movement stuff in update movement. Okay, move just goes, alright, set moving to true. So if we're calling this function, we want move to be true. Move speed is equal to move speed max. So we're going, okay, I'm going to just start pushing you in a direction at max speed of this thing. That's fine. It's just, you can change how this works, obviously. Set the angle of this entity to the to the angle that was passed in. Then, just for drawing's sake, oh, that's right, we do it this way. So, new direction is equal to angle to direction. So that function we'll fill out later basically converts a 360-degree value to one of our above constants. So 0 is up, 1 is down. You get the idea. Something like that. Where was I? Here. We want to throw angle in there though. Angle. Yep. So if direction changed, update current animation. If direction not equals new direction, so if they are different, then direction is equal to new direction, and change animation state, the state that I already had, so it's not really changing animation, it's just changing the direction animation. Reset frame to beginning, false. So if you were running right and you were on frame 3 and then you started running up, you want to stay on frame 3 for the running up, but you just want to change the picture from running to the right to running up. So that's what this is doing. The state stays the same, the direction is changing, and the current frame number is staying the same, so that you're in that 3rd frame of that animation. Okay, so that's what move does. It says we're gonna move, and we're just updating how we look. Update movement is a bigger one. Much, much bigger one. And it deals with some collision stuff, but it's alright. We'll we'll skip a lot of the collision stuff for later. So let's move on to update movement. So entity, update movement. So update collision box. So just in case it wasn't quite where we were, just update it to where we are now. And store collision box before we move. So last collision box is equal to the current collision box. So it's copying that value into there. Now we try to do some movement. I'm gonna reset total moves. Total moves, these guys. Total X move is equal to 0. Total Y move is equal to 0. Now, if my move speed is greater than 0, then I work out my move distance based on time. So move dist is equal to my move speed times, in brackets, time controller dot dt times move lap. So if your move speed is like 60 and the dt is the amount of time since the last game loop cycle, it could be like 0.001 times, I don't know why it's in brackets, it's okay, times these two together, so that you get like 0.001 times 60 gives you that, and then the lerp just seems to smooth it out and make it look better. So it's just a constant value to just push it up by. So that'll work out. That's the maximum distance in pixels that we're allowing ourselves to move on this game loop cycle. And it's usually quite small because of this dt. This dt is usually very, very small. So works out move distance using speed dt time since last loop, and multiplies by lerp. Okay, so if your move distance is greater than 0, then we're going to try and move you. So X move is equal to the distance that you want to travel times crazy math stuff. So we're going to deal with math now. So how on earth did I work this stuff out? I didn't. This is all online. This is bearings related stuff. It's basically a formula of X move is equal to distance times cos angle in radians. It has to work with radians, which is what that conversion there is doing. Pi divided by 180, and then times that against angle will convert degrees into radians. So this will work out using some crazy math, which I can't remember very well from high school, but basically it'll work out how far on the X plane we are going to move based on this angle and distance. And we're going to do very similar with y. Using sign this time. Otherwise, pretty much the same. Cool. Alright, so that's our movement. And then I break it up like this because I prefer to take it through steps. So that's, I guess I'll copy that explanation for here. Y, sign. Okay, now I break it up into making these new variables because for debugging cases, I prefer to be able to see this. So x plus equals x move. So I can see, I can check a debug point here and go, okay, that's what the x was before, and that's what it's going to add to it. If I'm having issues with this stuff, that is. And we keep track of this stuff in total x move is equal to x move. Total y move is equal to y move. And if we are not moving, then move speed minus equals move dist. That seems to, because this is a very, move distance will be a very small decimal number, so we'll slowly deduct it off move speed and it will slow us down. So if we start running and we stop, then we'll slide to a halt. And there's a big red mark on my thing. Make sure you get rid of that virtual there at the start of that function. Get rid of all the virtuals in this file by the time we're done. Alright, we're partway through move. We still gotta deal with sliding. Sliding's super similar. So if slide amount is greater than 0, so this is sliding around. Then we work out the slide distance, which is the same deal, slide amount times time controller dt times move lerp if that slide distance basically just works out the distance of how far we've moved without worrying about angle. That's what that slide distance is about there. Same with move distance. So without thinking about x and y, how far did we go? Again, x move is equal to slide dist times bracket cos slide angle this time. So the slide angle is used times globals pi divided by 180 to convert it into radians. And slide dist, I don't even really know what radians are. Some sort of angle-based system that I'm guessing predated all of this degree stuff. It's kind of annoying, but sure. Cool. X plus equals X move, exactly the same as before. Y plus equals Y move. Now, instead of just total move and total Y move equaling these values, we add it on top. So total move plus equals X move. Total Y move is equal to, plus equals Otherwise, let's see. Oh yes, and slide amount too. So make slide amount minus equals slide distance. It's fine. It's just something to help it decrease in some way. If your slide distance is 0, then else slide amount is equal to 0. So just, don't know if that's necessary, probably not. Cool. Now this last little bit, we're gonna go into collision stuff soon. So now that we've move the collision box up to where we are now. So update collision box. To help with collision checking, union collision box with last collision box. And that is going to be the first thing that I'm going to explain when we get on to talking about that. But it builds basically a big rectangle based on two other rectangles. So you give it rectangle 1, rectangle 2, so I'm doing the current collision box, the collision box of where it was before we did all this movement, and you can store it in a resulting box. So I'm just chucking it in collision box again. I'm just okay with that. Probably should have had 3 collision boxes to do all this stuff, but it's alright. I'll just reuse this one for down here. It's okay. And I'll explain that in the next video, which I might as well get onto now. Actually, wait, before we do that, get rid of this. See this abstract function? Kill that guy. Good, because he's abstract. He doesn't have implementation that we need to do. So the next two are update collision box, which is pretty trivial, and update collisions. This one's gonna need a bit of explaining before we get into this. So that's what the next video is going to be about. And then after that, we'll fill out the rest of this. Cool. Alright, see you next time. Alright, so this video is going to be on the concepts of collisions in a little game like this. Now, there's lots of different ways you can tackle collision checking and resolution. There's lots of existing algorithms and stuff out on the internet and in books and whatnot. It's been around for ages, obviously. Generally, the more mathematical you go, the better it is. But for this little game, I just came up with a fairly simple-ish collision detection. So the way mine works is you got your guy here, and there's a bunch of walls, let's say here. And some sort of enemy here. So here's us. Cool. Alright, now what we do is we move our character before we check any collisions. So based on their movement and sliding, we work out that they've moved to, say, here without checking anything. So like think so. There's that guy. Cool. Now, I didn't want to check it frame by frame, oh well, pixel by pixel. That's a bit too tedious. And the catch is, whenever you check, if you're colliding with something, you have to try and narrow it down to, I don't want to check every entity in the world. That can be very costly. So, you saw at the end of the last video that I unioned collision boxes together. Let me just find that. So union collision box and last collision box. So that's this here. So our last collision box was where we were. So last, and where we are now is our collision box. So what I did was unioned them, which means it basically just makes it a big rectangle just out of those two rectangles. Using that as a guide, draw a bigger rectangle. So here's our big area here. Cool. Now, the way my collision checking stuff works is it goes, okay, cool, we got this big area. Now, everything that collides with this bigger box, add it to a list. So that's this guy, this bit of wall, and this bit of wall. So we've added these three things to the list. So 1, 2, 3. Then what I do is I just sample along from where we started to where we're going to be and only check against the possible collisions that we just listed. So 1, 2, and 3. The bad guy and those two wall pieces. So I just go, okay, check it there, check it there, check it there, check it there. Well, this is not a very great drawing, but alright. And then, but as soon as we hit something, we're not going to keep checking anymore. So when we got this far, we built this box here. We hit stuff. Well, slightly inside it. Now, the way we check if we're hitting stuff or colliding stuff is when two things are overlapping. We consider that a collision. Not when they're next to each other. They're allowed to be next to each other. As long as two rectangles don't overlap, we're fine. Okay, so we overlap with these two here. Now I'm constantly checking if I'm colliding with stuff as I sample down from where we started to where we're going to be. And we don't check every pixel, we just, what I'm checking is a quarter of the distance of my collision box, move it that far each time and check again. So it's not pixel by pixel. That's not necessary. So we find this overlap with 2 and 3 at this point. So what we do is we forget checking the rest of this collision path, and we go, alright, so this is where we crashed into something. Now, what I found online was one of the solutions for getting out of a collision is to, let me get a better color. Green, you'll see it at least. Is to take the smallest angle out. So because we're just in order, let's say we hit 2 first because it's added into our list before 3, so we're checking with 3. Now out of these two, it's the width on this little area here. Let's zoom in a little. On this intersection, the width is much smaller than the height. So what we're going to do is we're going to push our guy out based on that. So our new spot is going to be here. Now this is not perfect because sometimes you get pushed around in weird ways, but for the most part it's pretty clean. So it pushes us out that much, the width in this case. If the height was smaller on that intersection, then it would push us by that instead. So it does that. If things are moving or we're sliding, we still leave that on, but otherwise we just go, all right, our new position is here. So we're good, we're here now. Yay, cool. So, not perfect, as I said. The more involved you get into collision checking, the better it's going to be. But this one works, well, pretty good. Now there's reasons why I check along the way, and I use this big box. Now, I'll just clear this for a second. Why don't we just check where we are, where we're going to be, and just check if we collide with stuff after we've moved. That's not good, because if we move really quickly in one frame, then we never check any collisions through here, which is not good, which is why I decided to sample along the way down. So check each spot all the way down until we hit something. And that bigger square, the unioned one, just helped me narrow down the scope of where possible collisions could be. So we can only collide with things that exist within this bigger rectangle, and that's only these guys here that happen to touch that. So let's say it's from there to there. So there's a big grey block. So we add that to a list because we're going to keep checking over and over per sample if we hit those things in that sub list. Alright, it's probably getting a bit scribbly now, but hopefully you can sort of see what I'm trying to say. Alright, the next video will be applying this in code. But if you do want to look up some of this stuff online, there's a game called N, and check out that guy's blog, because I believe it's called N, Way of the Ninja. He's got really good collision detection and resolution stuff on his website. He's got a good blog. I'll link that in. And it mentions this mathematical theory called separating axis theorem. Very useful. Not what I'm using here. But they mentioned to maybe check the sampling. Sample you as you go down. Anyway, next video is putting this into code. Cool. Back to our code. Alright, so start on our update collision box. That one's not terribly exciting, so get that one out of the way. Collision box. Oh wait, hold on. Forgot to add this. Entity. Yep. So that it knows that it's for this class. Don't forget that. Because if you forget that, it won't be very useful to you, and you don't get the autocomplete, which I'm totally taking advantage of. Okay, so I'm just updating the collision box. So collision box x is equal to our character's x minus half the width, so that we can get this collision box to be centered. Collision box y is equal to the y of entity plus the collision box y offset. That way, that's just something you set yourself, so it's up to you whenever you're designing this stuff, whenever you make a new entity, how how high up that collision box should be. Collision box width is equal to collision box width, and the same for height. Good. Alright, next one, the main one. So, update collisions. This relates to what I was talking to last time. That concept about checking if we hit stuff and then dealing with that situation when we do. Now to save on getting through all of our entities, I only want to check collisions if they're active and they can collide with solids, and their move speed is greater than 0, or their slide amount is greater than 0. So this seems to work nicely for this game. Basically, I don't check for collisions if you're not moving. So if you're standing still, other things bump into you. Now you might not want that for your game, but for this little game, we've got that going on. So if you want to check collisions regardless of moving or not, get rid of this or keep it. It's up to you. Basically, I don't want to check for collisions if I'm standing still. Okay, now I'm going to keep track of list of potential collisions. So I'm going to make a list of entity pointers called collisions. Good. Alright, 4. Now, I've been doing list, entity, pointer, iterator, entity, and I've been writing out this huge thing which basically means it's a list iterator that iterates over a list with entity pointers inside it. I got trained up through a uni with C++, and the rest of it's been just me screwing around. So there's a bunch of new C++ stuff out there, and this is one of them. So you can use auto. Auto sets the type of the thing based on the return type of a function that you're giving it straight away. So it goes, alright, so you're gonna go hang on. Just accessing a static value, that list of entities dot begin. Now, because begin returns an iterator to the first position in its list, it sets the type of this variable here to list entity pointer iterator, thanks to auto. Yeah, I didn't know about that, but I learned about it just recently, so it's pretty cool. It cuts it down. So if that doesn't work for you, just type in list entity that iterator entity is equal to etc. So auto just sets the type for you. Anyway, not the main point of this. So while entity is not equal to entity class's list of entities, not at the end of that list, then keep going. Alright, so if this other entity that we're bumping into, well, we don't know if we're bumping into it. So if this other entity is active and whoops, hang on, losing track of my brackets, it's okay. And this entity's type is not the same as this entity's type. So the entity that I could potentially be bumping into's type is not the same as my type. That's just to save me time. You might change things again. So I didn't want enemies to bump into each other, and I really don't want to check if walls are bumping into other walls. And if this is multiplayer game, then I'm okay for players to run through each other as well. So that's what this is doing. So depending on the type, then if they're the same type, then ignore them. Also, entity needs to be solid for us to make it worthwhile for us to check. And finally, so if all of that gets true, we'll get to this final one where entity check collision, my collision box, versus their collision box, which I believe this is going to be one of our helper functions that we're going to define a little bit later, not too long from now. Basically it just checks, does this collision box overlap this collision box? If it does, then return true. If it doesn't, return false. So if all of that's true, it means that, I'll put it on multiple lines for you so you can see it all. Yeah, let's do it all like that. Okay, so if this entity in the list is active and its type is not the same as my type and it's a solid and we're colliding with it, then add it to the list. So collisions, that list that we just made at the top of this function, push back. Just got to dereference that iterator to get the entity pointer underneath. Good, add it to the list. If we collide with this entity with our currently unioned collision box, add to the list. So that's because just up here, after we do movement, we make the collision box equal to the unioned collision box, so the really big one. So where they were before, where they are now, draw a big box around that and see if we hit anything. And if we do with that, then add it to the list so we can check it properly. So if we have a list of potential entities we may hit, then let's check them properly to do collision resolution. If collisions, so our list of potential collision entities, if the size of that is greater than 0, good, then we can start checking this stuff. Alright. Now I don't want that big unioned collision box anymore. As my main collision box, I just want it to be collision box. Now, this is set it up so that we just quickly illustrate this. We were here, we moved to here. We temporarily had the collision box of the really big one, which is the whole area. And what I've done is I've set it back to where they've just moved to. So this one at the moment is now collision box, so C box. And this one here is saved as last collision box. I'm drawing with the mouse, it's pretty bad. I should use my tablet, that's okay. So we've got these two here saved on our entity. So I just want to make sure we're using this one instead of the combined one. We don't want that anymore. Okay, so we've got the two separate boxes. Good. So that fixes up our collision box. Now we're going to multi-sample check for collisions from where we started to where we are planning to go to. But first we want to work out a distance that we want to travel, so we're going to go, we're going to make, first we are going to find the sample distance we should travel between checks, which is, so the smallest of the two. So if the width of my collision box is smaller than my height, then I'll use that, and I just want to use a quarter of that. So this is going to be my sample size. So the next, if this is my X and Y, there's my X and Y there. That means that my first check is that far across from here. So that's like about there. Cool. So this first spot I'm going to check is about here. That's what it's going to help us work out. So we need to first find out which is the shortest length of the collision box, and then get a quarter of that. So float. What's a good name for this? Let's go box travel size. That'll do for now. If collision box's width is less than collision box's height, then box travel size is equal to collision box dot width divided by 4. The smaller you make this number, the more accurate your collision checking will be, but you'll find that after a while it won't make much of a difference. So this seems to be a good amount. Otherwise, use the height and divide that by 4. Okay. Good. Next thing, we're going to call this thing, this pink box here, sample box. It's going to move through all those steps to see if we hit anything. So SDL rect sample box, and we're going to make it equal the last collision box. So it's starting in this first position here, and then we'll move it up shortly. But I'm pretty sure we check for collisions where we are first, like where we started first. So use sample box to check for collisions from start point to end point, moving at box travel size each sample. Sure. You probably come up with a better name than box travel size. That's not awesome, but that's okay. Movement angle is equal to, now the angle we're going to move is the angle of where we were to where we will be. So we want to work that out. So movement angle is going to be this here, movement angle. We're just going to work that out. It's pretty simple. We're going to be using one of our helper functions that we haven't made yet. So all it does is angle between two rectangles, and we give it last collision box and collision box. And we'll fill this function out later, but basically it just gets the angle between this box and this box from their center point. Okay, let's get into the loop. Now our control or sentinel value is called found collision, which is equal to false. Whoops. I'll scroll down a bit so we got some room. Okay, while we haven't found a collision, good. Gonna loop through this nonsense. Let me just check one thing. Yeah, that's fine. All good. We end up breaking out early anyway. You don't really need a condition on your loop, but better safe than sorry. Okay, so check sample box for collisions where it is now. Is the first step. So we'll deal with that very shortly. Come down to if collisions found or sample box is at same place as collision box, exit loop. And if we somehow get past all that, then move sample box up to check the next spot. And we'll keep looping through that logic. So first one, check sample box for collisions where it is now. Let's start with that one. So I'm just going to make a rectangle outside called intersection. It's going to be helpful for us because we're going to need that. So I'm going to use auto again. Auto entity is equal to collisions.begin entity not equal to must have spelled that funny. Hold on. Oh, no, I spelled it funny earlier. Alright, sorry. Collision should have an extra I in it, so it's going to break that. Okay. Good. So our collisions list holds a bunch of entities that we may collide with. Okay, so cycle through those. If SDL intersect rect, and you give it it wants a pointer to a rectangle to check rectangle A and rectangle B, and then another rectangle so that you can store the result, which is going to be our intersection one. So we're checking we're checking between our sample box, this entity in the potential collisions list collision box, and we're going to store that intersection in our intersection rectangle. This thing returns true or if there's an intersection, or false if there's not. So it's checking is there an intersection between sample box and the collision box of this entity in this collisions list? And if there is, it will return true, and also update this intersection rectangle with that intersection's information. So it'll give us, let's just draw something here. Let's draw this guy here. It'll give us this information that's in green, so this intersection here. So this is a intersection. It'll lie. There you go. Cool. Intersection. That's what we're getting back from that. Very helpful. So that means there is a collision. Good. Now we want to first off tell our entity that we're checking all this on, tell it that its move speed is 0. We can't keep running through a solid thing. Tell it that it's done moving for now. And we're going to say, well, we should do this first. Say that hey, look, we found a collision. True. We found one. Stop trying to move. Set your slide angle to angle between two entities that helper function will define later. So get the angle of, we're going to set our slide angle to away from the thing that we bumped into. So you put in the thing that we're bumping into first, and then us, and it'll give us the angle between those two. So in this little example, it'll go, alright, Pinky's bumped into this black square here, so the angle between those is, our slide angle is going to be this. So next time when you move, if you had any sliding going on, then slide that way. But we don't need to. It's only if you have some slide amount going on. If you were sliding around and you bumped into this guy, you'd suddenly bounce that way. Not that accurate. You can do more mathematical stuff if you want to. But it works good enough for this. Alright, so we're currently overlapping this. So currently intersecting entity. Now we need to do collision resolution. And like I said before, what I'm going to do is I'm going to I do all this checking stuff, that's okay. I'm going to move out based on the shortest path. So with this one, the shortest way for me to move out by just picking one direction, you only allowed, let's say you can only move in 4 directions, up, down, left, or right. So I'm going to pick the shortest one. So I'm going to pick here, so the height on this intersection is shorter than the width. So that's what I'm checking first. If the intersection width is less than the intersection's height, good, then we're going to move out by that amount, else move out by the other amount. Now, which way do we move? It depends on where we started. So if I'm moving down, that means I've I started up the top, so that means I'm sort of moving down on the y-axis, so that y starts at 0 up here, up the top, so down is in the positive, right? So to push us back up, I'd have to minus an amount, minus some sort of y amount, which is the minus the intersection here. But if I was coming and moving up and hit this guy, then I would want to be pushed down. So I want to be pushed up here, down that way. And we just base that on where this entity is and where we started. So if last collision box dot x plus last collision boxes dot width divided by 2, so that gives you, if the x is here, so that's x, x, I want to get the value of halfway through him and halfway down him to work out where I should base things off. So that's why I'm adding a half width to get the center of my entity here. So if my starting x was less than this entity's x, then I need to push them, if we're playing with width, then I need to push them back out this way, because it means I started on the left hand side if I'm just pushing out based on width. So I'm going to get a bit long, I believe. Collision box x plus, same again, just going to be a little bit lazy. Copy that, paste, width divided by 2. That means we started on the left, so move us back to the left. Intersection dot width. Otherwise, else, we must have started on the right. Oh, x, sorry. Plus equals intersection dot width. Same, just started on left, so move left out of collision. Otherwise, started on right. Okay, that's dealing with just width. So if width was the smaller one, do that. Now we're going to go into height. I'll type it out. I was debating whether or not to copy and paste that, but that's fine. It's going to be basically the same logic, but just checking with y and width. Height. But let's just do it. So last collision box dot y plus last collision box dot height divided by 2 is less than the entities. Same deal. So my starting y is less than their y, which means I started above them before I moved. Then do this stuff. Same as before. So sample box dot y minus equals intersection dot height else sample box dot y plus equals intersection dot height. So I'll put the comment in properly. So started above. So move up out of collision. Otherwise, start it below. Cool. Alright, that's that part done. So we're checking if we hit stuff, and if we do actually deal with resolution. Good. If collision found, all sample box is at the same place as collision box, exit loop. So I'm going to exit this loop early if this happens. So if found collision, just down here, or sample box dot x is the same as collision box dot x, and sample box dot y is equal to collision boxes dot y. Then break. So exit loop early. Cool, so if I'm running with this example here, we would have gone, alright, we're moving down. The intersection here, smallest was the height. So our new sample box position got moved up to here. We got pushed up to here, and we didn't hit anything else at that point in time, so we didn't move around much more than that. So we're going to exit with our final sample box position of here. Exit the loop. Good. If we didn't exit the loop and this little black block wasn't here, then we would just keep checking until we got to the end. And when that's equal to that, exit, and there was no collision found, whatever. But we're running with this purple box. So the purple box, if we hit something, then we'll deal with that in a second. So if we didn't hit anything this time, then keep moving our sample box. So if distance between two rectangles, another helper function that we're going to build, sample box and collision box is greater than what do we call it? Box travel size. Yeah, so if the distance is from where we started to where we're going is still greater than our box travel size, then we move them up. So float x move is equal to, oops, that thing, box travel size times, and we did this before, this is relating to movement, so cos movement angle times globals pi divided by 180. So go back a few videos if you don't know what the hell I'm doing. But basically just creating how far we're going to move our sample box based on x and y value. That times same deal, except use sign. Movement angle, that movement angle we worked out earlier, it's just the angle between last collision box and our current collision box where we sort of planning to go. Okay, we're going to move our sample box by this much. Sample box dot x plus equals x move. Sample box dot y is equal to, plus equals to y move. Make sure you're plus equaling. Hopefully you know what that shortcut means. But just add this onto that. That's the gist of it. Okay, so let's get out of that loop. Make sure I'm in the right bracket. While this, good. Okay, outside of the loop. Now, if a collision happened, if we did find a collision... Oh wait, hold on. Jumping the gun. Sorry. I forgot to do else. So else. So if the distance to where we're trying to move our sample box to is less than the box travel size, we don't want to overshoot it and get into any infinite loops. So we're just going to set our sample box is equal to our collision box, and that's good because that means it'll check this final position. So it'll sample all the way along until it lines up with that final position, and if it'll check if there's any collisions in that spot as well. So if there's something here, then it will move itself out there. You get the idea. Okay, now we can go outside of that loop. Outside. So if we did find a collision, then we're going to set... Whoops, hit some crazy keys. Reaching over my keyboard. So move our entity to where the sample box ended up. Also, the slide amount, I'm cutting that in half. So if your slide amount was quite high and you hit something, I've just dampened it a little bit, well, quite a bit. Alright, so sample box. So Rx, our entity's x is equal to our sample box is x plus sample box's width divided by 2. Good. And our y is equal to our sample box's y minus our collision box y offset. So it's sort of like, yeah, I just want to set the x and y of my entity properly. Now, regardless of any of all of this up above, whether you hit stuff or not, let's turn your collision box back to its normal shape wherever we are now. So set it back up. So if we ended up using that purple one as our final destination, then what we've done is we've gone, alright, everything else is pointless. Shouldn't get rid of that black entity. Let's get rid of this. Yeah. And our new collision box is at this position here. The purple one. Yeah. Good. So you end up like this. Good. Alright. Good. That was a bit painful, but we got to the end. Next up for us is the helper functions. So we'll get onto that very soon. They're going to be pretty dry, but predictable. Alright, see you soon. Okay, helper functions it is. So let's get through this as quickly as possible. Let's get rid of all those statics. Whoops. Let's get rid of all the static stuff there. We don't need to say that again, basically. Okay. And then I want you to add this thing to say that each one of these functions we're implementing belongs to the entity class. So chuck that in front of all of those. Yep. And then let's start filling these out. This is just a bunch of math stuff that I found online to work all this out. So Don't freak out too much. Shouldn't be scary, but it's okay. Do I have distance between 2 points? No, that's okay. Alright, so we need 2 points, E1 and E2, to work out distance. So SDL points hold an x and a y. So E1's dot x is equal to R1's dot x plus R1 dot width divided by 2. So give me the center x value of our first rectangle, and give me the center y value of our first rectangle as well. And do the exact same thing with E2. So replace all the 1s for 2s. Just copy and paste that. Yeah. Be careful when you copy and paste. I do it all the time. I'll miss one of these things and it will throw off the calculation and be quite annoying to track down. Okay, so float d, or distance in this case, is equal to, in our mass functions, we've got this thing called abs, which is for absolute value. Absolute value means if it gave back a value of -10, it would change that value to just 10. It's always going to give a positive value. Now we need the square root of, and everything gets chucked in here. So let me just bracket this again. E2.x minus E1.x, and then we have, change that to a dot, and then we have to, that should be to the power of 2 here. So distance is, get rid of this from last time, distance is equal to square root of, so E1 dot x, sorry, E2 dot x, let me just check, yeah, minus E1 dot x to the power of 2 plus E2 dot y minus E1 dot y to the power of 2. Yeah, which is what we're currently doing. We can use power, I suppose. We're going to just do the power of 2 stuff, if you like. Yep. Plus oops, yeah, sorry, use a bracket. So power E2 plus x minus E1 dot x to the power of 2, and plus power E2 dot y minus E1 dot y to the power of 2. And I think I've missed a bracket somewhere. There. Good. And that's our formula taken care of, so just return the value. So I just looked up, just Google, distance between 2 points, and you find basically this online, then convert that into code. That's all I've done. And we basically got to do the same here. But let's see, it's much shorter, which is handy. Because we've got entity 1 and entity 2, they have an x and y already, so that's fine. So very similar. So float d is equal to, actually we can just copy and paste that more or less. We're just going to tweak it, because E2 and E1 are actually entity pointers instead of SDL point objects. So just basically just change them out. Your dot accessors out for pointer accessor, and you'll be right. Yep. Return D. Cool, that's two of them down. Angle between two entities. This one's a bit longer, but that's okay. So we got float dx and dy. Again, just Google angle between 2 points and you'll find this stuff, and then convert it out. So x1 is equal to entity 1's x, y1 is equal to entity 1's y, x2 is equal to entity 2's x, and y2 is equal to entity 2's y. Just so we're using the exact same variable names for what the formula I found on the internet was. Okay. Just checking something. Can't remember why that's important. Oh, I guess I used it to help me. So if oops, I got that over here. Get rid of that. Now, instead of using the x and y, if my guys were if they're solid, I'd rather use the x and y based on their collision box instead of their actual their x and y, because their x and y, get rid of that one, and entities x and y, so this guy, so his x and y might be here, x, y, but if I'm playing with collisions and whatnot, maybe I want to be checking the x and y value of here to work things out. Yep. So if E1 is solid, actually let me just check this. Alright, scratch that. Alright, so I'm going for the simplified version here. You don't really need to be 100% accurate. You probably noticed a minor edit. I just decided to cut some code out of my cheat sheet, so if you see that the time jumped a bit, that's fine. Okay, so x2 minus x1. So dx is equal to x2 minus x1. dy is equal to basically the same idea. Return a tan 2. Whoops. So using some trig stuff, pass in dy dx times 180 divided by globals pi. So this thing gives you the angle between these 2 points, which is good. So between dy and dx give you 2 different, or give you angle, except it's in radians, and then convert it from radians back into degrees, which is what we're doing all our maths based on. Cool. Let's keep going. Check collision. This one's pretty easy. I check it in a few ways. So let me just check this. I might just run my code again. Okay, check collisions next. This one's very easy. So, I guess we don't even need this. I'll get rid of that, actually. So if SDL intersect direct C box 1, C box 2, and guess what? We don't care about a resulting collision box. Intersection box. We just want to know if it true it collides or false it doesn't. So does it intersect? Return true. Otherwise, whatever happens, return false. Now, if you want to check other stuff, this is checking for intersections. My code was a lot longer before. If you want to check for if a rectangle is in another rectangle and other situations, etc., then do it here. And I'll give you the code for what I've got, but it's a bit lengthy to write out, and it didn't make a difference when I took it out for when I just ran the code just before this little run. So it might make a difference if you've got really large objects, large entities, but I'll give you the code, but I won't video the code. Alright, angle to direction. So this is converting a 360-degree angle into one of our constant values. So we have our constant values: direction up, down, left, right, and none. So 0, 1, 2, 3, and a -1. So we're going to convert that angle that we've passed it into just give back a result. We're basically just checking if an angle is between certain bounds, and if it is, then return dir right, dir down, dir left, dir up. So this one's pretty easy. If angle is greater than or equal to 0 and angle is less than or equal to 45, or just because angles, so starts at 0, goes that way around. We're checking for right, so to check for right, we're just checking, is it from here to here, so 0 to 45, or this last little bit of whatever, hang on, let me just check, 270 plus 45 is equal to 315, so that's 45, or 315 to 360. So we gotta check within these two ranges where we are. So this is the only one where we have to check it twice, just because it starts at 0, comes back to here. So if angle is greater than or equal to 315 and angle is less than or equal to 360, then we return dir right. Else, if check the next next 90 degree spots, angle greater than or equal to 45 and angle less than or equal to, this is where I start getting lazy and just do 90 plus 45 degrees instead of working that out. I'll just make it work for me. That's why I did the calculator to work out what 315 was. I originally had 270 plus 45, so I didn't have to think when I first ran through all of this code when I was making it. That was if our angle is greater than or equal to 90 plus 45. Let's just work that out, which should be, I'm sure, yeah, it would be 135. I don't need to calculate that. Okay, and this shouldn't be a test of my math skills, but 180 plus 45 degrees is 225. All right. To left. Just else. Return dir up. Forgot the semicolon. Forgot the semicolon. There we go. So it just keeps checking those 90 degree sections. So if it's within there, return right. So if it's within this first section, return right. If it's within the next 90 degree spot between here and here, return up. If it's between here and here, return left. You get the idea. Alright. Okay. Right, down, left. Right, down. Okay, whatever. I know that it works, so I'm not going to worry too much about it. Okay. Angle between 2 points. Well, we've done angle between 2 entities, so this won't be too much extra work. We'll try and copy and paste what we can. So, we don't even need to. It's that short. Dx is equal to cx2 minus cx1 float dy is equal to cy2 minus cy1. Return tan2 dy dx 180 divided by levels pi. Cool, not too bad. Angle between two rectangles. We're going to make the above function help us out here, so we have to write a lot of redundant code. So we could have done this with the above one as well, but that's okay. Float cx1 is equal to, so it's checking between angle between two rectangles now. So col1 dot x minus, hang on, get the syntax. I had minuses in my code over here, which is not good. So col1, which wouldn't have changed anything much really, which is good. Col1. Oh, I called it R1 in this case. R1. Sorry, cheat sheet's a little different. We'll do cy1 is equal to, so we're just getting the center of a first rectangle. This is very familiar. I guess, well, I've probably just done this too many times. Okay, so cx1 and cy1 is the center of our first rectangle, and then basically just do the same for a second one. Okay, so 2, 2, 2, 2, 2, 2, don't miss any 2's. And the good thing is, I don't have to do all of this because I've done that, so I can do return this function from above and give it cx1, cy1, cx2, cy2. Good. Not too bad. And is that it? Good. Cool. So that's all of our helper functions. They're not terribly specific to a single entity, but they're used to work out things relating to entities. Alright. Next video is going to be to deal with lists of entities. So we'll deal with that next time. Okay. The final round of this, we're going to finish off this entity class, which is good, it's huge. Alright, last things, this is to do with lists of entities. So we've got a few helpful functions that we're going to build, and we've got a static reference to the entities list that we could, sort of a global list. Alright, so first, get rid of the statics. Getting rid of that. Good. Now, this is just a list of entities, but you still have to initialize static values, static objects and variables of classes somewhere. So we do it here. So I've just put that there. Cool. That's all I have to do there. Pretty easy. Let's put this onto all of these here. Good. It's going to complain. It's fine. We're going to get onto that in a second. I might as well just put the brackets in now. There's only 3 things we have to do. Good. Now, entity compare. I think it's got too many constants in there, but that's alright. I'm just going to roll the punches from whatever code I did when I made this project. Now this is for within our list of entities, how do we sort them? So we're making a function that sorts our entities, and I'm sorting my entities based on y value. So why we do that? We just clear this, make a new thing. I'm gonna make a guy like this. This isn't. Alright, so we got a guy. Cool. And we'll have another guy. Oops, let me do that. He can be cranky. Good, now they're on the same layer. Alright, I'll just check on that. Now, as these guys move around the world, because it's a 2.5D game, so 2.5 dimensional game, we'd expect if blue guy is further down on the screen, he's sort of in front of this guy like this. But if blue guy is sort of further away, we don't want him to overlap red guy like this. We want it to swap so that red guy looks like he's in front, because this guy's this far in the plane. It's sort of this fake 3D idea that we're striving for here, where even though it doesn't change in size, the depth, we still have the idea that things further up here are further away, and things closer should be in front of things that are further away. We don't scale stuff at all though, so it's really just equivalent lines, but we're still using that to represent depth. Okay, so we're sorting things based on their y value. That's what this function does. So if a is not equal to 0, can't remember why I've got that in there, and b is not equal to 0, so for whatever reason, I guess empty entities may end up in this check, but whatever. If they're both there, then return A's y less than B's y. So let's wrap that in brackets. True or false? Is my y less than yours? If it is, then I'll get moved. I can't remember which way in the list, but it'll work itself out. Else, return false. Main part is here. Probably could just have just that, and it'd probably still work the way our code's working at the moment. Cool. Then we've got these two functions that deal with cleaning up lists. Remove inactive entities from list, and we give it the list that we want to work with, and decide whether or not we should delete them when we remove them. And remove all from list doesn't check if it's active or not, and just same options. So it's basically the same code, just we remove an if statement that's around it. Okay, so let's use our auto again. That was pretty cool. So auto entity is equal to entity list begin. Entity is not equal to entity list and entity plus plus. Now remember that even though I've called it entity, like before, this is list of entities iterator. It's pointing to a position in this list. That's all it's really doing. So if there's a lot going on here. First, I'm going to dereference entity so that it's now giving us an actual entity pointer, and that entity pointer, is it active? If it's active, and then we're going to negate that. So if it's not active, if entity is not active, cool. First, if delete entities, if we're deleting stuff that we're removing, then delete the pointer that, well, delete the entity that's there. So dereference it, get us to the entity pointer, and delete the thing at the end of what we're pointing at with that entity pointer. And also remove this from the list. So remove this entity position from the list, which is erase. Now, if you don't do this part, entity is equal to that, then it's going to screw all sorts of stuff up. Oh, speaking of screwing stuff up, I've done it already. Get rid of this, entity plus plus. We're going to deal with that ourselves. So leave that empty up there. Okay, so entity is equal to entity list erase entity. So whatever entity we're pointing into the list. So let's make a new example. So we've got a list of entities, and this guy here is not active, and I want to get rid of him. So when you do erase, it'll point us back to the previous one. It returns the previous one. So that's why we want to do entity is equal to whatever happens with erase, but erase that one. So it makes us point back to here. Otherwise, we're still pointing at this dud one, which is not part of the list anymore. Not that helpful. Alright, else. So if the entity is active, then we won't worry about it. We'll keep moving on. So we just go entity plus plus. Like I said, I took it out of the for loop up the top and put it down here. Okay, this one's very simple. Remove all from the list. So copy and paste the code from above, paste that down here, and get rid of this, so the else part and the if check here. All you need in the middle is, you got your for loop, and do I delete as we go, or am I just removing them from the list? So that's it. Cool, that was pretty easy. And that's it. We got past entity. That long, big bastard of a class is going to save us a ton of time in the future though. Well, you can celebrate for that. That's pretty good. Well done. Alright, I'll catch you for the next one, which will be, let me have a look. The hero. We get to start making the hero class. That'll be good. Alright, see you then. Alright, so it turns out last time I lied to you guys, and we're actually moving on to the living entity class. Don't worry, it's a very small one. So entity is very broad, and we're making a subclass that defines things that have health and deal damage with things. So we're going to make a new class called living entity, which hero is built from. So add a new header file. Header file. And call this one living entity. Sorry, I got babies. Let's get back to it. Where were we? If not define living entity. Whoop. Okay, so what does this class need? It only needs to know about entity. That's all I need to include. I also want to make this abstract. Abstract class also. Class living entity inherits from entity. So living entity is a type of entity, but a more specialized version. Public, okay. In this game, living things have health and can deal damage. Obviously you make classes specific to whatever you're trying to make. So all my living things in this small little game hurt each other, which is a bit sad, but that's what's fun about this game, I guess. And have hitboxes. Similar to collision box, but describes damaging area. So a box to describe where we are hitting. Float. All of my things that take damage in this game have an invincible timer as well, which means if greater than 0, then can't be hurt. And that's just so you can't, well, the game loop runs as fast as your computer can process stuff, and I don't want to see if you're hurting something every one of those cycles, because you can smash a ton of damage before it even really is even visible to the screen for the naked eye. So I'm just delaying how often they get hurt by a certain amount of time with the invincible timer. So in between, so I can actually see in between hits a little bit. We're going to update the hitbox, very similar to update collision box with a last class. Update damages. Now this is a abstract method. It's going to be defined by every class that is a living entity. So this is how we get damaged by other things, which is up to each class to define. And just some useful functions that most of these things have. Die, if you want to just make something dead, that's what this function's for. Again, it's also an abstract function. Abstract to other classes to decide how they die. And update invincible timer. So it just manages ticking this invincible timer down if it's greater than 0. And finally, I wanted to override entities draw. Overriding entities draw. Oops. Cool. Alright, there's not much to do there, so we're going to build the source file as well. So add new item, C++ file or CPP, whatever you want to call it, living entity. Yep. which includes that header file that we just made. Yep. And not much to do here, which is good. So we just got to make, how many is it? 3 functions. So we're going to go back here and I'm going to copy it without the virtual or the semicolon, so I can just make this a bit quicker. That one, and that one. Or just type it out, it's up to you. Alright, living entity, update hitbox. Now this one is a bit different to how we were doing the collision box stuff. Now, hitbox is dependent on your frame data. So if we go a project inside of debug is res. Inside res you've got your Udemy cyborg.fd set. So if I open that up, our frames have data, and on the frames that deal damage they have, where the hell is it? Hitboxes. Hitbox and damage. So it's only on frames that have hitboxes that we deal damage. So otherwise, frames that don't have it don't have that data there. So what we do is we're going to be dealing with, going to be using all this group stuff that we added in earlier. So okay, I'm going to start with assume damage 0 for now. Damage is equal to 0, just for now. Okay, now group box. So the group box class is one of the ones we included, which has inside it group box is of type group, and the data that it has is a list of SDL recs. So it can have a lot of rectangles in it. Okay, so a group of boxes called call boxes for now. Could call it hitboxes, I suppose. Yeah, let's do that. Be more useful for you guys. Alright. Now we go cast group builder. Group builder has a useful function called find group by name, and it looks through a group of data for, look, a string. So we're looking for hitbox. Now that's what's in this file here. See, we've got hitbox. Lowercase h, but uppercase B. So we want to find that set of data out of the current frames frame data. Now the frame data is the group of data belonging to this current frame. And in that group of frame data, I want to find the data relating to hitboxes. So there could be one, none, or many on any one frame. Okay, if hitboxes is not equal to null. Oh, before we go into that, you see I did this cast here. So find group by name returns a group pointer, and group box is of type group, so we can convert a group into a group box if it is one. So that's casting. It's similar to doing this. So int x is equal to int 4.5. So you're saying turn 4.5 into an integer if it's possible. In this case it works because it takes off the 0.5, so x is equal to 4. Casting with classes and polymorphism only works if you're casting from something that it inherits from. So group box inherits from group, and we're returning a group, so we're giving it a go. It'll crash if it returns a different type of group. If it returns a group string and you try to convert it into a group box, it'll crash there. But I'm not checking for that. I'm not worried. Okay, so if we found some hitbox data on the current frame of our entity, our living entity, and that hitbox's group number of data in group is greater than 0, because we might find the group, but we might not find any data for it. So if it's greater than 0, cool. So we found the group, and there was more than one, there's at least one bit of data in there, then update hitbox. You get to see while this is working as well, because the draw function will build. So we want to get hitbox. Yeah, HP is fine. Is equal to hitboxes. So there could be many, like I said. Data dot front gives you the front. Gives you the first thing in that list, and the data in our case is a list of SDL recs. So it gives us the first SDL rect in our hitboxes group. And because this game only deals with one hitbox at a time, we're only taking the front one. So if it happens to be multiple hitboxes, we're ignoring all the other ones for this frame. So hitbox dot x is equal to x minus current frame offset dot x. We got that stuff going on, which will help line things up. Plus this hitbox is x. So we're going to make my hitbox equal to the x of the hitbox, but also take into account where the entity currently is. Do the same for y. Y minus current frame offset dot y plus hitbox dot y. So make this hitbox in relation to the hitbox we just got and the entity where they currently are on screen. The width is equal to hp dot width, and hitbox dot height is equal to hp dot h. Okay, very similar thing now. We're going to try find damages as well. Update damage. So if you've got a hitbox, good chances are you also have a damage data on this frame. So we're going to find the group number damages is equal to group number pointer cast on group builder is going to call find group by name. So that function is going to return a group. We're going to convert it into a group number pointer. And we're trying to find this group of data relating to the current frame, and the current frame's frame data is the list that we're going to search. So now we're looking for this bit of data. Okay, if damages is not equal to null and damages number of data in group is greater than 0, then damage is equal to damages data dot front. Okay, good, that's all we had to do for that one. So if you have a hitbox data, then set up your hitbox, and if you have a hitbox, then maybe you probably have damage, so set that up. So we can basically update a rectangle to describe the region in which we're hurting things. Alright, this one's not too bad, it's pretty short. Put that in front again. Okay, so if invincible timer is greater than 0, then invincible timer minus equals good old time controller dot dt, and that dt is, remember, it's the delta time between the last update, which could be way small in the milliseconds, so just take some milliseconds off of our timer. Okay, drawing is very similar to entities draw, but the difference is we want to show extra debugging information. So I'm going to go to entity for a second, go over to draw, go into that function, yep, and I'm going to steal all this code because it's handy. So I'm copying draw from entity and I'm pasting it inside of draw of entity, living entity. That's because I want to draw a few more things under debugging. So what have I got? Currently I'm drawing the current collision box. But for a good reason, I might also want to draw a few other boxes. So I'm just going to paste that 2 more times. And let's see, before I draw a collision box, let's draw a last collision box, because maybe that's helpful. And we're going to choose a different color for that, so change that from full red to full blue. So that's blue. And we're going to draw the last collision box, so where they were, collision box is where they are, and that's in red. And now this one, we're going to draw the hitbox. So change this one to hitbox. And the color we're going to make is yellow. Oh, actually, no, that'd be magenta. Or, well, whatever that pinky, bluey color is. So, full red, full blue. Cool. That'll help. This debugging stuff looks pretty cool when we get it going. It's just so we can see where all the boxes describing our shapes of our entities are, and then we can turn it off again for when we want to release the game. Cool. Alright. Next is the hero class that we're moving on to. Sorry about that. Alright. Talk to you guys soon. Alright, so we're finally on to doing the hero. So you're probably like, Matt, why don't we do the hero first? It's like the most exciting part. It's like, well, yeah, I know, but we laid down all that framework stuff first so we could make coding easier for later. It had to be done. Starting with the hero first would have caused a lot of issues on this type of project. But we're finally onto it, so let's get onto it. So, add new header file and hero. Set up the basic stuff. And we're going to include, I'm pretty sure globals is already part of entity, but that's okay. A hero is a living entity, and we'll come back later and add sound to our hero, so we're not going to worry about that now. Class hero is a living entity, but a more specific one, so it inherits from that class there. Alright, so to make things a bit nicer while we're doing things with our hero in terms of code, we should set up some reference values. Reference variables, which is going to be tedious to write out, so I'll try and make some shortcuts while we're going along. See how we go. So static const string hero anim, and these help describe the different animations a hero can have. So I've just copied that much, and this is going to be for up, paste, down, left, right. Also, copy that, paste. That's for movement, so we're also adding in idle up, down, left, right. So just gonna paste that, paste that, paste that. Next, slash, so their attack, up, down, left, right again. So just paste that. We need slash. Yep. And dash. That's not confusing. So up was the first one, so we're going to change that to a D. D, 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 D. And finally, so copy that much. Dying. So our hero can walk up and down, left and right. They can be idle, they can attack, they can dash, and they can die. They're the animations. Our hero also has states that they can be in, so we're going to have reference values for that too. Hero state, and copy that much. Idle, move, slash, dash. They pretty much are the same as the animations, and dead. Cool. Alright. On to our main functions for this class. So a hero, try and do a constructor here, hold on. A hero, whenever we make an object of type hero, always needs to be given an animation set so that they can draw from something. There's no point having a hero object without an animation set. Void update, we're going to override this from entity class, and we're going to make a few new ones called slash, dash. We're going to override die from living entity. We're going to have revive. That's going to be handy for restarting the game. change animation is one that we are also overriding. Okay. And a few more. Update animation. It's another entity one. And update damages. Alright, so that's all the things that our hero can do. And we'll get on to the source code in the next video. I figure I'll split this one up a bit more. Well, in half. Alright, see you shortly on the next one. That was pretty simple. So let's move on to the CPP file for hero. So go down to your source files, let's add that, new item, CPP, hero, let's include that, include hero so it knows about all of what we've done. Everything inside here is going to need to be moved into here so that we can, all those static constants we have to initialize in this section too, as well as do all the functions. So we pretty much got to copy it all over. Now, there's a lot of static mentioned everywhere, so I think our first step is to get rid of that. So let's just get rid of it. Delete, delete, delete. Let's do all the boring stuff first. Cool. Next, what class does this belong to? So hero. Just chuck that in the front of all those. I'm doing it the slow way so you can see that, otherwise you can speed things up wherever possible by using find and replace. So you could just search for every space capital hero and then replace that with that, but it doesn't matter. We're almost there anyway. Okay, cool. Now these here, these are strings that we're going to use to actually look up the animation names in that frame data set file. So if we go back to our project, not in there, inside res, come down here, Udemy cyborg.fd set, yep. Animations, we got 17 of these, and their names are up, and then it's got 4 frames for that, so we go down there, down, left, right, etc. You don't need to look through this to work these out. I know what these are because I built this frame data set file, which likely you'll end up doing. So just take it from me that I know what all these names are, so just copy this word for word, up, down, and casing as well. Make sure you match casing. So if you're running this and you're finding that it's crashing when a particular animation is happening, just double check all of these. Idle, up, I did camel casing for these animation names, so that's a capital U. Idle down. Idle left. No surprises here. dash left. Dash up, dash down. Again, you probably find you can be a bit more clever with your copying and pasting perhaps in this section. That's okay. And die. Good. Now, these integers here, it doesn't matter. We're just going to be referencing them by name. They're just constants. So as long as they're different values to each other, then that's all we need. So 0, 1, 2, 3, 4. Cool. Alright, so that's all our constants set up, which we'll be using inside these functions down here. Too easy. Alright. Hero constructor. Now, a lot of hero's attributes is inherited from other classes, which is good. So, first, the hero's animation set is equal to the one that's sent in through the parameter section of this function. The type, which is an entity thing as well, we're setting to hero rather than just leaving it as a default entity. And we're just going to set up a bunch of default stuff. So set up default hero values, which include x is equal to, we're just going to put them in the middle of the screen. So screen width divided by 2, y is equal to see how handy it is to be able to access all your globals without passing stuff around. Moving speed is 0, but their move speed max is 80. So move speed is like the speed that they're currently moving. So he's currently moving at nothing, but he can move up to 80. HP is equal to whatever HP max is equal to, which is equal to 20. Current damage is 0, just in case. Our default collision box width for our hero is 20. I just played around until I got a good collision box width and height. And 24 for that. So then, setting up our collision box. Collision box width is equal to that, collision box width. And I guess I didn't really need to do that because I update collision box anyway. Yeah, let's not worry about that. We'll get rid of that then. We got to set the collision box y offset, which is equal to minus 20. So wherever your x and y is, draw this collision box 20 up from that. Play around with this value to see what that's doing. Current direction of our hero is going to be down, so they're looking sort of at the player. And change animation, which is what we're going to make soon. Going to change the hero state to idle. True reset the animation to the beginning of the animation because we haven't got one going yet, so we should reset it. And update collision box, so that'll set the X, Y, and collision box width and height using these values that we've set up here. Good. Update Update mostly just calls a whole bunch of functions, so we'll get onto that. Check if dead, so if HP is less than 1 and state is not equal to hero state dead. So if your current state is not dead, but your HP is low, then let's go through dying. So change animation, tell it that the new state is dead, and yes, draw that animation from the beginning. Stop moving, sliding's okay, and call that die function, whatever that's going to do. Alright, now onto the set order of doing all of our previous functions that we set up. So first we update collision box, just in case anything's happened, like they've moved or whatever. Then update movement. Update movement. So try and move them. And then update collision. So set up their current collision box to where they are. Try moving them. So we use that collision box as set that as the last collision box, and the new collision box will be the destination, and then we union that, and then update collision. So check if after we've moved, did we crash anywhere in the movement, and then put us in the right spot after that. Then update hitbox. So if this is a frame that is doing damage, update the hitbox and set the damage value. Update damages. Update damages is how I respond to getting hurt by other things that are trying to hurt me. So if something's hitting me, I should respond. Now update animation. After all of what's going on, deal with animation last because it could change for multiple reasons throughout that. Change direction, get hit, change something, change action, etc. And update the invincible timer. So if that's greater than 0, then I guess we just tick that down slowly. Cool, that's not too bad. Slash, so this is a function to tell our hero to do an attack. So as long as our HP is greater than 0 and state is equal to hero state move, or I have to add that bracket in later, or state is equal to hero state idle. So as long as we're not doing anything like dying or attacking or dashing, then we're allowed to do this. Moving is equal to false, so stop walking. Frame timer is equal to 0. Frame timer we use to, I think that will get reset anyway, but we use frame timer to decide when to tick over animations. State is equal to, I don't need to set it here, we can do that in the other one. So let's go change animation, hero state slash true. So change animation kind of does two things. It changes the state to a new state, and then make sure it runs the correct animation based on the state that you're in. And to do, add attack sound. We'll do with sound and music a lot later. Keep wanting to type an extra S. It's bad. Alright, dash. Dash is pretty much identical, with a few extra things thrown in. So I want you to copy that so far, paste that in there. Dash sound. And instead of just that, frame timer, that, obviously change this to dash. We also need to work out slide angle and slide amount. Now, that's because we're gonna push the player or hero in the direction they are traveling. So basically, dash just throws your character into a direction. It's not based on movement. So once you hit dash, you can start trying to fight against it while you're sliding around by running against the opposite direction. We're going to use that, just, I don't know, it looks nicer. So we're just going to give him an angle and a certain amount of force. Angle is the direction that the hero is already facing, so just push them the way that they are facing at 300, which I just played around until I found that. Part of being dashing is you get to be invincible for a very short time, so that's 0.1 of a second. Then we change animation to dash and change the state to dash 2, and we'll play a dash sound later. Cool. Dying. What does dying involve? Dying means we stop moving. The state obviously is hero state dead. We probably really need this in here, but just to enforce that. And change animation state. Wow, I can actually simplify this to 2 lines, because change animation is going to set the new state. So I can actually, instead of saying state is equal to that and then pass that in there, I can just shove that in there like that. There we go, 2 lines. You stop moving and change your state and animation to dying. Revive. Basically, just reset a bunch of A's. Which is handy. I'm pretty sure I can just... it's alright, I'll just type it out. I can't be bothered scrolling back up to copy and paste, so it's not that much. So change animation, hero state idle, there it is there. True. Moving, stop trying to walk, x is equal to globals, that's screen width divided by 2, and same for y, so put it back in the middle of the screen, and if we were sliding around, reset that too, so no more sliding around. Good. 3 more functions to go. Change animation. This one is going to be tedious. Yep, sorry about that. So the state of our hero is going to be equal to new state, so the state that we pass in. See that? So when I call change animation and I give it a state, like hero state idle, it also sets the state of this so we can get the right animation going. It sets it, doesn't just reference it. Okay, so if state is equal to hero state idle, then depending on the direction of our character, direction is equal to, if we're currently direction down, then I don't want to use brackets, it'll get pretty ugly. Alright, if we're idle and we're facing down, then current atom is equal to atom set get animation, which takes a string, which we're going to pass it one of those reference values. Hero atom, this is idle down. Good, I gotta do that more. It's going to be a bit annoying. You can do else if you like. Actually, it's a good idea because it will save you a slight amount of processing. Okay, so down, let's go for up next. Up. So this needs to be up. Up, down, left, right. See, that was fun, wasn't it? Copy that. Else, then paste that and change it to move. Where we basically just go, alright, we leave all the directional stuff, that's good, we just go change the animations. So instead of idle, we just get rid of the idle part. Get rid of that. So just do the basic animations for moving around. Else, if slash, same deal, just sub out the word idle for slash. Slash is undefined. What did I have? I put slash in the wrong spot. No, it doesn't matter. We'll just run with that. That was really dumb. Broke my convention by accident by copy and pasting. That's fine. We'll just make do. Okay. Good, there's slash. Else. And do dash as well. Two else's, my bad. Dash, 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 dash. And the last one I'll write out because this is dying. So else, there's only one in there. If you like switch statements, which I don't, this type of else if structure is just checking if one thing is equal to something else. It'd be perfect for a switch structure if you're into that. So all we gotta do for this one, current animation is equal to atom set get animation hero atom die, wherever that is. Or did I, where is that? Let me just reference up here. Dash die. I'm definitely fixing that one. So hero anim die, not dash die. Sorry about that. Yep, good. Back down here. Okay, so death doesn't have multiple directions, it just always faces down. There's only one animation for it, so it doesn't matter. We don't check all the other stuff up there. Good. Alright, if reset frame to beginning, then yep, too late at night for me. Then current frame is equal to current animation, which we worked out above, get frame 0. So remember our indexes for frames start at 0. Else current frame is equal to current animations get frame, no, just get frame, and look it up based on the current frame's frame number. So whatever the previous current frame was, look up its frame number and chuck it into here. So the example where you'd use this is if you're changing direction from left to right and you want to stay on the same frame number. So you're about the third frame through the animation. Then you reset frame to beginning to false. The current frame is left, the third left frame. So this is like 2 because our indexes start at 0, so it passes 2 in here. And we've gotten a new animation which is for running to the right instead of left. So look in the right running animation for the third frame and set that to the current frame. So replace the current frame in this one with the, using the previous frame's index, find a new frame out of this new animation that we're referencing now based on the same frame number index. If you're confused about that, just talk to me. Yeah. Alright, update animation. This one's big, but it's not too bad. If the current frame is null or current anim is null, then quit this function because can't do much with animations without pointers pointing to them. So for whatever reason we don't have a current frame or current animation, then it's a bit hard to update the animation because our hero doesn't have one. Alright, so if state is equal to hero state move and we're not moving. So if my state says I'm moving but I'm not moving, then I should change my animation to being idle and update my state. True. Reset the animation. Good. So if state says moving but we're not, then change state animation to idle. Next, frame timer. Frame timer plus equals time controller. We're going to add dt to it. Dot dt. So frame timer keeps ticking up in this case and gets reset back to 0 soon. So if frame timer is greater than or equal to current frames duration. So as an example, in this thing you can see that for most frames the duration here is 0.1. So dt per cycle is probably like 0.0001, and it'll slowly add up to this or higher, and then it'll tick over to the next frame. So frame 1 to frame 2. That's the idea. But we've got a bunch of other stuff to check. So time to change frames. But a lot of stuff happens in here. So if we're at the end of an animation, what do? Depends. So if we'll do the checking of that first. So if current frame number is equal to the current animations get end frame number, so if it's the same as that, then it depends. So if this is true, then we're on the last frame of the animation. So if state is equal to hero state slash, or state is equal to hero state dash. So if you've done an action slash or dash, so attack or run around real quick, then change back to moving state slash anim. Change animation, hero state move. True. Because you don't want to loop that animation back around. It means that you've done the attack, so go back to being normal again. Else if state is hero state dead, hold on, it's a bit redundant to put that in, so I'm gonna get rid of that. And HP is somehow greater than 0. So if for whatever reason your character comes back from the dead, and it's the end of the dead animation, then set you back to moving as well. Otherwise, else, so I guess I'll type that in, was dead but now have health, have more HP, get back up, move state. Okay. Else, just reset animation loops it back around. So for a lot of things like being idle or running around, or well, being dead, repeated, like not coming back from the grave, but just staying dead, then a lot of the time, if you're at the end of the animation, you just want to go back to the start again. So current frame is equal to current animation, get frame, just the beginning, so 0. Good. Alright, that was if we're at the end. So find where this if statement ends, which is here, and else. So if we're not at the end of the animation, just move to the next frame. Just move onto the next frame in this animation. Because we're not at the end of it, we don't need to loop or do anything crazy, so just current frame is equal to the current animation get next frame, and we're going to give it the current frame, and I'll basically just check out what this current frame's index is and tries to move it up by 1, and if it can't, it'll loop it back to the beginning anyway, but that shouldn't really happen, but just in case, that's what it'll do. Either way, whatever we've done, we're always going to have to reset this frame timer back to 0, so good. Make sure this is within this if the frame timer is greater duration section though. Frame timer is 0. Good. Alright, kind of lengthy, but hopefully it makes sense. So that helps deal with certain situations. Update damages. This one is a bit more lengthy as well. A little bit tricky. So this is for me getting hurt. Or the hero getting hurt. Me. Sorry, it's hard. I always think of the current class that I'm working on as this and this, but I can't help but refer to it as like myself, because that's sort of how this works in code, but yeah, anyway, you don't care about that. So if this hero is active and the HP is greater than 0 and the invincible timer is less than or equal to 0, so they're not invincible, so they can be hurt, then for all the entities in this game, we're going to do just another loop on all of our entities. So we've written this 1,000 times already. Entities.begin. Just basically just going to iterate through that list. Entity not equal to and entity plus plus. Cool, now we can check stuff. So if this other thing, so in this big list of things, we check if each entity is active, and for me, because I'm the hero, I want to check that the type of this entity in the list is an enemy. So are they someone likely to hurt me? Obviously your logic here is going to be different if your game's more sandboxy or you've got way more complicated things going on. Mine's simple little melee battle thing, so I only need to check against enemies. If you got bullets and stuff in there, make sure you check in that as well. Or change the logic around. Now, we know enemies are living entities, so cast it to that. Living entity enemy is equal to living entity entity. So remember that this thing here is a iterator, so it's pointing to a particular position in this entities list, so say the beginning or an entity in the middle. So when I dereference it, it's going to give me the actual entity pointer that that iterator is pointing to within that list, and then I'm going to convert that entity pointer into a living entity pointer. Cool. Alright, so if my enemy damage value is greater than 0, so we got it pretty simple with this game. The only way you can really deal damage is you update your hitbox and you set your damage to something. So as long as you got more than 0 for damage, then you're attempting to hit someone. So if I've got damage to deal and check collision between the hero's collision box and the enemy's hitbox. So if the enemy is likely to deal damage and a hero collides with the enemy's hitbox, then it's time to get hurt. HP minus equals enemy's damage. So if you go on more sophisticated RPG stuff, this is where you include your defense and all that stuff to dampen the attack, but this is just straight up, they do damage, I take it. If I died, if I didn't die, if my HP is greater than 0, so still alive, then we set our invincible timer to 0.3 of a second. That's just a value I tested that I felt was kind of fair. And we'll play getting hit sound here. And then we also want to push the hero. So he's getting hit by an enemy, so we're gonna slide him. So the slide angle is equal to, we got a helper function for this, angle between two entities. See, that's helpful. So this enemy person that's trying to hit me and myself. So I'm just going to do that. I'm going to reference the iterator again and myself, and the slide amount is equal to 200. Just play with that until it's a value that you like. If you put it too high, he'll just ricochet all around the arena when he gets hit by enemies, which is a bit overkill. You want a little bit of feedback though. And that's it. So if I'm getting hit by enemies, take some damage, and if I'm alive, set my invincibility timer and push me around. Cool. Well, that's it for hero. That's good. Next up is keyboard input. Now we're going to make a class that deals with that, because the way I build these games is I pretend that the hero or player characters are puppets and they just have a bunch of functions, and then that way I can build a bunch of different classes that deal with input. So I'm making a keyboard input for this particular course, but you could easily make gamepad class that deals with the same way, or all sorts of crazy classes that deal with moving the player. And you could have, obviously having multiple in the one project is good, because that means it's up to the player what controls that they use, and you can make it more and more sophisticated, like custom controls and etc. So the next course will be on keyboard input for controlling a hero. And then soon, very soon, we'll be able to get our hero to run around. Not yet, but soon. Cool. See you next time. So as mentioned in the last video, next thing we're moving on to is keyboard input. It's a class that deals with just you press some buttons and it makes the hero, so a hero class, do some actions. So we're going to get into that. It's another small one, which is good. I like small classes. I should make them smaller more often. Okay, so we're calling this one keyboard input. Alright, so type in the usual jazz. Copy that. Alright, this thing needs to know about the hero. That's about it. Okay. Let me just check one thing. Yep. Okay, so on to building the class. So class keyboard input. So this thing has a hero pointer, so doesn't have a hero, just has a hero pointer, so to which hero I look after. Yep. Now we've got these things called scan codes, and they are basically just different keys on your keyboard. I'm storing them here because if you want to enhance this project, you can load up from some sort of text file or something what these buttons should be. But at the moment I'm going to hard code them in the constructor, but I'm going to store them inside of here. So scan codes hold, I'll show you if I can. Scan codes hold, look, like KPA and stuff like that. Lots of different things. Scan code left, so the left directional button. Those sorts of things. So a scan code is what do they call it? I guess it's an enum or something. What are they? Yeah, there we go. It's an enum of some sort, so enumerated type. But we're going to keep references to each button press inside of variables belonging to the class, just in case you want to change it, rather than have it hard coded in. You'll see what I mean. And slash and dash buttons. Cool. Alright, constructor. Yep. And update. Update takes this thing called SDL event. So we're going to pass it that. Basically, every time we run all of our code, we check the SDL event at that point in time, which keeps track of heaps of stuff. So keyboard input, gamepad input, sounds, other stuff, lots of stuff in here. Cool, that's all we need for that. Not very big, this class. Okay, now we've got to build the CPP file. Let's do that. keyboard input. So obviously include that header file. Good. It's only 2 functions, but why not? Cut any corner you can. Okay. Okay, so up is equal to SDL scan code up. So that's the up arrow button. Down is equal to SDL scan code. Oops. Down. You can guess the next 2 at least. So left, right, 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 and slash is equal to SDL scan code. For me, I'm using Z for my attack button, and my dash button will be next to that, which is X. Cool. These are hard-coded, obviously. Hard-coded keyboard buttons. So if you want, this is where you do it, I guess. Bonus task. So for you to do, not me. Load scan codes up from a text file. So just save all of these values. See how scan code up is 82. Just if you save that out to a text file, it'll just be as integers, so 82, 81, etc. And then when you read it back in, just cast it back. So I'll just give an example. So int test is equal to 82. Up is equal to test. It should probably complain. Yep. But you turn it into a SDL scan code. Maybe it's lowercase c. There, like that. So you can cast integers back into the enumerated type. But we obviously don't want to do that. But that shows you how to. Well, at least shows you how to turn integers into enumerated types. You just cast it to the type that it is. Alright, not that important. Okay, update. Button presses. Now there's a difference between holding a button down and pressing a button. So that's what we're going to check. So this is pressing. So at the point that you press the button down, if SDL event we've called E. So if E type is equal to SDL key down, then if E key dot key system dot scan code is equal to dash, then now dash was that scan code we saved up there. This is how you check the scan code of the event, SDL event of what's been pressed. This is how you check that. So if it's dash, then tell our hero to dash. And very similar, if the scan code of the event, the SDL event is slash, then slash. Pretty easy. Directional stuff's going to be a bit trickier. So button holds. So we just check if a button is being held down in this one. Okay, so we got to build something else. Oops. Just comment this. So check for keys still being held. And you do that like this. So const uint 8 key states is equal to SDL get keyboard state, and just chuck in null here. It doesn't need that number of keys thing. Then we can use this to check things. So now I've got a lot going on in here, but first we're going to check if hero not able to move or no direction buttons are being held down, then stop moving. Slide to a halt. So basically just tell the hero to stop moving if they're not able to move and or you're not pressing a direction. So if, let's type this out. Let me just check where this bracket ends up in my cheat sheet. Okay, first one is hero's state is not equal to hero state move, and hero state not equal to hero state idle. Basically, your logic's going to change each time. I've got it so that you can only move your character around using the keyboard if they're in a moving or idle state. It's the only time the keyboard's going to help you out there. Or not sure why we got or. Or's fine, actually, for this one. So if we're not in a state where we can move, or none of the keys are pressed, which is what we were going to do, or key states up. So key states is sort of this, we end up getting an array pretty much, and we just check each slot in the array, and we're going to just check every button. So it's going to be, I guess, a positive unsigned integer of some sort. I guess a 1 or more if it's being pressed, or 0 if it's not being pressed. So we just check that. We're going to just check all the buttons. Well, all 4 anyway. I'm just going to move this down to the next line. Key states left. So either you can't move or you're not pressing the directional buttons, then heroes moving is equal to false. Else, now I think I'm missing a bracket. Yes, there we go. Else, you must be pressing some sort of button. So what should we do? This is probably not the best way to do this, but ups. So if key states up, probably could have worked this out a lot better. So upright is if key states right. So if you're holding up and you're also pressing right, then that means hero move is whatever 270 plus 45 is. As you can see, I was pretty lazy on that. Didn't work it out. Else if key states left. So if you're pressing left, make sure it's a lowercase s. Then hero move. Now, hero move takes a direction, so an angle. So that's why I'm doing this. 270 minus 45. Else, hero move just 270. Not great, I know. I guess I could have, it's either plus 45 or minus 45, so you're either going up right or up left, or just plain up. So I guess I could have just saved this plus or minus 45 in a modifier, but whatever, it's fine. So the downs part of it, so pretty much the same idea. So we check down instead, and it's going to be check down right first. Now this gets a bit tricky. We sort of swap how it's going to work. So instead of plus, it's 90 minus 45 and 90 plus 45. Otherwise, just 90. Cool. Maybe we're just moving just left. So if not up and not down, and not right, but we actually want to check if it's left, so left, then hero move 180. So if 0 is right, then left is 180, and then we'll check right. It's basically the same logic. We'll copy and paste that. Again, you probably could have found a nice way of doing this. So, oh, I'm missing a bracket. That's not good. Not up, not down. In this case, yes, right is being pressed, but not left. And 0, so move to the right. Cool, that's all our keyboard class has to do. Not bad? Cool. And this class just controls our hero. We just give it a, we tell it what hero to point to, and then when we get onto our game logic, which will be soon, then we just go, alright, call the update function on keyboard input, and if you're pressing something, then make our hero do something. Cool. Next up will be walls, something to bump into. After walls, we'll get on to actually like showing the game again. So we'll build stuff, and you'll be able to see, you actually be building something and seeing it run, and you can play. So we'll do that soon. We just got to build some obstacles first to make it, a bit more fun. Alright, cool. See you next time. This time we're going to be making classes relating to wall. So if we go back to our cyborg battle, debug, sorry, res, then I'm talking about this. It's just a block so we can bump into something, some sort of obstruction. Alright, we're going to build that. So add new item, header file, wall, and this one won't take too long to do. I'm missing the N up there, if not defined. There we go. This thing only needs to know about entity. It's pretty basic. Class wall inherits everything from entity. Cool. Public, it's got a constructor where it takes a animation set. Yep. Has an update, which we're going to put the code in there for it, but it's not going to be that necessary. Change animation, int new state, bool reset frame to beginning. We're overriding that because we have to. And update collisions we have to override as well. Well, actually we don't have to, but that's for checking on how it collides with stuff. I'm going to leave this empty. Walls don't move or do anything. Don't do anything. Walls don't move or get pushed in this game. Cool. We'll have to make 3 functions. Pretty easy. Let's jump into the CPP file. Good. And just gonna go back to wall and copy these 3 that we're working with. Paste that there. Do this part again. Now I've put some code in update, because if you want to replace that one image with an animation set, so instead of just having a static single image, you want to have it animate, move in some way, then that's why I've added this extra code. It's not totally necessary, but we'll get to that. So this wall's animation set is equal to the animation set sent in, so passed in, and then basic setup stuff, or default values, whatever. Solid, yes it is. Collision box width is equal to 32, which is the same size as the entire image that I'm using. And I guess I'll just call, oh, not just yet, I'm going to set up collision box y offset is equal to -16, so which is half of 32, and I'm just going to call update collision box there. Alright, over in update, I guess this is the timer stuff, so update collision box if you need to. Okay. If current frame is null, or current animation is null. Oh, I didn't need brackets. Then exit early, we can't do much with that. Otherwise, frame timer plus equals time controller dot dt. If frame timer is greater than or equal to current frames duration, then it's time to change that. Very similar. We've already done this with Hero. Now we don't do anything special if the animation's not finished or whatever. We just want to move on to the next frame and cycle it back around to the start if we need to. Now, our frame class has, where is that? Sorry, animation class has it. Animation class has getNextFrame, which calls getNextFrame, and the good thing about that is getNextFrame number adds 1 to it, otherwise sets it to 0. So it'll do the looping around for us, so we don't even need to check if it's at the end of the animation or not. I only do that in Hero because certain things change the state at the end of animation sometimes. So for wall, it's pretty simple. All we got to do is go current frame is equal to current animation get next frame and pass it the current frame, and it'll loop for us. So if it'll get the next one, if it can't, it'll loop back around for us. So too easy. That's all we have to do in there. Change animation, not super useful, I guess. I guess I could call this one in the constructor, I suppose, but change animation, all we're going to do is just go current animation is equal to animset get animation wall and current frame is equal to current animation get frame 0, so the first one. And we don't even care about these, it's just that we have to override this particular function so that wall is not abstract as well. And we might as well call that here. We don't care about what the new state is, and it honestly doesn't matter what we pass in, so I'll set that up properly. Cool, that's all this thing has to do. It basically just sits here and animates itself, and other things bump into it. Done, that's wall. So I've hit another really short theory class. I'm going to be talking about game loop. So if we run a game at the moment, it's still just drawing just a single image. We sort of want our game to load up all the assets, set up the entities that are going to be in the world, and sort of kick off a process. And we call that, it's not always appropriate for every game, but basically just a game loop where you basically control everything with pretty much a big old while loop. So while not quit, update, so update everything, and then draw it. It's the basic idea. So this thing, this loop here, just keeps going round and round and round. In update, it's dealing with things like user input, AI, collision stuff, movement, etc. For all entities, it's gone off screen, whatever. But also win, lose, conditions, and other stuff as well. Anything else? Cool. And then draw just draws everything that needs to go onto the screen. So in our little game, just all the entities and also the background and other things like UI, whatever effects you need, whatever. Now this loop keeps going until a few scenarios. So if the user decides to quit out of the game, then we should quit. Or if they've died, or for whatever reason, it's up to you on whatever conditions you need to decide we'll exit that game loop. So this concept is what we're going to be coding next. We're going to make a game class, and it's going to have a type of game loop inside it. It'll also set up all of our entities to start off with and run some logic as well. I actually make this class probably a bit too chunky in the end for what it really should do, but that's okay. It's what we're going to do next. Cool. That's that done. We'll hit code next time. See ya. Cool, we're back from theory, so we've gotten onto some code. So let's make a new class. I'm calling it game. New item, header file, game. if not defined game. So chucking the usual stuff. So my game loop and a bunch of other logic is going to exist in this class. This thing basically just manages the game, everything in the game. So includes globals. We're going to keep coming back to this class and adding on to it. This is just, we're just starting with the basics here. We've got a hero. We've got walls. We need to know about keyboard. This is probably included in another class, but can you include the drawing functions as well? It's just what I've got here. Class game. Okay, so like I said, we're going to keep adding to this thing, so I'll just skip over in my cheat sheet the stuff that we're not up to yet. So first thing we want to manage is animation sets. So it's all kept here. This thing will clean this stuff up when it doesn't need it. So the hero's animation set, and we've got the walls animation set as well. We also have a basic SDL texture for the background image, or in our case it's going to be the ground that a player runs around on. And we'll have a hero, which we'll dynamically build at the start, just because we'll get in the habit of doing that. And we'll have a keyboard input called hero input. And we're going to have a list of entities that we're going to keep track of for walls. So the entity class has a static list of entities which we're going to use as like a guide for everything in the game, but we're also going to make these little smaller sub lists just in case we want to just deal with things, just deal with walls. So a single wall entity will exist in this list, and also that entities list that belongs to the entity class. You'll see what I mean when we get there. It's alright. We've got a constructor for this, and a destructor, because we're going to deal with a lot of dynamic memory. Also, we got update and draw. That's it. So probably too much logic is going to get chucked into update, and I'm going to use update to also call draw as well. And update keeps running a loop until it needs to exit, and then that's it. The game will exit. Cool. Alright, save that. Let's make a CPP file for that. Game, include game, yep. What do we need? Not much, just these four. Just the functions. Yep. We'll just prep these so we can chuck code straight in. And that there too. Copy that. What's its problem? Keyboard input. We made that a while ago. Turns out I forgot to make all of its members public, but I'm doing it now. That's what it's complaining about. So if it says it's none of its members, well, it's inaccessible, that probably means you don't have a public side of that class, so you can't really do anything with it. So I just fixed that problem. Good. So just add that public section to keyboard input as well. Something I missed, that's alright. We're only human. Okay, so string, we're going to keep track of this thing called resource path. It's going to help us load stuff up properly. Yeah. Okay, so our background image is equal to load texture. Basically, our constructor is just going to set everything up. So load a bunch of textures and things in. Res path plus map.png. And you got to give it that renderer as well. Yeah. Cool. Forget about a bunch of other things I can skip over. I've got sounds and stuff in here, so I'm just trying to find what we need. Right. Now, we're using my group-related code for loading up frame data. And the way that I manage that is we're going to create a list of data group types, which describes the type of groups we expect. Types of groups of data we expect on each frame. So it's alright. I'll write comments and explain each small bit at a time. So hold a list of group types. This list describes the types of groups of data frames can have. So we're going to make this thing list data group type, data group types. So what are we going to chuck in here? So what data can a frame have? First thing, collision boxes. So I'll just open up my project again. Open up that FD set file which describes animations and data, frame data for each frame that relating to a sprite sheet. So my Udemy cyborg.fd set tells us which image to load, how many animations there are, the name of the animation, how many frames it has, and then it starts to describe data that a single frame can have. Now, clip, offset, duration, and index are all default ones. And then this is the stuff, the data after that is what we've got to list here. So collision boxes, that's a type of data that we can load up. So we're going to list that. We're going to say the name of the group is called collision box that we're expecting to find. And the type of data that it is a box group. The reason why it's very open-ended is if, for whatever crazy reason, we have multiple collision boxes per frame, this code supports that. So you might have all different coordinates here. You get the idea. Doesn't make a whole lot of sense for our game, but I'm making this code flexible so that you can just dump it into any game that you're making, and then you can just load all sorts of data up that you need. So we're describing the additional bits of data that a frame can load up. So as I said, clip, offset, duration, and index are all part of it by default, so we're just describing any extra group. So collision box. Down later we have, where is it? Slash right, where we got? Where's hitbox? Went too far. Yeah, hitbox and damage as well. So basically we're going to describe, these are the types of groups that we could potentially read in. From memory, we don't even use this collision box anymore. We've hard-coded it, but I'm just getting the habit of doing it anyway. So collision boxes, although we have hard-coded the collision boxes, that's out of my brother's advice. We should have a collision box that doesn't change frame by frame. So even though the FD set has frame by frame collision boxes, we don't end up using them. But we'll still get in the habit of loading that up just in case you want to reference it for whatever reason. So data group type, collision box type. Now a col box type. Group name. This is exactly what you see in the FD set. Collision box. And what type of data is that? It's equal to data group type. And it's a static reference. So your choices are box, number, position, and string. So position is an XY value. Number is integer or decimal, and box is obviously the 4 coordinates that we need, and string is just words, sentences, whatever you need. So this is a box. Cool. We're also going to describe hitboxes, which we do use. So copy all that, change col to hit, and collision down here to hitbox, change that to hit over here, which is the data type is obviously box again, and damage as well. So I think we'll type this one out. Data group type, DMG type, that's just short for damage. DMG type, group name is just damage or lowercase. DMG type, data type is equal to data group types, and it just has, whoops, I want to need that as a capital, data group type. It's just a number, so that's the type that it is. So this is the extra bits of data we're expecting per frame that we could load up. So that's why we're making this data group types. It's to help us load information in. Cool. All right. Hero. Oops. Anim set is equal to new animation set. So we're just going to build a new one. And hero anim set, load animation set. Make sure this name matches that file in there. So Udemy Cyborg FD set. We give it the data group types, so the types of data we expect to see in there. Thank you, autocomplete. Actually, I did skip a step. We'll go back to it in a second. So the types of data we expect, so give it a list. Next thing is set color key. Remember, set color key means if the background color of your sprite sheet is a color and not transparent, then you probably want to set that to true. Transparent color index, I've got that as 0. So it's the first color in that image is going to be the see-through one out of the palette. And create white texture as well, yes, because our hero gets hit, we're going to flash up white versions of our hero. Now I skipped a step. We should add all of these data types to the list. So all we're going to do is data group types dot push back, and then we just add all these. So call box, might just copy this to make my life easier. Call box, hitbox, and damage group types. Add it to that list is passed in, now it knows what types of data to expect. And it's quite flexible, so you can make different FD set data groups per thing. I've just made it across the board that we expect these data group types for everything that we load up for this project. Okay. Now we're going to do the same for the wall. Wall anim set is equal to new animation set. And we're basically just going to do the same thing. Wall anim set, load animation set. Make sure this file matches the same file in here, so wall.fd set. That's what we're trying to load up. Pass the same stuff, data group types. True. This is a wall though. Actually, we'll just run with all the defaults for that stuff, so we're just going to give it just that. So the defaults is don't set a color key, so there's no, we shouldn't set anything see-through, and we don't need a white texture either. So that's all we need for walls. Okay. Now we've got a bunch of animations. We can start building a hero. Hero is equal to new hero, and the constructor takes a animation set, so we'll give it the hero animation set. I'm going to make sure that the hero's invincible timer is 0, and I'm just going to make sure that he's in the middle of the screen. So globals, screen width divided by 2. Yeah. Now we've built a hero. Now we're going to tell our keyboard input for that, so hero input, that its hero is equal to hero. So tell its hero pointer to point to the hero that we've built. So now this thing will manage our hero, which is good. So tells keyboard input to manage hero. We'll just put a comment here, build hero entity. So build our hero, we've got some keyboard that will look after him, and we're going to add him or her to the entities list. So entities list just keeps a big list of entity pointers, and hero is a type of entity, so we just chuck that in. Cool. To the entity list. Alright, walls are a bit different. Well, not that different. So I just built some for loops to generate all these walls just around the borders of the screen. So we're going to build all the walls for this game. first build walls on top and bottom of screen. So for int I equals 0, I is less than globals screen width divided by, let me just quickly check something. Yeah, that's what I thought. Divided by, well, I wanted these right next to each other. You can see that my wall.png is 32 by 32. So I am going to divide this by 32. So how many times does 32 go into the screen width? My screen width I've chosen divide evenly by 32. So I'm making a bunch of assumptions here. And I++. There's our loop. So it's going to just iterate through the number of times that 32 fits into the screen width. Wall pointer, just going to make a new wall. It's equal to new wall anim set, like so. This new walls x is equal to I times 32 plus 16. So that's 16. There's a bit of magic numbers. I should really sub these out so I can, with variables, so it's a bit more readable. Actually, we might as well do that. I'm just doing this up on the fly, so we're just going to make a few things. So we're going to have int tile size is equal to 32. And just going to sub out 32 with that, and half of that. Because the origin of a wall in its FD set is in its center, so I want to set its x and y properly. So I times 32 plus another 16, which is half of 32, to put these in the right spot. Alright, new wall is equal to, this is the top row, so this is just, not global, sorry. The y is just tile size divided by 2, so just the 16 down. Now we're just going to push this back on the walls list, push back onto walls. So adds this pointer, well, the reference, I guess the memory address of where this new wall is into this list, and we're going to add it to the entity list as well. Good. Now that covers the top. It was in top row. This is sort of basic logic stuff. If this is going over your head, it's because you're basically just copying off me. If you had to think about it, you would solve this problem yourself, but you're following me, so that's why this stuff may go over your head a bit. But that's okay. Basically, we're just open Photoshop, so when it pops up, I can sort of show what we're doing. Now, don't forget pointers point to the memory address of something. So when I make a new wall, I've created somewhere in my memory enough space for a wall and allocated memory to it. And this thing just points to that. So if I go new wall is equal to new wall again, this wall that we built here still exists, but we're no longer pointing at it with this pointer called new wall. So I'm reusing the pointer. and that's okay. So using pointer to create bottom row, I need to do new wall here. I can't just set it and then add it to the list because you'll be changing the values of the existing wall that we just built. So you want to make a new one still. And you didn't have to reuse the pointer, it's just, I figured I'd chuck it in there just to see how many of you guys freak out with that kind of stuff. Okay, so the X stuff is going to be the same as above. So it draws it in the same X along through this loop. Just the Y is going to be different. Y is equal to globals screen height minus, let me see, so we do minus, let me just test this here, it should work, minus half a tile size, just to bring it up. And then add that to both those lists as well. So just copy these two lines here, paste that there. So you're adding this new wall to the list and to the entities list. So when we do pushback, it's going to copy the memory address that you're storing in this pointer and pass that back. Good. Okay, that draws the tops and bottoms of my arena. So pretend this is my screen size. This loop's just going, okay, I draw a top tile and a bottom wall and just keep going like that at a time. Every loop cycle it draws another one, but they're even, so you eventually get the whole top filled in and bottom as well. Oops, didn't mean to do that. Okay. Now for the other ones. So now the sides, because we're going to wall in our characters so they can't walk off screen. For int I is equal to 1 because we're going to be drawing it down, but we've already filled this spot in. We don't want to draw a wall on top of a wall, so we're going to start here for going down. And here, I guess, at the same time. And we don't need to draw another one here, so we want to draw it one short. You just want to fill in this gap here, basically. Okay. I is less than globals screen height divided by tile size minus 1 I plus plus. So that minus 1 makes sure that we don't draw over that last wall with another wall. And the logic here is sort of the same, but we're changing the values. So if you want to copy all of this and paste it here, that's fine. So we're going to fill in left column first and reusing pointer for right column. So X in this case is going to be, it's reversed pretty much. So it's going to be tile size divided by 2. And the Y value is going to be I times tile size. So 32 times whatever I is up to. The first time is 1, so 32. Plus half a tile size. And then we make sure we update this one here too. So it's going to be oh, hang on. I definitely missed something. No, we're good. we're good. Yeah, okay, so, and again, X for us is going to be just, actually this one is a bit more different, so we're going to be globals screen width minus half a tile size. Yep, and our Y is the same as up here, so it's I times tile size plus another half tile size. So paste that in there. Good. That's built all of our walls. That's also all of our constructor done. Okay, destructor. I want to clean up that background image, that's for sure. So when the game exits and we're cleaning everything up, we're just going to make sure we delete everything properly. So we're going to remove all the entities from that global entities list, but don't delete them as we go. That's what we made this little sub list for, just in case. So it's asking for a list of entities pointer. This is just a generic list of pointers. It's not a pointer to a list of that, so I just give it the memory address. So make sure you brush up on pointers and dynamic memory for all of this stuff for sure. And then we just start deleting stuff. So delete hero animation set, delete walls animation set, delete the hero. And let's get rid of all the walls properly too. Remove all from list. Walls. But yes, actually delete them. So delete all the walls. Good. Update. Update's the biggest one. It's got some keyboardy logic and stuff in here as well, which I'll talk about as we hit it. So bool quit is equal to false, like in my drawing from the last video. I'm just going to make a SDL event E for convenience sake. I want to set up my time controller before the game starts. So time controller dot reset. So whenever we reach here in execution time, make sure we reset all our timers. Now the game loop. So we got while not quit. So this is like yesterday. Well, whenever you watch the video, last video. So while we're not quit, do stuff. So first thing is we should update our time controller. Update time. That'll help. If we don't update this, everything will be paused because it won't think that any time has passed. Which is kind of good. You can use this to freeze time if you ever need to, if you want to add those special effects. Now we're going to, with our big list of entities, we're going to remove any inactive entities from the list. So we're just going to add this in just in case, because you never know when you'll need that. It's just so that I basically treat entities that are not active are turned off, and in this game they won't ever get turned back on. So I just want to get them out of the list so that we can speed things up. Okay. Now this is how we use SDL event. SDL event has a whole bunch of stuff. Let's have a look at what we can see. Type, common events, window events, keyboard events, text editing event, text input event, mouse events, joy axis event, gestures events if you're going to do touchscreen stuff, touch finger, drop event, drag and drop event data. So if you want to drag and drop stuff, that's cool, we can do that. I didn't even know that was in there. That's kind of cool. Plus other stuff. So to check for that, we check for any events that might have happened. We do that like this. So while SDL poll event E basically just goes, and while we can still find events that have happened, keep looping through this bit of code, which is very handy. So let's pretend 3 things happen at once. Let's say you press 3 keys at once. It finds the first event, which is the first key in that list, and then runs through this code, comes back to the top of this loop, processes the second key press, and then runs through the loop a third time to process that third key press. Obviously, it doesn't have to all be keys, but that's how this works. So whatever event happens, it'll do one at a time. So if the type of this event is SDL quit, then quit is equal to true. This happens when you close the window. So if we close the window by clicking the little cross button at the top, we're saying, hey, we should quit. If you don't put this in, then that cross button won't do anything. So we can check for those events as well. So yep, quit our game loop if they hit that little close button, which is good. Now, if key down event. So if e dot type again is equal to SDL key down, that, then using a switch statement here on the e dot key system dot scan code. So which button was pressed in this event? So switch case on which button was pressed. I'm not a huge fan of switch case stuff, but I did it for this one for whatever reason, so it's good just to have multiple things in a project like this, so why not? SDL scan code escape. So if they press the escape key, so ES, this thing, so ES key been pressed, then again quit is equal to true, and break out of this case. Next case, SDL, scan code. Now I've got space here when you press the space bar, because I'm going to reset the player after they've died if I press space. So I'm going to come back and change this up a bit, but at the moment all I'm going to use that is if you press space, then you're just going to get all your health back and whatever else revive does. So just revive the hero when you press space. So at the moment that's going to be handy for testing. Next one. Apparently that's it. Just checking for escape and space there. Otherwise, whatever happens, as long as there's some sort of an event going on, we should give our hero input the SDL event as well. And it'll do the checking it needs to. So remember, this thing checks, I'll jump into it, checks if it's key down, do some stuff, otherwise check some key states, buttons pressed, etc. So we're just saying, regardless of above, we should probably also get the keyboard input for hero to check stuff as well. Cool. Cool, so that's, I guess, input. Now we should update all entities. Cool. So for list entity, it's been a while, I've been using auto, but I did this code in different order when I made this project to the way I'm teaching it, but it's okay. So you can sub this chunk here out for auto, but it's alright, I'll just occasionally have it so you know what auto is actually generating. It's generating a list of pointers iterator, so something to go over the list. I'm sure I've said that to you a million times by now, and you're probably way jack of it, but oh well, practice makes perfect. So make this entity point to the beginning of that global entities list, as long as we're not at the end of the list. As long as we're not at the end, then we should keep going and doing stuff. All we do here is remember how awesome polymorphism is? So this is why update all entities in game world at once. All we gotta do is entity update. And remember, this list of entities, this global list of entities, is going to hold our heroes, walls, enemies, anything else you want. You can start adding extra stuff to this project, so like bullets, bombs, explosions, traps, items, all sorts of stuff. This will just update everything because all those hero and enemies and walls, they inherit from the entity class. So that's all we're going to do there. That's pretty good. What else are we going to do? And before we exit, we should draw all entities. Where I best just call this draw function, and I'm going to chuck it down there. I should really have more functions and break this up more, but whatever, it's okay. You guys can do the refactoring yourselves if you like. So, draw. First thing we do is clear the screen. SDL, set, render, draw color. I don't know why I'm doing this, but I'm clearing it with a specific color. I can't remember what this color is. You won't see it anyway. 145, 133, 129. I don't know. I think it's a type of gray. SDL alpha. Yep. So it's just a flat gray. I'm pretty sure. SDL render clear. So clear the screen with the above color. Draw the background first. So background is not an entity, it's just a flat texture. So all we're going to do is draw the background image, throw at the renderer, an X and a Y, which is 0, 0. So draw it from the top left screen down, top left of the screen, sorry. And now draw all of the entities. So for this is the exact same for loop as above. That's okay. List entity pointer. Iterator entity is equal to entity dot entities dot begin entity not equal to entity entities dot end. Yep. Keep incrementing our entities in the list, and again, this is why polymorphism is awesome. So we just tell everything in this list to draw. Good. And once you're done, now we've got to remove some code from main and chuck this in properly. But when we draw, so render texture or do draw on our entities, it's drawing it to an image that's not on screen. So it's storing it in our renderer. And when we're done, we think we're ready, finished with our picture, we want to show it to the world. So after we're done drawing / rendering, show it to the screen and go, hey, look what I did. And hopefully it's not hell broken and ugly. So this will actually spit it out onto the screen. If you forget this step, then that means you won't see anything drawing to the screen at all. It's pretty important. Alright, cool. Now this won't do anything just yet because we haven't added it to main. That'll be the next video. I think we've hit a pretty good checkpoint here. Alright, so we'll deal with main in the next video. So up until now, you've been taking for granted a lot of things that I've been doing. You're just sort of following my instructions, and hopefully when this thing runs for the first time in quite a long time, we've got a character running around and bumping into walls. Hopefully. So let's go over to main. Main.cpp. Yep. We're going to include game. Scroll down to the bottom. This stuff. Where does that start here? We'll leave window, renderer. Okay. I'm going to comment out our starting stuff, which is loading that texture up and therefore cleaning it up. Don't need that anymore. Cool. Alright. And instead of that, we're going to make a game object and we're going to tell it to update. And let's run it, and hopefully everything works and is not broken to all hell. It's freaking me out. Come on. Well, there he is. Alright, the animation's not working. Or the collision stuff. I got a dash. That works. Slash works. Movement is not working. That's alright, we'll fix that up in a second. And we're not bumping into stuff for some weird reason. Okay. It's been a while, so likely these things will happen. Oh, but you saw that the hitboxes were there, right? See, I've got debugging on, so you can see that red box is our collision box. You can see that's the same for these things up here too. So we should be able to bump into them. But we're not. So I guess we'll have to look at that. Alright, so perhaps we'll check hero first. Yep. Alright, let's fix this stuff. So it turns out I skipped a few things by accident or just fumbled it. There's only 2 fixes we need to do, which is good. So first one is we're not bumping into stuff. So I was testing that by going to the hero class, and debugging entity class and debugging the collision stuff, and I found that this check collisions function that we made doesn't return true ever because of we're passing in null for that where we want to store the intersection, which is interesting. I didn't know that. I had it different I have it different inside of my project, so I thought I could skip that, but turns out I can't. So make another little rectangle called intersection, which we're not going to use, we just need it so that this function will work, and chuck it in there. Now this thing will actually, if there's an intersection, will actually return true or false properly. So that'll fix our collisions, which is good. And our hero, I missed a step here. So if we were moving but we're currently not actually trying to run around, we went back to idle, but there was another one we needed, which is when we do keyboard input, it sets our character to moving and pushes them in a direction, but it doesn't change their state or animation. So if should be showing running animation. So this is in update animation. Yep. Let's change state properly. So if state is not equal to move, which it's currently idle and we're just running around, and we're trying to move, then change animation to move true. Good. Alright, so basically just what we call change animation changes our state to move and resets to the beginning. So this will only call if we're trying to move and we're in the idle state. Alright, let's test if these fix everything. Yeah, good, we're bumping into stuff. I can't run through them. Missing one more thing. Currently, you can see I am not sorting my list of entities, which is a bit funny. See how I'm like underneath that? Yeah. And I'm running around, which is good. Alright, I forgot to sort all our entities based on the Y depth, so we're going to do that next as well. So that should be in game. Let me just find it. Yes, there it is. Alright, so in game, go to game.cpp. Well, you go into the draw function in there. So So just before we try to draw everything, we got to tell it to sort. So entity, before we draw it, let's sort all entities based on Y depth. So entities dot sort, and then you give it a function to use to sort things. So that was our entity compare helper function that we built. Okay, let's try that. Yeah, good, I'm in front of those. That's about right, good. And we got dash. Dash is just a little quick little maneuver. And slash. And you can see whenever I slash, that pink hitbox shows up. So that only comes up if I'm doing damage that frame. Red is my collision box, and if you can sort of see when I'm moving around, it's very hard, you'll probably see it when you're doing it. We draw the last collision box of where they were in blue, so you might see a little blue square trailing underneath the red one for my hero. And you should be able to just bounce off walls and stuff here. That's about all, but that's pretty good. Going well. So if you don't want to see all that debugging information, that's pretty easy. We can just go to globals. Debugging. To keep jumping between header file and CPP file, if you click on a variable and press F12, it'll take you to the implementation or prototype of that. So if I turn this off, turn debugging off, then you get a cleaner view of our game. There you go. Cool. Good. It works. Alright. So I'll upload this project at this point as well. And the next thing we're going to hit is we're going to move on to our first enemy, but we got to learn about random numbers a little bit first before we do that. Cool. Alright. Catch you guys soon. Okay, so it's been actually ages since I've recorded anything for this, so if it seems slightly different, it's just because it's been about 10 weeks in between, so I try to work out where I was up to. We're up to random numbers, so go and find your main CPP under source files. Now to do random numbers, I guess the easy way, we got to include some extra header files. So up the top here, we're going to include should be C std lib. Yep. And include C time. Now normally I just add stdlib.h and time.h, but I got this little C thing in front of here for now. I'm guessing that's a Windows related thing, but don't quote me on that. Anyway, so we need these two. So this thing, amongst all its other functions, gives us access to srand and rand, and time is obviously time. Cool. Alright, now at the start of all this, we set up what the seed value for our random series is. So I'm going to set the random seed for the random number sequence. I'll explain what that is in a second. So you go srand, and so that it gets a different value every time, just pass in time 0. So what is this doing? Basically, random numbers on a computer are, well, they can't be really random. We can't just roll an actual dice or pick up a card out of a set of 52 randomly. It's going to be algorithmically come to the number. So there's some sort of algorithm that the rand stuff in this uses, and it generates a series of random numbers. So we plug in a seed value, and that helps generate a particular sequence of random numbers. So if I gave this thing the value of 5, let's just say it always outputs the numbers 600, something like that, 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 and then say another 800 more in this sequence before it loops back around. That's because 5 is used in this algorithm to work out this number, and that from that point on we can work out what the second number is, etc. This is good because if you are doing random stuff and it doesn't quite work, you can always run the same random number again back through it, and you basically simulate the exact same run aside from what the user decides to do. This is very useful for games with procedural generation, so games like Spelunky. So they tend to have sort of the speed runs or whatever, the daily runs of some sort. So instead of storing the whole maps that are generated so that everyone plays the exact same map, like sets of maps for that daily run, all they got to give back is one seed value. Now, if I keep putting in 5, I'm going to get pretty much the same AI doing the same thing aside from what I do. That's not what I want. Now, to make it different every time that I run this thing, I just pass it time. And this gives back an integer, but this integer is counting, I'm pretty sure that either the seconds from whenever this time system started, so like the 70s, I think. So it's always going to put in a different number every time I run this, unless you run it like within a second of itself. So that's good. That means I'm going to get a random number series every time, like a good unpredictable set. Cool. Now, whenever I need to get a random number, which you'll see a lot in the next enemy the first enemy we're going to build, we run this function called rand. And rand gives you a random number between 0 and, I can't remember the number, but 2 million or something like that. The biggest an integer can be, whatever that is. You can look that up. That's not that useful though, is it? So 0 to some crazy big number. So we tend to work in smaller, we want to have it, say like random 1 to 10. We use modulus. Modulus is handy, so it divides whatever the answer is by 10 evenly, so it doesn't break it down into decimal places, and gives back the remainder. So at the moment, this will give me results from 0 to 9. So if you want it to be 1 to 10, just plus 1 to it. So plus 1 moves it up to 1 to 10. Yeah. So that's an example of me getting a random number between 1 and 10. Cool. This is definitely going to help for our enemies because their AI is sort of random, but we sort of we weight the dice on particular things that we want them to do more often. You'll see. Alright, so we'll get on to the enemy next. So I'll see you in the next video. Finally, it's time to work on our first enemy. So this is good. So we've got a player running around, they can bump into stuff. Now it's time to get some action going and our character fighting something. So I'm going to break this into 2 stages. We're going to do the code for the first enemy this video, and next video we'll chuck them into the game so our character has something to fight. So let's have a quick look at what our enemy looks like. Our first one's going to be called Glob. And if you look in your resource folders, you'll see the the way I've sort of split it up is these first 2 frames are the standing frames, and then the next 4 after that is the walking. So it walks. Over here on the right hand side here is dying, and down here, these down here, the one on the left is the telegraph, and the one on the right is the attack. Now, telegraph, what does that mean? It's important to have in a lot of games enemies that telegraph what they're going to do. Telegraph is they do a particular action that gives away what their next movement is, so that the player can try to get out of the way in advance, basically. So these guys go red eyes for a second, and then they dive at you, mouth open, to try hurt you. So the player can learn these little visual cues about these enemies and then start getting out of the way when they need to. If we just had our enemies attack just randomly, just go straight for the attack animation, then sometimes it feels very unfair for the player. So telegraphing your attacks is a pretty big deal. Okay, so this guy's called Glob. So let me just get my cheat sheet ready. Won't take long. Try code over my laptop again. It'll be alright. Okay. Make a new header file. Add new item. Header file. And just call this one Glob. G-L-O-B. Yeah, cool. If not defined glob, then define glob, and if like I said, it's been a while since I've recorded, so I'm gonna scooch up to the computer, work out how I sat with a laptop on my lap and type at the same time. Alright, so we want to do random number stuff, so we want to take advantage of stdlib, cstdlib, and we've got globs are living entities, and we'll come back and add sound and stuff later. I think after we get enemies in, I'm pretty sure that'll be the next thing we do. Class glob public living entity, so it inherits from that. Public. Okay. Now these guys got a lot of reference variables, so it's gonna be a bit annoying, but you'll be okay. So static const string glob anim up, and then I'm gonna just copy this much so I can save myself some typing. Oh, even the underscore. Up, down, left, right, and then copy that again. And I'm just going to put the word idle in front of all these. Idle, so idle up, idle down, left, right. What's next? The attacks. So copy the first 4 again. Paste that. Oh, we do telegraphs as well, so might as well paste again so that we're ready. So anim attack up, down, left, right. So if you're wondering how would things have been different if we made a platformer, well, we wouldn't be doing 4-directional asset stuff, which would save you time there, but you'd be dealing more with the physics engine side of things. So, I don't know. Saving on animations is always good, I suppose. But this is a much simpler game to make, all in all. Alright, that was that's for all animations. Next is we're going to build all of our constants for what state our thing can be in. So static const int glob state, and I'll just copy that because it's definitely going to use that a few times. Idle, move, attack, telegraph, and dead. Now, aside from having a state so that code-wise we know what's going on and an animation to show what's going on, we're also going to keep track of what the AI is thinking. So these guys are pretty simple. They've got glob AI normal and static constant glob AI chase. Good, so they can do, I have to check what's going on when we get into normal, but I think normal is just they hang around and be idle, and then chase is just go after the player. And we're going to keep track of how many of these guys we've killed with a static. So I can't remember if I've used any statics before now, but remember that static variables belong to the class as a whole, as a group. There's only one of this variable that exists in our program called globs killed, and we use that to keep track of how many there are actually been killed, which is good. Next, let's see. Oh yeah, things to help the AI work stuff out. So we're going to make a think timer, which is equal to 0. When this is 0, this is my notes I've got. Choose to do an action. This is AI related. Okay, think timer. And just in case, who should I chase? So if you want to make this thing multiplayer, this is the start of that. So I'm saying they will find the closest target and hunt them down. Even though it's a single player game, I still like to put stuff like that in here early. Okay. AI state is equal to glob AI normal. So they start out with the normal AI state, that's where they are. Alright, onto the functions. We got the constructor, which takes a, if I can spell today, animation set, pointer, anim set. We just pass it the graphics for these dudes. Update function, a think function. Now we could have made a whole enemy class that these guys inherited from that had this think part in there, but it's not that big a deal. Every think's going to be different, I guess, but yeah, it depends on what you want to do. If you wanted to have a big list of generic enemies and then use polymorphism for all of them, just tell them all to think at once, then yeah, maybe a class beforehand that has a virtual think function that all enemies inherit is probably a good move. But we're not going to worry too much, because this think function for us is going to be called from within the update function, which all entities have to have anyway. Telegraph, attack, die. You see a lot of these guys die. Hopefully more times than you die. I had comments here, but I'm just going to ignore them, but it's pretty self-explanatory. Find nearest target So that will just set this target thing to whatever the hero is. And if it can't find anything, they'll just wait around until someone is there to hunt down. Change animation. Frame to beginning. Yep. Last two. Update animation. Good. Update damages. Cool. And that looks like it's about it. Let me just double check. I think we're good. If I miss anything, we'll go back for it. It's all good. Cool. Alright, we got the header file. Time for the CPP. CPP, glob. Make sure you include the header file that we just made. Yep, cool. Too easy. And there's a lot for us to do in here. Unfortunately, we got to deal with all the static stuff at the top first. So we're not going to get anything interesting in just yet. Glob, anim, up. Let's go up. And I'll do what I can to make this quicker as well. So we're going to do the same deal. Up, down, left, right. Up, down. Left, right. Ah, smooth. There we go. Okay, and all the other ones, so we can at least copy and paste this to save a bit of time. So we got the idle stuff, the attacks, and the telegraphs. So let's find the next one. Anim idle. I'm just going to do the idle stuff first. Idle, idle, idle. Update these as well. It doesn't really matter. So this is just for reference sake, so I don't really care about the camel casing right now. I did in my example, so I would have done that, but you never see this stuff represented anywhere on screen, so I'm not too worried about it. Okay, we got the attacks. So I'm going to chuck that in for the next 4. One, 2, 3, 4. Yep. And finally the telegraph. Well, not finally, we still got to do dying as well. String, glob, glob, anim, die. Not chase. Okay, now the next ones. The states. Different states our thing can be in. So const int glob state, and our first one's idle 0, And we'll do the others very quickly as well. At least this isn't too bad. Yeah. It's kind of weird listening to myself after all this time just to see how I was doing before I took that big gap. Much more calm doing these videos than I am in the classroom. I guess I have a bit of backs and forth and we joke around a bit in class. It's a bit hard to do that at the moment on my own. Because I'd just be laughing at my own jokes, which you guys don't need that. Alright, next thing. The different AI states. AI normal, 0, and chase. Finally, last one for our static stuff. Int glob. We're just initializing globs killed to 0. Gonna be a very handy counter, because when we get up to showing score, basically just going to be how many kills have you done. Okay, now I like to save time. I'm pretty sure I would have said this before. I'm going to copy all the functions, just paste them here, and I guess very quickly just structure them ready so that we can just chuck code in there. So stick these in front of all the function names. Yep, cool. Replace all the semicolons with brackets. Might even just paste that as well. Paste, paste, paste. Cool, alright. Pretty easy setup for us to start coding. Good. Good. Alright. Constructor. The only thing we're passed in, we better keep track of it. So my animation set is equal to the animation set passed in. Good. Alright, the type of me is enemy. Default. I change this up a bit later. Oh, no, it's okay. I manually set these, but if no one sets this otherwise, the X and Y, we're just going to set it to the center of the screen. But what I'm going to do is we're going to build these guys and then randomly give them an X and a Y within the arena. Cool. Move speed, 0. Move speed max. Just play with this until you find something that works, alright? 20 seems to be okay for me. HP is equal to whatever HP max is going to be equal to, which is equal to, all of our enemies have a bit of random health. So 10 plus, in brackets, random number, modulus by 20. So it gives us a random number between 10 and, I guess, 29. Yeah. If you want it to be up to 30, just do a +1 inside here. Once it's worked this out, just do a +1. Or just make this 11 straight off. Oh, but I suppose you want it 10 to that. I don't know. It's up to you. Okay, so what else we need to do in this constructor? A fair bit. Damage, so it's currently doing no damage. Our collision box width is equal to 18. collision box height is equal to 20. I just played around with this till I got it right. If you don't like it, just keep tweaking it till you find something. And just set my actual collision box width to this value up here. And same with this. Oh, it's raining now. Okay. And then a collision box y offset is equal to -14. Again, I just kept changing it till I got it right. Direction. Start them facing down. I tend to just do that for everyone. Sort of look at the screen by default. Change animation. Whoops, didn't mean to do that. Okay. Glob state idle. True. Update collision box, I guess that as well. Cool. Alright, on to the update function. This part's pretty average, what you've seen before, except that we also reference the think part of it. Okay, first, check if dead, or I guess more accurately, died. If HP is less than 1 and state is not equal to the dead state, then do some stuff. So change animation to the dead state. True. Yep. Stop moving. And finally, die. Good. Now, more or less, a bunch of these function calls are the same, except that we also do think. We think here. And the rest I'll just stack on top of each other. Don't think I need the comments. So update collision box, it's the same as our hero. Update movement. Let's see, update movement. Update collisions. Update hitbox. Update damages. So go hurting people now. Or taking damage. Can't quite remember. Update animation. Always good. And the invincible timer. Because all of our living things, when hit, get a little bit of time to sort of like live and not take damage so they can maybe get away. So think, only think if we are in a state that we can think. So if we're in, oh, not state, okay. Glob state idle or move. So only think about what to do next if you're in those states. If you're telegraphing or attacking, then that's not going to be checked here. We'll do it further down in this think function. Okay, so think timer minus equals good old time controller. time controller dot dt delta time. So it slowly goes down. Now if think timer is less than or equal to 0, then it's time to do something. I guess I'll put that note there. Oops. Time to choose an action. Cool. Alright. Reset the timer. Random 5 milliseconds. Fair enough. Pretty quick. Actually, no, sorry. 5 seconds. 5 seconds. Because this will be... It's a float, so delta time is going to knock it down by a small amount each time. So 5 seconds. Up to 5 seconds. 0... I'll put it in notes here. 0 to 5 seconds. Okay. Action is equal to random mod 10. So we're randomizing this timer, just making a quick little variable which gives us a 0 to 9 value, and it'll help us decide what to do. If action is less than 3, then moving is equal to false, AI state is equal to glob AI normal. Change animation to glob state idle. True, reset it. Okay. Else, we've only got 2 things it can be, so it's either we're gonna do the normal AI or the chase one, so this will be chase. This one's a bit bigger. Find nearest target, whoever that is, and if we found one, so if it's not equal to null, we're pointing to an actual target of some sort, not or, and that target's HP is greater than 0, then let's go hunting. Target. Let's get him. Okay. Float distance is equal to, and remember we did all those useful functions in entity, so distance between 2 entities, and I give it myself and my target, and it will give back the distance between me and them, which is handy. It's good. And then we can decide what to do based on distance. So if in range, attack. So if dist is less than 100 pixels, I guess, you can probably a good idea to set this up as a variable somewhere rather than have a magic number. So currently it's just not explained why I'm using 100 there. So first, telegraph our attack first, so players have a chance to dodge. Doesn't have to be very long, just something so that they not just instantly taking damage from all these enemies that are chasing them. And turn their state back to normal so that when they do the attack and come out of it, they're just going to stand around for a bit. Else, otherwise, move up to the player or target, whatever you want to call them. Aye. Yeah. Moving. True. Hunting usually involves moving, so we're going to do that. Change animation. Glob. State. Move. There we go. Should we reset the animation back to the start? Only if we're not currently chasing them or moving at the moment. So we're just going to set up a little conditional thing here. Glob, state, move. So reset the animations back to the first frame only if the state is not moving already. Cool. Now where's this else? That is... oh yeah, down here. Now the bracket that links to the if target's not null and target's HP is, so we found someone and we're gonna hunt him. Else, we're gonna put else to that one as well. Else. Pretty much just run the other one, the other bit of logic anyway. So moving, false. Let's just steal it from up here, hey? Same thing. Moving is false. AI state is equal to glob AI normal. Change animation, glob state idle. Same as above. So just go idle. No targets. Go idle. If you want to make this look a bit nicer, I suppose it'd be good if you had a state where they can either be idle, just stand around, or maybe just walk randomly around the map, just to make it a bit more interesting when there's nothing to hunt. But we don't really care about that right now. Okay, so out of this, how many brackets out do we need to be? 1, 2, 3, 4. Out of all of them, but stay within the function. If chasing a target, and do this. We'll do that. Hunt them down, basically. So if AI state equals glob AI chase, and I'm not dead. So if this enemy's not dead and they're in chase mode and they're active, so they're not gonna get deleted basically, then get the angle between me and the target. Angle between two entities, that one there. Yep. Move that way. So move at that angle. Good. Cool. All right. A few more to go. These next few are short, which is handy. I'm just going to grab some water. Good. Good. All right. Telegraph. When they're telegraphing, I don't want them moving. I want to make it very obvious that they are preparing an attack. Frame timer equals 0. Change animation to glob state telegraph. True. Reset it back to the start. That's all I want to do for that. Attack. So we'll call attack at the end of the telegraph animation. So it'll be down later when we call this function. Again, moving is false. Frame timer is equal to 0. And what we're going to do is we're just going to push the enemy at the player instead of make them run at the player. So we're sort of doing a lunge. So it's kind of like if you jump forwards, lunging, your forward movement is controlled by, I guess, velocity and things like that, rather than you actually pedaling your legs to move further. So that's why I'm pushing the slide amount instead. Slide angle is equal to their current angle, so where they last tracked you to be. And change their thing to be attack, which should be showing up in my list here, but it doesn't matter. Yep, definitely start the animation from the start. Good, not so bad. Dying. Moving is also false, so stop moving. State is equal to our dead one. Change animation, just going to check its state that we just set it to. Yeah, reset it to the start. And later, hopefully I remember to do this, to do add dying sound to enemy. We'll do that later. And add to our score count. So glob's killed ++. Cool. Find nearest target. Now this one's kind of useful for if you've got more than one hero running around, or maybe they hunt down all sorts of different types of enemies. It's not heaps useful for what our current example will finally be, but because there's only going to be one player. But like I said, it's a useful function to learn about. So I'm going to set it up. Find closest target. So for good old auto, entity is equal to entity, oops, bumping the keys, entities list dot begin. As long as entity is not equal to the end of that list, and entity ++. So cycle through all the entities in the game at this point in time. Now if dereference the entities type is equal to hero and our hero is active. So if we find in the list someone of the type hero, check if they're active, and then okay, right. Right, this splits in two. So if I've found my first hero on the list, I better put notes about this. If found first hero in list just set them as the target for now. So if my target pointer is still null, basically, then target is equal to, I'm going to cast them to a living entity just because I know it's safe, because all my heroes are living entities, just so I can check HP and stuff. If can't cast to living entity, like if we accidentally called our walls, like gave them the type hero, then it'll throw casting exception, which wouldn't be good. But we're assuming we coded everything properly at this point, which, you know, is probably not a good move because we're all human, but whatever. Otherwise, does this other hero, is this other hero closer than the previous target? We've got distance between two entities, very handy. So this and who we're up to in the list. So entity is less than, call this function again, me and the current target. So is this new thing in the list closer than the target that's currently being pointed at? If so, then let's just steal this line here. Then the target is this new entity that we've just found. That's closer. Alright, getting there. Oh yeah, change animation takes a bit of time to get through. It's just kind of boring. And it's up next, so I guess we'll just smash it. Lots of copy and paste stuff. Okay, state is equal to new state. State is equal to glob state idle. Then we do all the directional stuff. So if direction is equal to do down, current animation is equal to anim set get animation, get me the idle down animation. This is where you'd have a lot less code writing, at least if you had a platformer. You only got left and right, right? But we go do all four. So I don't know why I start with down, but it's okay. Up, left, right. Make sure you update these things as well. So down, up, left, right. And we're just going to keep doing the other ones as well. Else if, else if. A lot of copy and pasting here, which is good. So copy that whole thing. And this one is move. Basically just take the word idle out of all these change animations. Oh, sorry, get animations. So at least that's easy. That's good. Yeah, else if the next one is going to be attack. So you might as well copy that attack, and we're going to replace the word idle in this set with attack. So choose all the attack direction animations. Good. I might as well copy that. It's going to be telegraph next. It's got two else's there because I'm an idiot. Alright, so we got telegraph. Yep, so just get rid of that word attack everywhere again. Cool, and finally, if you're dead. So I'm just going to copy that much and just gut it for what we need and don't need. Like, for instance, we don't care about the direction that they're in. We'll change this to dead. Sorry, die. Good. Alright, and then if reset frame, oh my god. Frame to beginning. I don't need brackets, it's only one line and then an else. Current frame is equal to current animation get frame 0. Else current frame is equal to current animations get frame and get my current frame's frame number. Cool. Alright. So that's when they turn around. So if they're walking, you want, say, like, they're on the second frame where they got their front leg up, one of their front legs up in the air, and then you turn around, you just keep it at the same position rather than reset it every time that they change direction. I'm sure I would have went over that back when I was doing that stuff. Okay, update animation. If current frame is null or current animation is null, then we're screwed, so just return. Animation wise, if we're in move state but not actually going anywhere, then just go back to idle. State is not equal to glob state move and equals. I'm looking ahead. So if you're moving but you're not moving, so it's thinking about moving but it's not actually doing that, then change animation to the idle animation, so idle, and just reset it. Cool. Now, sort of the same logic, but for the opposite. So if we're idle, but we're actually moving, then so if we're not moving, but we are, so if we're not in the moving state, but we are still moving, then maybe change this to move. It's good to have all these little things around just in case, so that you don't have weird animations running while you're doing a particular action. Frame timer plus equals time controller dt. Now, time to change frames. If we've ticked over the certain amount of delay that that particular frame needs, then it's time to move to the next frame in the animation. Current frames duration. And we check which point of the animation is it. So if at the end of the animation, and we break this up from memory because we want to sometimes loop the animation back on itself. So if they're just sitting there or chasing you, it's okay to loop the animation, but at the end of it telegraphs and attacks, we want them to actually do something more specific. Animation get end frame number, so we just check for the end. Whoops. And if we are, and we're in state telegraph, done telegraphing, now attack. So just call the attack function from in there. Cool. Else if state is equal to glob state attack. So if they finish their attack, then what do they do next? Just put them back into move. Yep, true, good. Oh, I just stretched my broken back. Okay. Otherwise, it's just going to be else, just loop back on itself. Else, doesn't matter, loop animation from here. Current frame is equal to current animation get frame 0. Cool, so if it's at the end of an animation, do that. Otherwise, if it's not at the end of an animation and we just finished showing one frame of an animation, then just cycle to the next one. Get next frame. Cool. Otherwise, just move to the next frame. Final function, this is good. So when you finish this one, go for a walk around the house or go outside, get some air. That's what I'm going to do. That's definitely what I'm going to do. And it sounds like what probably happened halfway through this is that the washing machine will beep. That'll be great in the background. So I guess my relaxation time will involve housework, which is kind of lame. So if we're active and we're alive and we're not invincible, I probably spelt that more correctly. Invincible timer. I spelt it wrong in my cheat sheet. What am I doing wrong? I'm missing a bracket of some sort. Active and... oh, I'm missing the end. Aye. This is why you should not code for too long in one big batch. Alright, so if I'm alive and I can take damage, then I'll see if I can get hurt from anyone. Specifically useful for checking if the hero can hurt me. But we'll just assume other things can hurt me because that's more reusable code for you guys. So we're just going to cycle through the entities list again. We've done this a fair bit, going through this whole entities list, and you're probably wondering, what? That seems pretty inefficient. Yeah, it kind of is. So if you have a giant map, our game does not have a giant map and has a limit on how many entities there will be. You will probably want to break this entities list up into sort of quadrants, and then only check if you're getting hit by things within your vicinity rather than everything in the world. So keep that in mind. I'll let you guys solve that problem, or maybe I'll do a video on that one day if that's what you guys want me to do. I will do it. Okay. Cycle through all the entities in the entity list. As long as that entity is active and it's one of the dudes that I can take damage from, aka the hero. If you have more types that they can get hurt by, then definitely list them here. So, if this dude's active and it's the hero, let's see if they can hurt me. Now, damage is on living entity class and not the entity class, so we've got to cast this thing. Reference as living entity so we can access hitbox / damage. So we do this thing again, we cast it into it, casting into, so it's sort of upcasting it from entity up to a living entity. Again, if it's not something that inherits from living entity, then you will get an exception thrown here, and since I'm not checking for exceptions anywhere in the code, it'll just crash. But we know heroes are living entities, so we're okay in this situation. Just keep that in mind if you expand this thing. Okay, so if this enemy has damage greater than 0 and we collide with them while they're with their hitbox, so my collision box versus the enemy's hitbox, so if enemy hits me, then here we go. I take damage, HP minus equals the enemy's damage. If you go into RPG stats, factor in your defense and things like that at this point. Don't just take the hit full damage. As long as my HP is greater than 0, we're going to play hurt sound here. Just putting this note here so that I can remember to find it. Otherwise, set the invincible timer to 0.1. That seemed to be a good amount of time, so that's in 0.1 seconds. Else, you're going to be dead, but we'll deal with that. We'll let update deal with dying. Okay, angle from other entity towards this entity, aka get thrown backwards. So slide angle is equal to entity angle between two entities, and we pass it this dude, the entity that we're checking, and this, which is me. So we want it from that other entity, the hero's perspective, facing me. That's the angle I want to get. Slide amount is equal to 300. I just played with that till I got something kind of nice. I launch these guys around a fair bit. If you want it to be less bouncy, then just drop that number. Or if you want it even more bouncy, go crazy. Put it high. And that's it. Good. That's our glob done. But he won't do much yet because we don't spawn any. So next video, all of this code is going to be in action because we're going to start spawning some enemies. Cool. So thanks for sitting tight again. Another long video. On to the next one. It's not too bad. Oh, there's a washing machine. There you go. Don't know if you can even hear that. Alright, I'll catch you guys around. Hey, you're back. Alright, so we made an enemy, but we don't spawn any. So let's change that. Let's go over to our game header file. Scroll to the top. And add them in. Include glob. Good. So far so good. Next we're going to just sort of get stuff ready here. So we're going to have, copy that, we're going to have glob animation set. What else do we need? Aha, a list of enemies. Just so I can keep track of things. Good. Let's see, what else do we need here? That's it, okay. Better start doing stuff with them. Okay, jump into game.cpp. We're gonna have to add, let's see, these animation sets. So after all this collision box, hitbox, damage type stuff, that's to help load the data up out of the frame data sets that we've made. Oh, by the way, I made that tool before, like, to help make this course, and it didn't have a name, but now it's 10 weeks later. That frame tool is going to be called Frame Boy, so pretty sure it's going to stick. So the link you'll see will take you to there. So if you want to be able to make your own animation sets, then you'll be able to get that. But anyway, it's got a name, Frame Boy, and we want to do one for our enemies now. So we'll just copy wall for the moment. Actually, no, copy hero because they're very similar. Paste that, change to glob animation set, load glob animation set. It's just glob.fd set. Takes this, true, 0, true, just the same as hero. Good, so I've added that. Let's see, we don't do anything with the enemies at this stage. Now on cleanup, we better make sure we delete stuff properly, so come down here. Yep. And we got remove all entities from list. Okay, cool, it's doing that. But we probably, let me have a look at this. That just takes them out of list, but we want to properly delete all of the enemies anyway. out of the list as well. So I should do it the other way, but it's okay. So entity, remove all entities from list, the enemies list. Enemies. And true, yes, delete them properly. Take care of all that dynamic memory. I should also get rid of their animation set. So glob anim set, delete that. So I've added that one and that one. Get rid of the animation set. Delete all the enemies that are left in the enemies list when we leave here. And a bunch of new logic that we're going to add inside of update. Enemy related. So just going to add enemies to build is equal to 2. I just made up some weird little algorithm to just grow a bunch of enemies and just tested it till I got it right. Enemies built equals 0. And it's not perfect, but you know, it'll do. Enemy build timer equals. So everyone, well, it's going to wait for 1 second before the first enemies are spawned. Now, where's this next part happen? Alright, now down here. Remove inactive entities from the entities list, but it doesn't delete them. But remove / delete enemies in the enemy list who are dead / inactive. Alright. Remove inactive entities from list, same as above, but we're going to reference the enemies list. And true, yes, delete them. They're dead, they're not useful anymore. Recycle their memory. Okay, just remember where all this is. So scroll down to where we update all entities. Just after that, we're going to generate enemies, or probably a more useful word is spawn enemies. That's probably a bit more common in this area. So if hero HP is greater than 0, so I don't want to just fill the screen with enemies if you're dead. That's kind of pointless. And there's another part we'll add later. Now inside here, if enemies to build is equal to enemies built, so enemies build is 0, enemies to build is 2 at the moment, so we've got to build 2 enemies. If it's the same, then we're going to go enemies to build is equal to enemies to build times 2. I don't think this whole algorithm worked that well, but it worked well enough to create a sort of interesting battle. Enemies built is equal to 0. Enemy build timer is equal to 4. Okay. Now, enemy build timer minus equals time controller delta time, so just take it down a few milliseconds at a time based on difference of updates on your screen. enemy build timer, if that's less than or equal to 0, so it's ready to just maybe build some enemies, and enemies built is less than enemies to build, and enemies dot size is less than 10. I only really want 10 enemies on the screen at any one time at this stage. Okay, glob enemy is equal to new glob, so we're generating a new one of those types of enemies. The enemy's x is equal to get random number. Oh yeah, I already had a header file I'd done all that stuff, but that's alright. I guess I could have used that for the AI, but that's alright, I showed you firsthand what that's really doing on the inside anyway. The globals screen width minus 2 times globals again, tile size. Do I not have that here? I can't remember what I did with that. I guess it's elsewhere. Guess I never used that. I can't remember. Either way, our tile size is 32 so 2 times 32 minus 32 plus 32 plus 16. It's like, what the hell is this? Matt, what are you doing? So first, get me a random number that is as big as the screen's width minus 2 tiles minus an extra 32. So I can't remember why I did that. Oh yeah, I guess it makes sense. I don't know, but basically, give me a random spot, like give me a random between the width of the screen, not including where the walls would be, and then, but it's still going to get it from 0 upwards, so add another 32, so push us to the right, so we're not spawning on the left hand side to the, like, it's going to be 0 as the lowest number first, 0 to the screen width area where there's no walls, but we want to move it over to the right a little bit so that you don't start in that left hand side wall ever. Plus another 16 just because these guys are kind of small, and it factors in for their offset. Basically, it's just going to randomize position out on the field that's not in the walls, which is what you want. Do the exact same for x as well. So it's not x, sorry, y. So change width to height. Everything else is the same. Yep. So basically just set enemies position to somewhere random within the arena. Arena's open space. Obviously, if they spawn on top of you or other enemies, it doesn't care about that. I've just made it a region that's not including the outside wall. When they spawn, we're going to give them a bit of invincibility. Just a very little bit. Enemies. Push back. Enemy. Yep. entity. So add them to the enemies list, add them to the entities list. Yep. And what else do I need to do? I believe that's it. Okay, let's see how we go. I feel like I'm missing something somewhere. Let me just scroll through the code here. Yeah, that's probably okay. Alright, let's just run it and see what happens. I'll try to fix it if it doesn't. So yes, let's build it. Oh, here we go. Whoa, okay, that crashed. Get frame. Alright, let me just sort this out and I'll get back to you. That's not. Alright, it was my bad. So, it turns out all of these up here. So, they do need to be camel cased. I forgot that they weren't just reference values, they used to look up all the animations inside of our enemies frame data set. So, very foolish of me. It has been a while, like I said. Do most of the course, take a huge gap, come back, break it. Always good, always fun. Which does bring me to a good point. They say the best time to fix a bug is when you first find it, because that's when your brain is working on it. So that way you don't waste time relearning stuff. So hopefully this works now. Yeah, whoa, okay. Here they are. Animation's a bit funny, but alright. Boom, boom, boom. Probably needs tweaking. I'll see what I can do. Oh yeah, there's something a bit broken in the code that I missed as well. So I'll fix that up in a second also as well. Wonder what I missed. Really not dying too well. Alright, I'll be on it in a sec. Alright, so if you look at the time and date, it's jumped a fair bit into the future. It's because I haven't had a chance to look at this for a while. That's alright, we can fix this bug. Well, not bug, it's just I missed some code. Alright, so I missed, if you go down into glob.cpp's update animation, I missed a few bits of code in here. So we didn't deal with at the end of the dying animation. So at the end of an animation, and we were checking for telegraph and attack, but we're going to slip in dying. Else if state is equal to glob state dead. Yep. Then for some reason the frame timer is set to 0 here. And if somehow alive again, then change state back to moving if HP greater than 0. Change animation. Glob state move true, yes, restart the animation. Else active equals false, because they weren't getting removed. We're only removing non-active globs from the list, so I was missing this definitely. So that's why when we killed them, they hung around forever. Now the other problem is they're animating really fast or weird. It's because I missed a little bit of code just right at the bottom. So still inside this function called change animation, update animation, and we're just inside the first bracket set in here. So time to change frames, if frame timer is greater than the duration of this frame, go to the end of that, just inside it, frame timer equals 0. Because the frame timer is just still way up there, so it was just animating pretty much as soon as it showed a single frame of one of these monsters, it would just jump to the next one. So it was just animating crazy fast. Now that should have fixed it. So they should get deleted from the list properly, so they'll get actually taken out, and they should animate at a decent speed now. Yeah, looks better already. Yeah, let's see if they can hurt me. So at least knocking me around. Yeah, cool, they're dying. How? Down I go. Cool, looks good. Alright. There's just one more thing I want to check, which is somewhere. And I think that's it for now. Alright, cool, looks good. So we got our first enemy in the game. Sorry about those few mix-ups, just because of how long it's been since I had looked at this code. Cool, alright, the next thing that we'll be doing is adding all the nice little things like sound, music, splash screens, score, and that'll be it. There won't be too much more to the end. Cool, alright, I'll catch you in the next video. Hey again, alright, this is just a small video. Looks like just something else I missed. If you go to your living entity, I set up this invincible timer thing. So currently our heroes are getting hurt, and so is our enemies, which is good. But we're just not reflecting that visually to our players very well. So go to the draw function in there, and in here, if they're active and all that stuff, that's fine, that's good. Now if invincible timer is greater than 0 and animation set, we're going to do the white sprite sheet is not null. Then do something else what it's currently doing. So just copy this, paste that there, and we're going to change it out for white sprite sheet. So basically, if you're invincible and you have loaded up the white sprite sheet for this character, then go ahead and draw that one. Otherwise, they're not invincible, so please just draw them the normal way, which was, this is the original bit of code inside this bigger if block. Now that white sprite sheet, I can't remember if I talked about this, but when we're loading up these characters, because I'm playing with 8-bit style graphics, I made like a custom bit of code that basically just loads in a character and ignores the background color and replaces all the colors in the palette with white, so that you've got your normal sprite sheet and your sprite sheet where all the characters are just all white, so we can just have them. It's useful for flashing and stuff. You'll see. I'll just run this. Here we go. Yeah, see now that when I hit the enemies, whoa, what's going on here? That's not good. Must be stuck in some sort of horrible loop. It was dealing with collisions. Alright, let's just run this again, see if that happens up again. Okay, alright, so you can see basically they flash. They flash when they're hit, and I should flash when I'm hit too when they attack me. Yep, see? That's all it was really gonna be. Huh. Alright, I'll have to double check that code. Expect a bug fix video very soon. Cool, alright. I'll deal with that soon. But basically I just quickly added a tiny bit of code just so we can flash white when we hit. Alright, talk soon. Alright, so you might have seen the code freeze. I think I've got a bug fix that works for this. You can let me know if you find it. It's very hard to sort of set up a predictable way to reproduce this. Anyway, in entity.cpp, we're inside the update collisions function down here. Move sample box up to the next spot. So the sample box moving from one piece at a time from where the entity started to where it plans to be. So in this, I added this line here. Movement angle equals, just make sure it's still correct. Because for some reason the code was looping because it overshot it and then it kept going straight past it. So this should throw it back in the right direction at least. So movement angle is now between sample box and the collision box. This seems to have fixed it, this one line fixed. So I'm going to leave it in the final. Cool. Alright, that's all. Alright, so whilst playing with the code, I found another bug. So only if your computer's running quite quick with a very slow thing does this happen. So, where is it? Update collisions. Here we go. Go back into here. Scroll down, scroll down, scroll down. Up here. Alright, so when we first build sample box, also build a float for collision move x, which is equal to sample box is x for the moment, and collision move y is equal to sample box is y. Yep, cool. And I'm just going to go down here. Move this stuff. Right. Here's the problem. Now, if your thing is moving so slow that it gets to a point where the x move and the y move are like, say, 0.71, because x and y on sample box are integers, see, int, when you put floats into integers, they just cut off the decimal point. They don't round up or down. So that's kind of not what we want. So we're going to keep track of the x and y in those new ones. So I can't even remember what I just called it. Collision move x. Just sub this in here for the moment. So this will still keep counting correctly for us. And then, so it actually increments, because the problem was if it keeps rounding down, your sample box moves 0 pixels every time you get stuck in an infinite loop. So we're going to update this one, and then our sample box is x and y. Just set that to equal collision box move x and y. So the decimal point still gets lopped off, but we're actually moving along these two floats that we just made instead, so we don't run into problems that way. So it's still okay that we round down for our pixels here for our actual output. It's just we want to keep the calculation moving through, so that's why we needed this part here. So this is a fix for float values below 1, e.g. 0.7 being, I guess, truncated to sample boxes x as that and int. Okay, that's not awesome, but yeah, this is a fix for that. Let me just test that works. And I found this fix after making this, I found this issue after making this entire course, so it's got some of the challenge, has the challenge character in it, the grobs, which is probably your video is at the end. Everything still works. Okay, good. Excellent. Cool. Alright, let's fix that problem. Everything was moving pretty fast, so it didn't come up. But I started adding onto this code just for a personal project and put some really slow moving things in, and then they would get stuck into an infinite loop because of that round down thing to rounding 0.7 something or other down to zeros every time. Alright, cool. Take it easy. Alright, so in this video we're going to add a basic splash screen and overlay for when you die. So what are those? Those are, here's my splash screen, basically just an intro screen. Cyborg till you dieborg, press space to start. And our overlay, every time you die this thing will pop up, press space to restart. And it will show the score that you had, which has to be done via code. So that's why it's not there. Alright, so I'm going to jump over to our game header file. Yep, and I'll just double check everything. Yep, cool. Alright, so scroll down. These things are basically just generic textures. They don't do anything, they don't animate. So if you want to animate them, go through the whole animation set process, but these guys don't move. So I'm going to make two textures. Splash image and overlay image. Cool. And also, we haven't played with drawing stuff yet. But there's every time you try draw something new, it creates a we basically just generate a texture. So we're going to make a score texture for drawing strings to the screen. Oh, screen. Yep, cool. What else do we need? A few extra things. Okay, so we got these three. Scroll down here, just add another one. A boolean for is the splash screen showing, and a float for the overlay timer. Cool. Alright, we're going to set these up. So jump over into game. Games constructor. And we're going to load these textures up first. It'll be pretty much the same as doing the background here. So splash image is equal to, totally just going to copy and paste that and change out what's written there. So instead of map.png, I want cyborg title. Cyborg title. If this doesn't work, it means we probably typoed that. Overlay image is equal to, paste that in again, just type overlay. So the same names as these two files that I pointed out. Cool. Alright, what else do we need? Oh, we better, it's the start of the game in the constructor, so we better put the splash showing is equal to true. So show that first image, and overlay timer is equal to 2, which we'll work that out as we go. Just scrolling through my cheat sheet, make sure I don't miss anything. Okay. Scroll down to the destructor. We're just going to clean up this stuff when we're done. So, looks like did I miss that in my cheat sheet? That's terrible. That's alright. So we should clean up our splash and stuff. So, splash image, clean that up, and also clean up the overlay. Now, we're going to keep deleting this score texture Oh, actually, we don't need to delete it as we go, but if they quit the game before it's ever used, it's still going to be null. So we just check. If it's not null, then we should clean it up. Cool. If never used. Sorry, if used, then clean up. Alright. Alright, on to the next function in here, update. Cool. And let me just find where I do something with this stuff. Oh, we update space. So if we scroll down, check for any events that might have happened. So the SDL poll event stuff and relating to keyboard stuff. At the moment, space just revives our hero, which is handy. But we're going to put in extra code in here. So if the splash is showing, then just make it not show anymore. Pretty easy. If the overlay timer is less than or equal to 0 and our hero is dead, then hold on. Then clean up and restart the game. Now this overlay timer, basically this thing will pop up saying what the score is, and we don't want people to just hit space immediately and skip what that screen was. We want it to at least show up for, I think, 2 seconds. So when that's down to 0 and they've pressed space and the hero's dead, then restart the game. So reset these things. Enemies to build is equal to 2. Enemies built is equal to 0. Enemy build timer is equal to 3. Overlay timer, we just reset that back to 2. And then a few more things. Glob's kill is equal to 0. If score texture is not null, then, oh, we did delete it as we go. Forgot about this little step. Then clean it up. And set it back to null. Okay, next thing. So outside of that if statement. Okay, so next thing. Remove all existing enemies. For a list of entity pointers, iterator, enemies equal to enemies, start list, enemies not equal to the end of the list, enemy plus plus, so cycle through all the enemies. And all I'm going to do is I'm going to let my enemy cleanup code deal with deleting enemies. All this thing does is just set their activeness to false, so they'll get cleaned up later. And then finally revive our hero. So chuck him in here. So he's in this big if statement. If that overlay timer is blah 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 blah, revive the hero. Cool, so this is our restart code. Restart code, start game code, basically. Cool, let's keep going. Okay. So we got that. Alright, down here. Basically what's a good way to put this? Make a overlay timer tick down. So that's what this bit's for. If the hero is actually legit dead, and that overlay timer is greater than 0, then overlay timer minus equals, just reference our time controller. Time controller dot dt. Cool. Keep going, update all our entities. Spawn enemies. Now, here, if our hero is alive and we're not showing the splash screen, so there's that use of that variable there. Splash not showing. Keep going down. Pretty much just draw to go, I think. Yeah, just draw. Alright, draw's gonna get bigger. We got new things to draw. So, if splash is showing, we're gonna draw the splash screen with render texture. There it is there. Splash image. Whoops, how did I do that? Splash image, reference the renderer. X and Y 0 0, so it draws it from the top left. Cool, so if the splash screen is showing, then actually draw it. Else, delete this thing. Let's go down. Else, do lots of other stuff, which we're going to do. So we'd wrap your existing code underneath. So draw background, sort all the enemies based on the Y depth, and then draw them all. So we got these here. And leave render present, because whatever we've drawn to the renderer, we want to show that to the screen. So leave that at the bottom. Now inside this big else block, we've got to add more stuff. So blah 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 if. Now this is to do with that score and all that stuff. So if overlay timer oh, okay. Turns out I don't remember this overlay timer that well. No, you get to see your character die first before the overlay comes up. That's what that's about. So there's a few seconds before this scoreboard shows up after you've died. Okay. So render texture again. Render the overlay image. Oh, plus all the other details, so just copy what's up here. Same as what we did for background and splash image. So just the renderer, X and Y 0, 0. Now if score texture is equal to null, so equals equals, now we generate some, we're going to generate the score text. So first we choose a color. I'm doing this in white. So it's, I can't remember the order of these things, hold on. RGBA. So for white, basically just do 255, 255, 255. So full red, full, is it RGB or RBG? Anyway, full green, full blue, and full, we can see it. If you want to do it like semi-transparent, just put that down to like half or something like that. 255 is the highest value, so 0 to 255 gives you a 256 color palette colors. Okay, so this is white. Good old string stream. Very handy for building strings. I'm going to feed it this, so enemies dispatched. Globs killed. Yeah, so just giving it that number that we're keeping track of, how many we killed. And then we build this thing. Oh, we need a reference to the res path again. We need that every now and again. Get resource path. Score texture is equal to render text you got to give this thing a string, so I'm basically I use the string stream to build this as one string inside the string stream, and then I output it as a single string into here. So this thing takes a string. The font is the next thing, so I'm giving it the path to, where is it? Vermin Vibes 1989. Now the license for this is in here, so I can't take credit for this thing. Blah blah blah. For any usage, donate any sum of money to blah 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 via PayPal. While I recommend the donation is some is what. Anyway, donate money to that guy if you're going to use this awesome font. And this font looks like this. So I need to reference this file. I don't want to try to type that and screw it up, so I'm just copying the name of that. So render text takes a string that you want to output, the font, so the text to font that you want to use, a color, and I have a few other things here. Font size, so I've got it as 30, and then you just got to give it your renderer. Cool, and that'll generate a texture out of that stuff. It's kind of annoying. You got to build textures for every bit of output on the screen. So make sure you look after these textures properly, delete them properly. Anyway, so once you've built this thing, we can draw it. So if we have already built it before, we just output it. And if we haven't, then we quickly generate it. So score texture, give it the renderer, 20, 50. So X and Y, just a little bit off from the top, and 50 pixels down. Not text, texture. There we go. Okay. Now, if I didn't miss anything, this should work. I've said that before though. Hey! Here we go, got our game. Now, when I die, that's when it's supposed to kick on, so I better let these guys wreck me. So, overlay time is ticking down. Yep, for 2 seconds, then this comes up. Enemies dispatched, 3. So we built that text. Cool, press space to restart. There he is in the middle, all the enemies are gone. Yep, and it just can keep going now, which is good. Let these guys kill me again. Won't take long. Unless they keep screwing it up. Come on, guys. Oh, God. There we go. Cool. And that's a wrap. Okay, so we've got enemies, got splash screens. We're missing a few things. Sounds, we need them. So I tend to make some sort of manager of some sort, just so I can keep track of things all in the one place. So we're going to make a new header file. Going to make a sound manager this time. Hang on. Sound manager. Okay, let's do the same stuff. If not defined sound manager, then define sound manager. Probably stuffed up the spelling of that, so let's just chuck that there. Okay. And if, okay, cool. So this thing needs just a few things. So we've got to include SDL mixer this time. That takes care of sound and music, which is very handy. Strings. Strings are always handy. Pretty much do everything with strings. And list. Okay, first thing I'm building is a little struct. So it's sort of like a, these things existed before classes. I don't know if I've made one prior to this, probably not. And I'm calling it sound listing, and all it has is these 2 attributes to it. Mix chunk, which is a pointer. Now, this thing's what your actual file is referenced, like your sound file is referenced through this pointer thing here. So if you want to learn up on that stuff, definitely do that. And string name. So I'm going to build a list of sound listings. So I pointed to the actual sound that we're referencing, the actual asset, and a name for it. And we're going to look after that inside this class here called Sound Manager. Okay, it has a list of sound listings. Sounds. Sound manager, we're just going to make a constructor, a destructor, and we got load sound, which takes a string name and string file, and play sound, pretty easy. So using the name that you gave it in the listing, it'll look it up and play it. One more thing, good old statics. So static sound manager, sound manager. Just so we can, wherever we include this header file, we can just reference an existing sound manager rather than having multiple or have to pass values around. It's my lazy way of getting around stuff. We've already done stuff with statics before. Okay, now copy these. Do I have to copy that? Probably. I don't know. We'll just type that one out. Copy these functions here because we're going to have to build them now in the CPP. New item, CPP, sound manager. Include sound manager. Paste that there. Let's fix this junk up. Okay. Cool, we're ready to do some code. That's your favorite thing, right? I hope so. Okay. Oh, why did I even do this? I don't even need this. So you don't need a constructor. You can delete it if you want. Okay, the sound manager, we'll come back to this to do in a second. Load sound. So we make a sound listing. So listing, and that listing has the same name that we've passed into it, so name, and listings sound is equal to, this is where we start loading stuff up, mix load wav. It's because it's damn it. Because it's a WAV file, so we just give it the file dot C string, because it likes, we're giving it a character pointer array for mix load wav. It's just the type that it takes. It doesn't take strings, so we just convert it to a character string instead. Cool, and then we just add it to the thing. So our list sounds dot pushback listing. Cool. So whenever you need to load up a sound, just do it. Adds it to sort of this like dictionary of sounds that we're building, and then you can reference them like whenever you want to play them. That's what this is for. So just go for list sound listing. You know, we're going to do the cycle through the entire list thing again with iterators and whatnot. SL, short for sound listing, sounds dot begin. So our iterator is going to start at the start of the list. As long as our iterator is not at the end, we're cool. And plus plus. If sound listings name is equal to the name that we passed in that we're looking for, then we go mix play channel. Now you can choose what channel you've got, or you can just, or if -1, play the first free channel, which is what we want. If you want to just cut short sounds on a particular channel, you can, just by putting in a specific channel number, but most of the time you're going to put in -1 here anyway. Alright, so the actual sound that you want to play, so sound, So a sound listing sound. And do you want this thing to loop? No way. Cool, and then break out of that loop. We don't want to keep searching everything else. Cool. Yeah, I do have to do the static value mentioned as well. Sound manager. That's what we're going to do for that one. Cool. Now this destructor is basically just going to loop through and clean up everything. So I'm just going to copy that for loop. Just that top line. Get rid of that. Okay. And there's a special way of freeing up sound, so we're just going to do that. Mix free chunk SL sound. Cool. So that basically just cleans up all that dynamic memory when we loaded up all those actual files. Cool. All right. We've got our sound manager. We should probably load up some sounds soon and play them. So I'm just going to have a break for a second and then we'll keep going. Alright, so we've got a sound manager class. Let's start using it. So go to your game header file. Up here, we want to include it. Alright, sound manager. Good. And in our game class, we're just going to load up all the sounds here. Everywhere else is where they're going to play. So let's go to let's see, we've got to load up 1, 2, 3, 4, 5, 6 sounds. It's not too bad. Load up sounds. Doesn't really matter where you put it inside this constructor. So we're in the game constructor right now. Sound manager, sound manager dot load sound. So my hit sound is going to be linked to this file called randomize2.wav. Oh yeah, so these files, so where is it? Randomize 2, somewhere there. There you are. These are all made with this thing called BFXer. So just BFXer. BFXer.net. Alright, this thing. Load. Oh, what? 2 loading bars? Alright. Go. Alright, cool. So this thing here, you can hit this and it will randomly generate a sound for you. Oh. Which is good. And you can play with that and make all sorts of sounds and save them as WAV files. And you can do randomize. That one's pretty cool. So this is pretty handy tool. So bfxr.net to get all those 8-bit sound effects. So I just made a bunch for this. And that's what we're loading in here. Okay, so we've got our hit sound. I'm going to do this 5 more times. I'm just going to change out the text. 1, 2, 3, 4, 5, 6. So the next one is the enemies when they get hit. Enemy hit. Hit. Hurt. 9. Again, if any of this doesn't work, just copy and paste the actual file's name just to make sure. Randomize 21. Is swing, we got dash. Which is just dash, which is good. Wasn't randomized. Growl. randomize 34. And you can always source your sounds for wherever you want, as long as you're not preaching any copyright, it's all good. And another randomized one there, cool. So our sounds are hit, enemy hit, swing, dash, growl, and enemy die. Now we start, pretty much we can just get these sounds to play now, which is good. So all the places where we want them to play are mostly in the hero and the enemy. So let's deal with our hero first. So our hero header file needs to know about the sound manager. Like that. Good. And where our hero needs to know about it is in, this first one is in slash. So go down to your slash function, press F12, it jumps you over there. It's a good little shortcut. To do add attack sound. Perfect. So sound manager dot play sound swing. And we're going to be doing a lot of this, so you might as well copy that line, delete that comment there. So in slash we're doing the swing. No doubt we're doing dash down here as well. To do add dash sound. Good. So do the dash sound in there. Where's the next one this guy needs? Probably when he gets hurt. Which is in update damages. What about dying? What do I do with that? I don't have one. I just run with the basic hit sound. Fair enough. Okay, so update damages. Here we are. So, alright, we can do the dying stuff here if we want to. So, to do playing get hit sound. Alright. Hit. There we go. So in here. Good. Alright, now our enemies need to do stuff too. So let's go over to globs header file. We're going to include that sound manager there as well. Yep. And first place they do it is looks like down in die. That's fun. Die. Okay, to do add dying sound to the enemy. Paste. Enemy die. Good. The next one is just the generic enemy hit sound, so that's going to be an update damages again. So I might just use this to bounce around. Okay, update damages. There it is. To do add hurt sound. Handy. Glad I put all those to-dos in there. Enemy hit. And apparently I don't use enemy growl at all. We loaded it up though. Oh well. So we didn't use all the sounds. That's okay. We missed. Just didn't use growl. Who cares? Alright, cool. Now, if this worked, then we should hear some sound effects of while we're doing stuff. Although I don't feel like that's everywhere. Hang on. This game. Yeah, we used hit, enemy hit, swing dash, enemy die. Yeah, that's fine. Whatever. Okay. Whoa. Whoops. Looks like my code is a bit broken still. Okay, let's not dash through the wall. Now, here we go again. Yeah, cool. Alright, and we're dead. Good. Cool. Alright, so we got sounds now. And I guess the next thing will be music. Cool, catch you soon. Alright, so last time we had a sound, now we just need music. So let's go over to our game header file, wherever that was. Here. And at the top of this thing, we're going to add a mix music pointer called song. Pretty easy. And in our constructor, I'm just going to load this thing up. So, where did I do that? I guess before or after the sounds. I guess after the sounds will do, because once we do this, it'll start playing as well. So we'll make it play straight away. Song is equal to mix load music. Okay. Okay, I'll do this weird chop and change stuff, you'll see. So respath plus, now there's a song in there called Fatal Theory.wav. Now that's not our studio's Fatal Theory song. Those are all done by Jamie Paris Bondak. This is a song, where is it? This is a song that my mate Ryan thought he was making for Fatal Theory, but I was asking for a different project. So Ryan Beveridge, this guy, did this song. So if you dig it, I'm posting a link to his SoundCloud. You can contact him for if you want to do some work with him, basically. So make sure you get this name right for this thing. He let me use it for my projects, so if you want to use this song in particular, you better talk to him. So just make sure that's right. Yeah, looks good. Talk to C string. So this thing takes a C string as well, but I want to sort of make sure I build a string and then convert it to a C string. I can't remember why I did that, but that's all good. So song by Ryan Beveridge, and I guess I'll just stick the link straight in the code here as well as out there. Cool. If you know any musicians, definitely just contact them and see if they can do any work for you, or go out and hunt for someone. It's all good. Anyway, so that's how we load our song up. if it worked, if song is not null, then we're going to play it. So mix, play music, song. How many times do you want to loop this? I want it in an infinite loop. So in this case, -1 means it runs infinite times, which is good. Alright, so we got our music playing. Now, we probably want to clean it up properly too. So, down our destructor, all the way down here. Destructor. We're just going to pause the music first. Mix pause music. So that just stops all the music channels, which is good. And then free music song. That cleans that up. And let's see if it worked. Build, run. There we go, music. Cool, good. Yeah, this song's actually, I got Ryan to make it for a little game I made called Blitz Smash, so if you want to see where that song's used, go and look at that project. Anyway, it's not that important, but anyway, yeah, music's pretty easy. So you can stop it and start it and play different songs if you like. It's up to you. Whatever you want to do, it's all good. Cool, done. Alright, so this is the part where I issue you a challenge. So if you look in your assets folder, Grob. So we've put globs in there. Globs are little blue guys, and they just sort of charge at you. Grobs is these little red dudes here. Now they just more or less, they have different AI, so we need to load them up. I know the imagery is the same and they're just red, but if you see the version of this game that I've got done, let's see, this one here, I'll load it up. They have different AI. So let's have a look. Yeah. Alright, so where are they? This one. Alright. Ouch. Cool. So the point with those guys is that they don't do a lunge attack, they just hurt on contact. So you got to swing your sword kind of close to them and hopefully they don't walk into you. So my challenge is to you guys, more or less build a new class called Grob instead of Glob. And these guys are constantly doing damage, just walking around. They don't do these attacks down here. So I'll provide the code so that you can have it as well, if you just want to sort of cheat sheet it and have a new enemy in there. But otherwise, see if you can build this yourself. So once that's done, that's pretty much the whole project done. We've gotten from the start all the way to the end. So what could you do with this thing now once you're done? Well, if you want to keep going with it, you could build more enemies. You could build different types of levels. If you want to release this game and make money off it, just more or less sub out all my artwork, because that's mine. And make sure you get music from someone who's okay with you to use the music. Cool. Alright, good luck with the challenge. Alright, so you made it to the end of the course. That's good. thanks for joining me for this. It's been fun. Well, I'll try to kill stuff while I do the final wrap up. Oh, it's a lot of red guys though. Oh man. Alright, so what do we do? We made this cool little game, which is good. Little hack and slash game with C++ and SDL2. And the good thing about this is it's, well, you can show people, you can expand on it, you can rework it and make your own title and sell it if you like. Obviously it needs more levels. You have to use your own art. But yeah, you can pretty much reskin this, add more to it if you like. What did we learn? That's probably more important. What you learned? Well, you learn how to work with SDL, C++, a bit more. I'm guessing it's probably good practice for a lot of you guys, because you probably came in at about intermediate level. So we also went through basic game dev, like Cody game dev stuff. So you went through like collisions and animations and things like that, which is good, always good, because they're pretty much your basics. Like this is not exactly the most fancy game. It's still pretty good though. But you know, it covers all the basics. And also you got to play with polymorphism some more, or maybe for the first time. Polymorphism is very good. So if you don't care about games and you took this course for polymorphism, I hope it was helpful. Should have been. So you can always expand on that side of this and go crazy, make more enemies that inherit from each other, or items and things, whatever you need to do. What's next with me? So in terms of course making, I will have somewhere on Udemy, there'll be a thing saying a list of potential things I'll take on, and you guys can vote, I suppose, on what things I should make next. It'll also have a list of other courses that I have run, I suppose. Oh, yeah, I don't know, just a suggestion thing. So it may be art, it may be code, we'll see. And thank you for coming along for the ride. It's been fun. It's been good. So I hope you enjoyed the game and the code and the course. Definitely give me feedback. It's my first course, so let me know. Cheers. Hey, it's Matt again. So, a couple of years ago I released this 2D hack and slash game course, which taught you about the basics of building a little simple game engine, input, AI, that sort of stuff. And now it's time to add some new features to that course. So I've added 2D camera system just to follow around our hero. Replace the old collision system with a way more efficient one, scope AABB. And I've added a boss. So that's all awesome. Another 4 hours of content there. I also changed out how enemies spawn. They now spawn in waves instead of the old kind of just dump them all over the place system. So there's a lot of new content. So if you're old, then there's new stuff to explore. And if you're new, then the course just got bigger. So there's more stuff that you can play with. Either way, I hope to see you in there. Let's get on to the code. See you soon. Hey, it's been like 2 years. I'm bringing you some new updates for the course. So we're going to bring in camera, we're going to change up the collision system, and I'm going to add a boss. So we're going to get started with the camera. The camera is just going to be a basic one. It's just going to make sure that our hero always stays in the middle of the screen wherever he is. And at the moment, our game screen's not very well. It's as big as a window, but I'm assuming that you probably want to make worlds that are much bigger than your window. And so, as your character walks around, you want to be able to see those things and keep track of your player. This is a very simple camera. I chucked it in just for fun. So let me go to this. Let me talk about the maths theory behind it first before we jump into some code. So all this camera is going to do is keep the camera exactly centered on our hero. That's all it's going to do. Alright, so let's say our game world is yay big. Say that big. But our window size is, I should change up the colors, hold on. Let's say window size is about this big. And let's put some numbers on here. Now let's say the window size is about 400 across by 200 tall. There we go, good, cool. So if we put our little hero in, he's going to be here at the moment. Yeah. Okay, but let's say in this whole game world there's other things, there's like massive treasure chests, some sort of gun, ammo, and lots of monsters. But I'll put one over here specifically. I worked out the maths earlier, so I didn't have to work them out on the fly. So roughly here. There he is. There he is. Good. Now, when our player moves, I'll get another color for this. Greeny. Just go red. Alright, so our guy walks over to here and a bit down. And he's somewhere around here now. Now, if we were using our existing code, it would mean he'd just walk off screen. But instead, we want it to center around him and show those things that he's nearby. So we kind of want it like this. Terrible. Everything's not drawn to scale because you can see I'm freehanding it. Alright. Now, let me go back to blue. Oh no, pink's okay. Now this little pink guy, he's off screen at the start because he's positioned at 450 by, hang on, I'll put that up the top. 450 by 50, so 450 pixels on the x-axis, 50 pixels down from the top. That's where he is, sitting here. We've moved our character over to 570 and 150. Okay. So to keep our camera center, I've kind of moved this pretend invisible rectangle over, and to keep it centered around our guy, because it's because our window size is 400, that means to get this centered right, I have to take half of this, half of that, and half of that to work out the X and Y position of where my camera should be sitting based on where this dude is right now. So my current X is 5, well, let me put something a bit more helpful. Cam's X is equal to my current dude's position, 570, minus half of our screen size, which is 200, which is that, which is equal to 370. So that's 370 here. So that's the X, top left X of our camera position. Cool. Now, cam Y, same rule. Our hero's Y minus half of the height of our camera, which is just 100. See, I set these numbers up. They're nice and easy, aren't they? Yeah, 50 down. Oh, it doesn't make heaps of sense because this guy is apparently 50 down, so I guess he should be touching this or something like that. Okay. Okay, good. Now, that's just to keep the camera in the right spot as our dude moves around. For drawing though, if I just use our current drawing code, it's pretty much just gonna draw whatever's in the original section of the start of the screen, and everything that's off screen will still be off screen and we'll be updating a camera's position for no reason. Now we have to update how everything draws to the screen. So that's going to be annoying when we get to coding that. It just means updating all of our entity draw functions. But so let's say we want to draw our enemy. His draw x is equal to his x, which is 450, minus. Now for this one, to get the difference here so that he draws, hang on, let me set up a new little thing. Here's render screen, okay? Render. You can see the orange boxes around here. I kind of want to see him like this with my guy in the middle. Whatever. Alright. I want to see this get rendered and not this part. That would be bad. So I want to see the new region get rendered. So to get that positioning correct, it's pretty easy. That's why I set up this invisible camera in the first place. I draw everyone's x who's on the screen at their current x position minus cam's x. Oh, cam x. And same for draw y, which is he's at 50 minus cam y. So let's put those numbers in. I'll help it out. So cam x is, where's the cam x at the moment? 370. And cam y is at 50. So we draw this guy at, this is where I should have, did I not calculate this? No. It's alright. 450 minus 370, 80. Good. So 80 across, and then 50 minus 50, that's easy, 0. So his position with relation to the window and not where he is in the world, we draw him at 80 and then 0 down. So that's there, where he is. Now you apply that to everything in the world, and that means as the camera gets updated, it updates their draw positions. So hopefully the math didn't get lost on you there, but it's okay. You'll see it in code anyway. Cool. So I'd apply the same math to our hero here as well. So his draw x is, we'll go through it one more time, why not? So that's this guy. Let's do this, guys. Draw x is equal to 570 minus 370, which is equal to 200. Oh, we know what it's going to be. It's going to be half of the camera. He's always in the center, but I'll go through it anyway. And his draw y is equal to, what's his position? 150 minus 50, which is equal to 100, which is half of this. Didn't have to mathematically work that out, but yeah, he's always kept in the center of the screen, so his position is basically, his draw x, draw y is always going to be 200, 100. But we'll still apply the same rules to calculate it, just in case we decide the camera follows someone else and not the hero. Alright. Good. Okay. Next lesson, let's jump into some code. See ya. Hey, welcome back. Alright, so like I said, we're going to move on to the camera code. So I also mentioned that I haven't done an update on this course for 2 years, so this is all new bonus content, not part of the original package, so I figured I'd add more things. Because it's been so long, make sure you're working with the same base code as me, I suppose. So I went to the challenge section, downloaded that zip, Cyborg Battle 11 final build and bug fix, and that's what I've got running now. So it's probably be quite loud, but here we go. You get the idea. Anyway, it had the blue guys and the red guys in it, pretty much. The globs and grobs to attack you. So I'm going to continue from that project. Now, this camera, you saw in my example theory stuff that there's this hypothetical rectangle representing where the camera is. It just helps to actually build that so that you can visualize it. Now, this thing needs to be referenced from everywhere, so I'm going to chuck it in. Good old globals. Just going to chuck it down here. So globals.h static.stl rect camera. So rectangle just has an x, y, width, height. Whenever you declare static stuff inside of a class, you've got to initialize it somewhere. So I've got to go over to globals.cpp as well. And I'll put it down here. Hold on. So STL rect globals camera. Easy. Okay. By default, probably everything's set to 0, so the width and height of our camera won't change. So what I'm going to do is I'm going to set those up inside of our game class. Let me just jump to my little cheat sheet. Okay, so can you go to game.cpp? It already knows about globals. And yeah, this is good enough before we load everything up. So in our games constructor, I'm just going to set our basic stuff for our camera up. So setup camera globals camera x is equal to 0. So that's sitting at the top left of the screen initially. Y is 0. The width is equal to the screen width. That's the reason why I store all this stuff, is because if I want to change cameras size and everything and windows and all that stuff, I just update like just screen width and updates it everywhere. Same for this guy here. Whoops, my bad. Screen height. Done. That's all well and good, but all we've done really is just add a camera, but it's not going to ever move and nothing else is referencing it. So let's see. I think I want to update all the drawing stuff next. How about we leave that till the next video? I'm supposed to be doing shorter videos according to Udemy, so let's try that. Next time we'll update all our draw functions. Hey, alright, we're back again. So, I said I was going to update all the draw functions for our entities and things so that they get drawn with relation to our camera. So first up, that's going to have to be entity. So I'll go to the header file just so I can jump around a bit easier. Header file. So we're in entity. For entity's header file, go down to draw. And if you don't know this shortcut, I'm guessing it's different if you're not in Visual Studio, but if you're a Visual Studio guy, F12 would jump you to the implementation of it, which is heaps handy because I can't bother going through this entity.cpp file. All right, here we are. So in entity.cpp, I want to update the draw function. So F12 was that shortcut. All you had to do was click on the name of the function somewhere and press F12. It'll jump you across. If you press it from here, it'll take you back to the header file. It's handy. Back, forth, back, forth, back, forth. F12. If you're on a laptop, it'll be like function F12. Anyway, we're going to update our draw. So it's pretty easy. We got this X and Y here that we try to draw our character at. All we got to do is, if you remember my maths from before, it's at their X where they are in the world minus the camera's X. And same for Y. Their Y of where they actually are in the world, but we'll draw them after we've translated their position based on the camera. Cool. All right. That wasn't too bad. We got to do this in more places though. So next one will probably be living entity. So let's go to living entity next. We're going to be doing basically the same thing. Where's its draw function? Right at the bottom. Good. We've got to do it in a few places here because they've got the white sprite sheet and the normal one. Everything else is just drawing rectangles. Okay. We can do that. Here we go. Here we go again. Minus globals camera.x minus globals camera.y. And the same for this guy down here. Replace its x and y with x minus camera x and y minus camera y. Great. I think that was all of our entities. We only made those two classes. But there's some more annoying places where we put things. So in game, where is it? Ah, yes. All right. We also want to draw the background with relation to where things are moving. Now, because the camera's moving, we want the background to move too. So that image, if we don't update that, it'll look really weird. It'll mean that the background stays in the same position, but the whole world moves around it. So remember that background art is, let me go in, I'll show you. What did I even call it? Map? Yeah, this. So if that didn't move, but the rest of the world moved around it, it'd be really off-putting. So we've got to update how we draw that as well. So that's inside of game. Game, draw, and where is it? After the splash stuff, draw background. Here it is. I've got it at just 0, 0. So instead we're going to get 0 minus globals, whoops, camera X, 0 minus globals, camera Y. Same idea. It's X and Y just happen to be at 0 all the time. Let me check. I'm sure there's somewhere else. Yes, there is. No? I think that's it. Great. Just double check my cheat sheet. I'm pretty sure everything's been updated. Entity, living entity there. Great. Done. Okay. Now if you run this thing, nothing will be different. We don't have the camera following the player yet, so the camera still sits in the same position. Wow. Great. I was getting ruined there anyway. So it should run, nothing should break. So far, so good. Alright, so the next thing we're going to build is going to be a camera controller, and I'm going to do that in the next video. Alright, see you soon. Okay, here we go again. So we're going to add a camera controller this time. Something that'll update the position of where our camera is. So, make a new header file, add, new item, header file. And we're going to call this guy camera controller. Put that stuff down there, it's in the way a bit. Okay, put these things in if not defined camera controller. I know there's a shortcut that does the pragma thing for Visual Studio guys, but at least this is what do you call it? Cross-platformy. If and def, yep, it's fine. Yep, good. So this will make sure we don't recompile the same file multiple times if we've included it in multiple other header files. All right, it needs a reference to globals because that's no, not those guys. Globals because we need to access the camera, and we also need access to entities because it follows entities around. I've made it entity rather than hero so that you can make it follow enemies around if you really want to. Camera controller. Okay, so it's got some basic things. It's got entity pointer called target, and we just make it point at the things we want the camera to follow. And let me see, do I actually... Oh, I do have something in there. I didn't realize I did this, but I thought I just kept the camera exactly on the center of the player, but it turns out I've added a little bit of interpolation stuff to it too, so it moves to the character position rather than just teleport always on it. So I've got lerp in here, so this is how fast kind of does it move over to the target. And an update function. Great. So far so good. Alright, next we need a CPP file for it. So add new item, C++ file, yep, CPP, and call it camera controller. Whoops, yep, there we go. It's got to include its header file. Great. And we start filling this in. So void cam controller update if target is not null. Great. We're following someone. So if target is null, else don't follow. It's up to you if you want to reset the position back to 0, 0 for the camera. I just left it wherever it is, so it'll just stop updating the position of the camera if there's no target. But anyway, in this update section, if there's a target, my target X is equal to targets X minus, now remember we want to keep the camera positioned on, we have the hero halfway in the camera. They're always halfway across, halfway down. So it's that dude's X minus half the camera width. And same for the Y minus half the camera height. So here we go. Globals camera width divided by 2. Thanks to math precedence, divide comes first, so this section will get done first, and then whatever this adds up to be, it's going to minus it from the X over here. And we're going to do the same over here. If you don't trust math precedence, you can always put brackets around it. You want to make sure that half happens before the minusing. But we're good here. Yep. And the Y value is going to be the Y minus half the camera's height. This is to get the camera's like top left position of its like region that it's viewing. So it's got to be like half away from the hero, so that the hero is in the halfway point of it. Alright, now move to target position. Globals camera X, oops, plus equals, so we're going to add this to it. I'm going to put some more in here than I was expecting to put. I was just, in my head, I was just going to set it to target X and target Y, but I forgot I added this stuff, so I might as well add it in. So target X minus, oops, globals camera X. It's sort of like where I want to be minus where I am, and then use math to and time to move it over there. Yeah, like so. So it'll proportionally move us over there based on time. It's kind of good. It'll kind of do nice easing over there if your character moves suddenly quite quickly. I don't think we'll notice because the stage is so small, but same idea for Y. Flip. Great. If I don't add extra letters, great. Excellent. That's all it needs. Pretty simple. Now, this thing here is going to be added to game. So we've just done the definition. We want to actually build an object of this thing. So go to game.header file. And we've got to include our new camera controller at the top, so it knows about it. Camera controller, there we go. Make sure you add this. And somewhere down here, doesn't really matter where. Camera controller, cam controller will do. And we've got to set this thing up. So there's a few places we've got to update to make this whole thing work. So it exists, but currently it's pointing to nothing, and its update function is not running. So we've got to do a few things. So let's go This is going to be in the constructor. In our constructor, after we build our hero, which is, here's our hero. Yep. After we build our hero and push him to the list, get camera to follow hero. So we use our camera controller. Oh my god. Alright. Camera controller dot target is equal to hero. So make this pointer point to the same thing as this pointer. Great. Still won't do anything until we run cam controller's update function. And that's going to be way at the bottom of update for game, which is going to be heaps far down. Let's see. Right before draw. So in our update function, we're going to add update camera positions. And hopefully I didn't miss anything in all the code that we've done, because we get to see how good it is very shortly. There we go, update camera positions. We're updating where we are. Great. Okay, let's give it a go. Let's see how this is. See, it worked. Great. If we don't update, you'll see what I mean. Running around. But when I've got that update thing on, you can see the gray areas outside of our map. My map is still set to the screen size, but that's okay. If your world was bigger, you could actually go and explore it now. So I'll run it with the update thing on and try to look for the gray around the edges. Cool, alright. And that's all I was going to do for this. So we got a camera, and I thought it was just going to be basic, but it even like shifts its way over to give you some nice kind of movement on the camera, rather than just like constantly being fixated on the hero. If you wanted it to be totally fixed on the hero, that's pretty easy. Instead of doing all this stuff, you would just do camera X is equal to target X and camera Y is equal to target Y. If just lock on hero, no movement. I'll show what that looks like. We got time, I assume. And back to the one that I built before with you guys. See here. See, the one that I got with the movement, it takes a little bit of time to catch up, and it kind of eases in. This one's very intense. Alright. Good job. We'll go into something way more complicated next. See you soon. Hey, alright, we're back again. So, next thing on my list of new updates is update collisions. More efficient. plus better. By better, I mean more accurate. So I'll show you what the old one was doing. Do you remember? We had like a guy, a wall. He'd be moving so fast that his next X and Y should be here. So what I was doing was going, alright, I'll multi-sample this guy. Does he hit anything here? 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 Oh, he does. So let's go back to the previous one where he doesn't. And then bounce or whatever we need to do. It was a bit tighter than this movement, but you get the idea. This is not so good because the multi-sampling thing is not terribly efficient. And I knew there was a better way of doing it, but I couldn't find a nice example online that helped explain it all. So moving away from multi-sampling. Yeah. And we're going to move to a new one. Not new, but new for us. We're going to move on to this thing called swept AABB. And I'm going to include the article that I got all these references from. It's this guy here. It's on gamedev.net, written by Brendan L.K. He's got this amazing write-up of swept AABB collision detection and response. And so more or less I'm just going to be implementing what he's written here. And he explains all this stuff way better than I probably can. So we're going to have this as our reference article. This part here, AABB, you can look it up. There's going to be nice ways to explain it as well, but it's just a nice, quick system of checking, does one box overlap another box, and if so, therefore it's colliding. If you're not overlapping something else, then you can't be colliding with them, right? So it's kind of a quick test for that. It's very efficient to run. Now, the thing with that is, if your character's moving from A to B, so he's here, and then he's here, and then there's a thing in the middle, like a wall. If he's going to move that quick over one, like, render cycle, you want him to actually bounce off here, right? Or whatever he's going to do. You want to do something about it. AABB on its own only checks against two stationary things, but what we're trying to do is we're trying to move through space and time. So that's where the swept part comes in, and this is where the math gets way more complicated and a bit beyond me for explaining it. But like I said, this article goes into way more detail. We're just going to try and implement it. I'm just going to talk about the gist of it, but it's kind of goes, well, if I can do this, if I can work out an overlap between two things when they're not moving and they're just like in their static positions, then I can sort of sweep that logic across from where I am to where I'm going to be. The good thing about this is the algorithm that's written up for this thing works out at which point in time from point A to point B. Let's say this is 0 and this is 1. It'll work out where that collision happens. So in this case, let's say it's like 0.3. And using that 0.3, we can go, all right, we've tried to move this far over 1, then we'll only move like a third or something. And then we can work out how we're going to deal with collisions from here. The algorithm that he's got also lets you know which side of the thing that you're hitting. Also handy for working out which way to bounce off stuff or slide against stuff or whatever. The way we're going to deal with it is instead of bouncing, we're going to use slide. So when we hit stuff, we'll slide down it as much as we can, but we'll lose a bit of speed as well. So you go hit and then slide down instead of ending up here, which is heaps wrong. Cool. So our guy will end up, say, here instead. Great. Good. Teeth. Alright. I'll put that article up if you want to read into it in depth, but more or less we're going to try to implement that thing in our system. So it's going to be a little bit different to what's in the example there, because their thing just has one thing that wants to move, one thing that you're going to bump into, and then how to test it. Our thing has lots of things that you can bump into, so my implementation is going to be more based on how our current project works. Alright, cool. I'll talk to you soon for code stuff. It's going to be intense, so good luck. See ya. Alright, let's get on to this collision thing. Like I said, it's going to be big, so I'm going to split up across multiple videos. Let's start off nice and easy. Let's update the entity header file. Scroll up to the top. Now, we're going to need to reference two other things for this thing based on the that solution that I found online. So they use the limits header file and algorithm. So you'll see, they'll come up. I'll point out when they're needed. Limits kind of gives you like the max size of variables and stuff. And algorithm, I can't remember where we use that, but I'll point it out when we use it later. Alright, now let's update entities header file. I can add a few things in here. So we got, do you remember how we had collide with solids, true or false? That's still useful. I'm going to add a new one. So this is new. Die on solids. We don't have anything that does that yet, but later we will. So when something hits something, if this is set to true, then it'll die when it hits a solid. So I'm thinking of things like bullets and stuff. When bullets get shot and if they hit a wall, you want them to disappear. So that's what this is in here for. Useful if you need entities to die on touching solids, e.g. bullet hit wall. Yeah, so that's that first one. Just this, nice and easy. I'll go to the new one there. You don't need that. Oh, but we need the bull. There we go. Alright, next one. We're going to add a few functions. So scroll down. And virtual void crash onto solid. And it currently does nothing. This is in the case of that other thing that I put in there. So if die on solids is true, then this function will deal with the dying. however you intend for your thing to die, this will take care of it. Our helper functions, we're going to add some new ones. We're going to add static float, swept AABB, and it takes an SDL rect, which we'll call moving box. It takes a float. I'll just do Vx and Vy so we can see everything, but Vx and Vy is velocity x, velocity y. How fast we're moving on the x axis and in which direction, and same for y. It's a bit different how we've been moving around in our game. We've been using angle and movement speed. This one is pretty much considered, if it's a positive value in Vx, then you're moving right on the screen at that amount. And if it's a negative value, say -2, then you're moving at -2 so that means you're moving to the left on the x-axis. We didn't really do our movement system that way, but they've implemented this particular system this way, so we're going to take advantage of that. We got SDL rect other box, so the thing that we'll crash into. And hang on, my cheat sheet is quite a long method. Oh yeah, and we got these two things, float normal x, and float normal y. Now, these are passed by reference, so we'll give it the variables that we want. We want this function to populate with values. So remember, pass by reference passes the whole variable in, and then it will update it for us as it comes back out. Now these normals, this is to help work out which side of the other box we're colliding with. So pretty sure it's got it as 0 means we're not hitting any side of it, negative means the left hand side of the box, positive means right hand side of the box for normal x, and normal y is very similar for 0 being nothing, and then minus probably being up and positive being down, but I can't quite remember. But basically it's just some way of measuring which side did we crash into. Okay, we'll build that guy later, he's quite a long function. And we need another one, another helper function. We got all these distance things, distance between two rects, two entities. That's great, but we don't have one for just checking 2 points. Don't know why. I should have made this basic one ages ago. Distance between 2 points. Whoop. Float. CX1. Float. CY1. Float. CX2. Float. CY2. Great. And that is all we need to do in the header file for the moment. So we're good. So we added distance between 2 points, swept AABB. So I'll show the whole method here. Here we go. And up the top, we got limits, algorithm, and excuse me, the die on solids as well. Great. Cool. All right, we'll start implementing this stuff in the next lesson. See you soon. Okay, so last time we set up the header file with some new functions and I think one variable. This time we're going to start implementing it. So first one up, that's swept AABB1. It's huge. So to make your life easier, copy this much of it, not the static part. So copy that. And then if you jump to where distance between two rects was using F12, we're going to stick it just before that. And make sure you got entity on there. Great. Cool. Now this thing is huge, and like I said, that article is going to explain it way better than I can. So I recommend looking at that, but for the moment I'll point out what things are. So return type gives 0 to 1 depending on where collision is. 1 means no collisions. 0 means collide immediately. And is halfway, etc. So it's going to give back a value between 0 and 1 of how far that square, the moving box in our case, gets before it collides with some other box. And if it doesn't collide at all with this other box, it's going to return 1. If it collides with it as soon as this function gets through it, like immediately, it's right next to it, it returns 0. If it's somewhere else along the path, it'll give a point value. I'm going to use that to help calculate how far we should move our box before we deal with response. Let's fill in the next part. Our parameters. So we got moving box is entity being checked. I guess I'll do it this way. Vx and Vy are the velocities. Our moving box is moving at. We got, what's the next thing? Other box. Other box is some other entities. Collision box we may collide with. And normal X and normal Y. Let us know which side of other box we collided with. These are passed by reference. So if you're not savvy with passed by reference stuff, look it up. Most variables, as you can see, don't have this little ampersand in front. So they're passed by value. You copy a value into it, but when you do pass by reference, you pass the whole variable in. So any changes you make on this thing here is affecting the thing that you passed into the function. So look into that if you're having trouble with pass by reference. It's not the default, so play around with it. Look it up. It's very useful. Anyway, let's keep going. Float X. Now this stuff I'm not going to be able to explain that well as we go, because it, as I said, it goes over my head a little bit too. I sort of get the gist of the theory, but then each part of this gets, I don't know, it's a bit complicated. The article goes into this stuff in more detail, like I said. Alright, so these things here kind of work out the exit and entry points of when moving box crashes through other box, and we use it to help work out which side it sort of hits. It's kind of weird. Anyway, First thing, find the distance between the objects on the near and far sides for both x and y. So if Vx is greater than 0, so it's positive, means that the box is moving to the right, then we'll check this. So x inverse entry is equal to other box dot x minus moving box dot x plus moving box dot width. Great, cool. Next one, x inverse exit is equal to brackets other dot x plus other box dot x plus other box dot width. This just gives you a basic distance between certain sides of our boxes here. So this one's going to give you the distance of the left-hand side of other box to the right-hand side of my moving box. And this one gives you the distance between the right-hand side of other box to the left-hand side of my moving box. Else, it's going to be sort of similar, but swapping things around a bit. So x inverse entry is equal to other box dot x plus other box dot width minus moving box dot x. Just kind of swaps which one it checks first, which one it puts in which. So if you pass through something, you go through an entry point and come out the exit point, but depending on which way we're moving, we're assuming that if we're moving to the right, our entry point is going to be from the left-hand side, and then our exit point will be on the right-hand side of other box, and this just swaps it. So if we are going left, entry point is going to be on the right-hand side of other box, and so forth. So it's kind of weird. Just roll with it for the moment. Exit. There we go. And other box dot x minus pretty much this goes into here, this goes into here. Just swaps which one gets set to which variable. Okay, so we do that with for x, we do the same for y. Well, cheat sheets going into sleep mode. That's always handy. I was thinking of copying and pasting, but that usually runs into other problems. How about we just type it out? Oh, no, other box dot y minus moving box dot y plus moving box dot height. And then Okay, same deal. Just basically just swapping x's for y's and widths for heights for this axis. And then better just double check this, because if there's something goes wrong in here, it'll be quite annoying to track down. Y plus height. Yep, good. Other box. Great. Yeah, cool. Alright, let's keep going. Cool. Alright, so bracket other box dot y plus other box dot height minus y. Cool. Alright, great. That's only part of this massive function. So let's keep going. Alright, next section. Find time of collision. Sorry. Yeah, find time of collision and time of leaving for each axis if statement is to prevent dividing by 0. So as you know, dividing by 0 is not a good thing, so we're going to put an if statement in here to deal with that situation. So that'll be in here very shortly. So we got x entry, y entry, x exit, y exit. Similar to before, but without the I and v in there. Alright, so if vx is equal to 0, we don't want to divide by 0 because the maths we're going to do is going to involve that. This is where we use the limits thing. So we go x entry is equal to minus std numeric limits float infinity. Copy that. We'll use it a few times. Not the minus though. But here we go. Let's keep going. X exit is equal to there. Else, so we won't be dividing by 0 in this case. We go x entry is equal to x inverse entry divided by vx. See, if this was 0, we'd be dividing by 0 here. That wouldn't be good. And the x exit is equal to x inverse exit divided by vx as well. We're going to be doing the same thing with vy as well. I might actually copy paste here. Be very careful. Copy, paste. Change all your vx's to vy's. Change all your x's anywhere to y's. Cool, got it? Great. Now, with these things going on, we're going to find the earliest / latest times of collision. So float entry time is equal to std max, and I guess this is the algorithm part of things. X entry, Y entry. This will just return the bigger of the two, X entry or Y entry, and then exit time we're going to use min. So this will just find the smaller of the two things that we're passing it. Give me the biggest one out of these two, give me the smallest one out of these two, and store it against each of these things. Great. Alright. First case, if there was no collision. That's if entry time is greater than exit time. So it basically means that exit times whatever, where is it here? If that's smaller than entry, that means we've never exited anything within this time span. So if that's bigger, then we couldn't have hit something, but we have to check all the things. Or X entry is less than 0.0f, and Y entry is less than 0.0f, or X entry is greater than 1.0f. If it's at 1, that means we've gone across. Remember, 1 means we've traveled the whole distance, because we're going to give a fraction of how far they got our moving box against our other box. So if it's 1, it means got the whole way. If it's 0, nowhere. If it's less than 0, then we've got a problem. So it's anything between 0 and 1, pretty much. Or, this is a long if statement. Or Y entry greater than 1 as well. It's big. If there's no collision, then normal x is equal to 0. So no axis. Well, no normal, no x normal, no y normal. So remember, normals are the sides of our box. So and if it's 0, it means we haven't hit any side of the other box. And we're going to return 1.0f. 1 means moved full distance, no collisions. Else there was a collision. So if all that doesn't get picked up, then yeah, we hit something. We're almost there, don't worry. Cool. So we should work out which sides / normals of the other box we collided with. So which side of other box did we hit? So if x inverse entry is less than 0.0f, so if it's less than 0, then normal x is equal to 1, normal y is equal to 0. Just put 0 in there, it's fine. Else, so we're saying that if the x inverse entry is less than 0, then it must be hitting it from, I guess, the right-hand side? I can't remember what each of these represent, but it's okay, we'll work with it. Else, normal x is equal to -1, normal y is equal to 0 again. I actually missed an if statement in there, my bad. Hang on. We should work out which sides that was. Yeah, sorry. There's been an if statement around this whole thing. So if x entry is greater than y entry, then we're assuming that we've hit on the x-axis. Yeah, then we can work out which side. 0 being not hit top or bottom of other box. And I think 1 is hit right hand side, but I can't remember. Hit left hand side. I could get this wrong, but anyway. Else, there's a big else to the x entry, y entry, so this one assumes we hit other box on y-axis, and by that I mean we must hit the top or the bottom of other box. So if y inverse entry is less than 0.0, normal x is equal to 0, normal y is equal to 1, else normal x is equal to 0, normal y is equal to -1. Great. Okay, then finally, after all that, this stuff just works out the normal part of it, normals. Otherwise, return the time of collision. 0 to 1, e.g. There we go. Oh, it's big and convoluted. Don't worry. You've got that other stuff to read up on. We just push through it. We sort of get what it's trying to sort of do, so we'll keep persevering with it. The whole point of doing all this system, even though it's a bit of a head wraparound situation, is to make collisions way more efficient. So this is the most complicated part, I guess, this function here. So if you sort of get it, then you're doing kind of good. Anyway, we'll keep going in the next video. See you soon. Alright, we dealt with that massive function. Now to a much easier one. So let's go to header file and distance between 2 points. Nice and easy. We'll copy this much of it. Float, name a function, parameters, don't worry about that semicolon. Now I want to stick it just before this angle between two entities function. So jump there, paste our definition here. Don't forget to add class namespace up here in front of the function name. Good. This one is nice and easy to type in. So just using basic distance math. This stuff's not too bad. So float d is equal to absolute of whatever's going on, square root of pal cx2 minus cx1 to the power of 2 plus pal, I might put some spacing in here to help, cy2 minus cy1 to the power of 2 semicolon. So we got I know, it's spaced it out pretty good for me. Okay. Absolute, if you don't know, basically just knocks off any negative value, negative sign off it. So it'll just give you just a whole just the positive number of it. So if it's negative 49, it'll just give you 49. Here's a little formula for working out distance, which is old school kind of stuff, so it's handy, so it's nice and easy to work with. Good, and return that. Done. That's all we had to do for that part. Okay, nice and easy. Now the next thing that we're going to do is update collisions function. We're going to do that in the next video. It's good to have a nice short video. Have a rest. Let's get ready for the next one.